Hello, everybody. Good morning. It's so exciting to see here again, one in the last day of Architecture Software Summit. So please tell me where you're from because it's an amazing opportunity to talk, to share knowledge, and get awesome networking. And today we will have several presentations with amazing content where you are able to share your knowledge, your share your experience with us. Okay, let's start. Uh, Remember you that 100% of everything of Geeko this conference will be donated to Ukraine. Okay, so it's a dangerous time. We look to more peaceful, and Kiko is doing its part on that situation to make the place safer with the idea. So help Kiko to help Ukraine doing that. And before start, let's talk about edge computing architecture with a senior solution architect at Red Hat. With you guys, Saru Ashad. Hopefully, I say your name correctly.
Hi, yeah, this is Saurabh Asthana. Hi, glad.
Okay, I'm glad. Usually, I don't do it correctly because the name is so hard. So it looks an amazing presentation. Let me share your screen here.
Thank you.
And please, could you introduce yourself?
Yes, thanks, Octavia and Nick and Senior and the whole team behind it. In this crazy time, you are still keeping up the show, and this is, I mean, seriously, hats off. Yeah, let's hope everything is better soon. Uh, I'm Saurabh Asthana, and I'm the senior solution at Red Hat, Netherlands. And I'm an open source enthusiast. I think Octavia, you spoke about open source with a Red Hatter yesterday. It was nice talk, by the way. Uh,
Oh, thank you.
uh, yeah, and I'm basically part of the telco and media entertainment vertical at Red Hat, and my main role is helping specifically the telco customers, onboard their cloud journey, so around the private public and the hybrid cloud journey. So yeah, today's discussion is about edge computing and architectures. So I think we can start now.
Yes, yeah, this is yours.
Yeah, so what we're going to discuss today basically is about, let's say, the high level introduction of edge computing. What is edge computing, and why is it required, and why now? And we'll dive a bit deeper into what are the whole paradigms of edge computing. How does 5G and multi-access edge computing, also known as MEC, helps with edge computing? How do they fit together? After that, we will discuss about the top use cases and the business driver behind those kind of use cases, and who's doing the edge computing in today's world, and where and what business verticals it's going in future. We'll also discuss about the challenges in implementing and specifically getting started with edge computing, and after that we will discuss about a bit about the architecture and the design principles and patterns around this whole edge computing. Yeah, if you have questions, keep those coming in the chat, and we'll take it also. Let's say if we have time a bit later in the session, and also we have a dedicated Q&A session for that. Yeah. Sorry. So, if you look how the infrastructure technology has been evolving over the past few years, you will see that this whole cloud thing is coming up. It started a long time ago, but organizations are still moving in that direction, and you know there is whole paradigm of the centralized cloud computing. So, against this whole principle of centralized cloud computing, one thought which has been bouncing on and off is, why does, let's say, a request needs to travel hundreds or even sometimes thousands of kilometers away back to my centralized data centers when the response has to come back to the same place? What if, I could localize my compute power to near in the proximity of where it's actually required, and why hog the bandwidth going back to the data centers? What if I could do a lot of computes locally and in the near vicinity of where the actually it's required, it's the response. So edge computing is basically bringing the computational power, the compute capacity near to the source of data generation, near to the users, near to the sensors, and also devices, so that it handles first, let's say, the latency requirement. So if there are, let's say, high demanding use cases, high demanding application sensors, which require low latency or near real time response time. So it's better to put them towards closer where they are required rather than hundreds of kilometers away in the data center. And the second is, if we talk about, let's say, the data which can be analyzed or computed upon, uh, needs to be a bit smart, and needs to be picked up smartly, as in, what kind of data you require to be actually computed, let's say, in terms of analytics, and what kind of data you require to compute to have an actual response in the near real time. So if we talk about, let's say, for example, autonomous driving, so an autonomous car can generate 5 gigabits of data per second, which will be, let's say, if I want to transport it back to my core data center, it will be a huge bottleneck on the network. So in a research, it was estimated that, let's say, 10% of the data can only be transmitted if somebody tries to transmit whole data coming from, let's say, general purpose interfaces from the sensors or the cars or whatever. They can transmit only 10% of the data back to their core data centers, and rest remaining 90% is going to waste. So what if you could, build some kind of local intelligence in what kind of data you actually want to transmit to your centralized data center, and reject, the data which you don't need, let's say, for analytical purpose. So you will have the smarter and the concise data, the data fit for your use case for the business, actually going back to your data centers where you can do centralized analytics on it. Yeah. And the remaining data, which, for example, is not fit for the use case and coming from general purpose interfaces of the devices, the end devices, the sensors, etc., you can reject it. And because the sensor will not be based per use cases, sensor will be having a general purpose interfaces which will be emitting, let's say, tens of fields or parameters, out of which, let's say, two can be useful for your business case, and let's say two for other business case, maybe 10 for analytics. So yeah, so you can smartly choose which data you send back to your centralized data center, and which data you can process locally and respond locally in a near real time. Yeah. So this is basically what edge computing is: moving the compute power closer to the devices and the end users. If I talk about what edge computing holds, let's say, in terms of the framework. So basically, it's just two elements. One is the core data center, and the second is the edge compute devices. But depending upon what kind of data you want to aggregate at what layer, you can have, let's say, multiple tiers in the edge architecture. So if I go from left to right in the picture, so it's decreasing compute capacity, but it's increasing the response time. If I go towards the left, from left to right, near my core data center, it's high in compute capacity, but less in the latency, less in the response time. So here is in the extreme right, there is the core data center, which will be, let's say, a customer service provider, or let's say cloud providers, let's say core data center. Going towards the left, you can may start reducing the footprint of the edge compute, and in the center there is provider edge, which is basically the service provider facility or service provider assets used for computing. And you go further left, you have the end user premise edge, for example in the factories, the hospitals, or we'll talk about also mobile edge computing later on. So the thing is, if I mean, in future there will be billions and billions of devices and sensors which will be generating enormous amount of data. All the data, I mean, from all these data, some of which needs to be responded in real time, and that action can be taken, let's say, from the device edge or the on-prem edge. And this device edge and the on-prem edge can also be responsible for filtering out the data which can be sent back to the next layer. And this can have the intelligence to send some data which require a bit more of computational power or analytics to the provider edge, or reduce, let's say, the amount of data and send it directly to across your core network to the provider, to the core data center, to the central data center. Yeah, so basically, we talk about edge and fog computing. So fog computing, I mean, they are basically the same. The fog notion was basically in the past was derived basically for the aggregated nodes in the edge tier, usually at the center, and in the extreme left, the device edge was they were basically forming around the devices which were generating the data. So the device edge is really, let's say, the sensors, mobile phones, etc. So everything that has a computational power but is also generating some data is called as, let's say, the device edge. And every edge device is basically what is generating, let's say, the large amount of data, or some lot of edge devices generating lot amount of data. So every edge device is not a device edge, but every device edge is an edge device. Let's just put it this way. So if we move further, we discuss about, let's say, the role of 5G, and what is multi-access edge computing, and how does 5G plays a pivotal role in this whole technology. So 5G has not been like any generation of mobile, what we've seen before, jumping from 2G, 3G, 4G, we have now 5G. And if we look about what the 6G specification coming up, it's not gonna be boiling kind of an ocean, but the jump from 4G to 5G has been enormous, specifically in terms of, let's say, millimeter wave, high bandwidth, low latency, and things like enhanced mobile broadband, uh, massive machine type communication. So 5G is really a kind of a paradigm shift coming to the generation of mobile technology. So 5G is aiding, let's say, the low latency part, device to device communication part, ultra high bandwidth part, in terms of what it brings along with the technology itself. Uh, MEC, also known as mobile edge computing in the past, but now renamed to multi-access edge computing, is basically when you add the factor of mobility to the regular edge computing. So, what if the device which is generating that data is on the move? For example, automobile for the car, aeroplanes, and the trucks, the fleet of car management and the truck management. So, what if we add a factor of mobility to the regular edge computing, it becomes, let's say, mobile edge computing or multi-access edge computing. So, in the previous picture, you saw how the tiers were built. Now, in this, you see there is also a green layer in between, also called as the telecom edge, uh, where you actually install or put the compute power directly at the radio sites or the cell site, directly at the base station of your cell sites. What it's doing is it is providing yeah, sorry. So what it's doing is it's providing, let's say, the mobility factor to the edge computing, and location awareness is another thing which is coming along with the mobile edge computing. So this and the enhanced capabilities of the 5G is what is kind of match made in heaven for multi-access edge computing with 5G. So if we go from left to right, the devices are kind of increasing in thousands to millions and billions. And the same in what we discussed in the previous picture, the compute power is going up from left to right, and the response time, the latency is going also low from right to left. And there's one principle. So because there can be management overheads if you manage too many devices at the edge. So there is principle which says centralized where you can, and distribute where you must. So depending on what kind of use cases you're offering and what kind of quality of service you are trying to deliver to your end customer, there needs to be kind of a conscious decision on the number of layers, the number of devices you put on each of the layer, and let's say the proximity and the distance from the end users. Yeah. So so we spoke at a high level about what is edge computing and how 5G and multi-access edge computing are kind of making it a reality. I mean, this has been in design and thoughts for a long time, but now it's already happening, and customer service providers and the organizations are kind of implementing it already now. We will see more growth in it when also 5G rolls out, let's say, across broader horizon across the whole world. But yes, the use cases that we see, they're kind of endless at this moment. There have been around 150 recognized use cases. But yeah, I think we have only begun to realize what's possible with edge computing and MEC. So if we talk about edge computing use cases, so they are primarily derived. I mean, the main business driver for doing the edge computing is the latency requirement and the bandwidth requirement. You should be able to respond in near real time to some of the use cases, and you should also be able to process the relevant information in some use cases. So, if I look about who is doing edge computing, they're all kind of businesses now involved in edge computing, and it makes sense to have. I mean, it will only be a few years before it becomes kind of a de facto standard for along with the centralized cloud computing. It will become a de facto standard for let's say the distributed computing. So all kinds of enterprises, let's say remote offices, and in-field operations. For example, if I go to let's say a grocery store, there will be a scanner, a handheld device which I can scan my products and then do the billing at the end. So those kind of data doesn't need to travel all the way back to my central data centers. They can be processed directly at the remote location, remote office, and the billing and sorry and the billing and everything can be done directly on site. Telco, for what we discuss about the the multi-access edge computing, and like kind of a use cases of having private 5G for enterprises and everything. So they would be using edge computing heavily. Then we talk about, let's say, the sensors and the controllers. Let's say for security and access management, etc. So that finds use there. Video surveillance. I want to maintain security and let's say real-time video analytics fee of let's say a, a face or something like that. I want to block. I want let's say the security unit to mobilize based on what happened in the video. That is a highly likely use case. Let's say for the smart city and all these things. Connected car, trains and planes. I mean, they were I mean, these are the first thing which will be, kind of implemented, or at least sort of implemented for the edge computing. Uh, Self-driving cars. I mean, if you do kind of a general calculation, the response time between a human and a self-driving car, 300 milliseconds or 3 milliseconds, can really make a difference of the stopping distance of a car from 300-meter to 3 centimeter. If this is a basic calculation, but these are the things where the low latency and the near real time response would be really beneficial in this whole use cases, for these kind of use cases. uh, Trading sensitive apps, for example. I want my data which is generated, let's say, at a location A, processed at location A without leaving the boundaries of, let's say, a perimeter where it's not considered safe. uh, I can do kind of data processing on site, response and on site. I don't need to send it out of let's say the secure zone. Healthcare monitoring, let's say the patients in the hospitals, we can do real time monitoring of the conditions and the response time based on if something deteriorates. So yeah. So there will be multiple and many use cases in years to come, but they will most primarily be derived by the need for speed, the latency, and the bandwidth. So what you can send and what you should not send to the local data center, and not hog or congest your network. Yeah. So now you would say, it's nice, and everything is fine, and I think this is the future. But how should we get started, and what are the first thing we need to consider, and what are the challenges at this moment? What how we should address those? So the scale is the challenge. The scale at which the edge computing will be done has a kind of a never before scale. So there will be challenge to manage that many of nodes distributed across the different tiers of your edge architecture, edge network. So that is one of the concern that needs to be handled. Interoperability. So there will be vast variety of the hardwares, the devices, the sensors, and the infrastructure, the software that needs to be deployed across the whole landscape of edge computing. So how would they work together? So would there be kind of a common standard between them, or how do they how you can guarantee that each of these things work together, at that scale? Uh, Consistency. I mean, there will be different footprint of deployments across the different tiers in the edge architecture. There will be different kind of application deployed across those different footprints. So how would you maintain kind of a consistent and homogeneous framework for maintaining and managing that bigger scale of edge deployments? So we uh, we have been thinking about around what would be the best practices and in the architectures and the patterns around the edge deployment and how to get the user started. But before we get started on that, the edge deployment will be really customer and use case specific. Or you predict that your line of business or your model is going to go this way. You want to you want to provide that kind of services to your customer with that level of quality and that kind of quality of service. But you would like to ask first the questions: what do you want to achieve from your edge business? If you look at this thing around, let's say specifically around 5G. So customer service providers and the telcos around the world, they are spending in billions to implement their 5G technology, but they will not. I mean, the end customer, like you and me, the mobile user, they will not be charged extra for 5G as a technology. So how do the businesses need to make money? So there will need to be a new business model along with that comes with 5G. And luckily 5G enables the new lines of businesses and new use cases. So but before going into that, you need to ask the questions like, what are my service goals, what kind of use cases you're trying to address, and what kind of hit you take, let's say in terms of latency. I mean, is it really critical, is it really important, and what kind of quality I want to guarantee to my end customer. Second is my platform already edge ready? You don't have a platform, you don't have an edge platform yet, but you want to extend, you want in a some way to connect it to your centralized data center. But your centralized data center and your current platform should also be edge ready, or at least in a way to be that kind of platform. You cannot have, let's say, a legacy architecture or a legacy platform, running on physical machine somewhere in, let's say, on a silo directly on a physical machine, and without any cloud native features to implement edge and extend it to edge. That will not work. Second thing is, do we have the necessary skills? So there would be new skill required by, let's say, the organizations and their workforce around, let's say, the edge management, the edge deployment, and that also comes with that kind of scale. So how would my current employee base, my current skill set in my organization be willing to fill this gap of edge computing? And the last question that you need to ask is, what do we need to build ourselves? Let's say the architecture, the assets, the infrastructure, or the application itself on top of it, the network, whatever. So once you have these kind of questions, answered, or to an extent, at least you're thinking in that direction, there will be a good chance that you're doing it first time right. Uh, we at Red Hat, we have kind of an open hybrid cloud strategy. So what we propose to our customer, and also the customers have been onboarding this strategy, is you should be able to deploy any kind of workload, let's say a virtual machine based workload or a containerized app, any kind of cloud native app across any kind of infrastructure, like on-prem cloud, public cloud, or even in public cloud, what kind of public cloud, or Google, Microsoft, or AWS. You should be able to deploy it across all kinds of clouds, all kinds of footprints, with a common homogeneous way of managing it, and at that scale. So that is important, because even if you have, let's say, even if, I mean, organization with a considerable size will not be deploying only on, let's say, a private cloud, on-prem, or let's say only public cloud. Organization application will be scattered over, let's say, public and private cloud, their own data centers here and there. Also now in the device edge, enterprise edge, all kinds of edge tier. There needs to be a common way of managing it with a single pane of glass, and with a homogeneous way of managing it. So we have this hybrid cloud strategy, so you could deploy any workload at any footprint, at any location, and at any scale. uh, so if I talk about achieving those things, deploying anything anywhere, we talk about cloud native paradigm. So when your application and your infrastructure and your way of working is, let's say, truly cloud native, then it would be a bit easier to manage things at that scale. So when you talk about cloud native, containers come really to the, let's say, the first thing in the mind. And why would containers make sense also at the edge? So basically containers make sense now, I think, almost everywhere, not just at the edge. So what you can do, container, the degree of freedom that you get with using containers is like magnanimous. You can have new application deployed, let's say, easily. They run everywhere. You can update, deploy them at scale. You can manage life cycle at the scale. and they are lightweight, so they are kind of ready to be. You can make your containers really lightweight, ready to be deployable on, let's say, a smaller footprint, or wherever you want it to be. You can orchestrate between various edge tiers easily once, if you're running containers rather than something like a virtual machine or something like a legacy application. So that really makes sense to have containers also at the edge. uh, Now, what we do, let's say, containers and Kubernetes is, Red Hat OpenShift is the enterprise Kubernetes by Red Hat. And we have kind of various flavors of deploying containers across, the different kind of footprints that we have, big footprint or small footprint. So it can be, let's say, a big fat cluster like what is running in your centralized data center. It can also be, let's say, a smaller cluster, or a three-node cluster where you don't need, let's say, all the bells and whistles of, let's say, complete cluster with three masters and multiple workers. You can have, let's say, a three-node cluster deployed at, let's say, your regional data centers, and smaller compute capacity data centers. You can also have, let's say, remote workers where you have, let's say, a common control plane sitting at the central data center, but you are deploying only the worker nodes at the remote sites where you don't have that big a footprint. You can also have, let's say, a single node server, so single node cluster, where on one node you can have, let's say, a worker and, let's say, the control node running together, single on one node, like really on a small footprint device. So these are the different things which Red Hat OpenShift makes possible to deploy container platforms across different footprints in a different sizes. So yeah, but how are you going to manage that kind of scale? So with we have kind of a unified management system called as Advanced Cluster Management. So it can manage different kinds of Kubernetes platform along with OpenShift across different infrastructure, public or private clouds, and it gives kind of a uniform management tier with, let's say, homogeneous ways of managing across multiple clusters that you can have. So this is what we have. You can get in touch with me if or Red Hat if you want to know more about it. Really, this is kind of a 2 or 3 hour session. We can explain more. So I think this was it. Also, if I try to summarize, so this is what we discussed today. That what is edge computing is. It's basically moving the compute closer to the source of, where the actual data is generated, and where the actual users are. It can reduce latency, and do smart bandwidth management, and kind of selective data processing, etc. 5G with new capabilities like ultra reliable, low latency communication, enhanced mobile broadband, and massive machine type communication is well suited, and kind of, like I said, match made in heaven for realize the edge use cases. And edge is becomes the natural choice for low latency and bandwidth aware use cases. Uh, so you might ask me, edge is already happening. For example, if you've heard about things like narrowband IoT, which draws, let's say, a narrowband from an LT 4G cell sectors, and talks to a low power sensors in, let's say, industry, etc. And you might as well say, look, I if I'm driving on a highway and I want to, let's say, stop at the next gas station, I can look in my mobile phone in Google that, okay, this gas station is kind of a bit crowdy. There are a lot of people stopping at it. Maybe it's not a good idea for us also to stop at that gas station. Maybe they take the next one, which is, let's say, 200 kilometers away. So these things happen, but let's say in Google services or in your map, it will not tell you that this area is crowded, because there's really kind of some kind of malfunctioning, it's running its capacity, or there is really, let's say, a good restaurant in the petrol station where everybody's stopping for a while longer than actually they need to fill their gas tanks. So these kind of analysis and computational or intelligence can be brought with edge computing at the side. It is happening already, but not with that real time and low latency kind of thing. It's so yeah, that is what is bringing additional to what's happening today, and other than multiple other use cases that we'll realize. Uh, the architecture would be use case specific. So, like I said, it can only be, let's say, cloud centralized data center and edge devices based on, let's say, if the use case is smaller. But the architecture and the layers needs to be devised and designed a bit smartly, as in what kind of data going from, if you remember the picture, going from left to right, what kind of data you would want to respond back in real time and filter there, and what kind of filtered data you want to send back to your centralized data center for, let's say, later analytics. So this needs to be, these are the few considerations which needs to be followed when thinking about designing an edge architecture. uh, if we go here, I have collected some further reading materials where if the last link is actually the patterns, what are the common patterns which we have validated at Red Hat, and these links are basically diving a bit more about the edge technology, the mobile edge computing technology, and the edge infrastructure technology, how to realize it, let's say today and in 5 years from now. So have a look. This is it, I think, from my side, and thanks a lot for listening. And I hope to get some questions now. Or
Yes, indeed we have. Is edge computing and architecture directly linked with underlying cloud architectures?
Yes, to some extent it should be, but not, let's say, in kind of a hardwired kind of way. So it should not be the case that your edge computing architecture is totally relying on a cloud architecture. There can be some kind of backward connectivity. There should be to your centralized cloud architecture, but it is a bit easier and future proof if your cloud architecture is flexible enough to extend to edge architecture.
Okay. Hey everybody, it's a time to write your question right now. So if you have any question, doubt, yes, indeed will have a QA session, but you have this time here to have a conversation. So let's wait. Give once, give twice. Let's see. Give one, give twice, and sold. So thank you. It was an amazing presentation. Thank you, Red Hat.
Me,
Thank you, Sarah. Saurabh.
sort of, yeah, very close.
Saurabh. Okay, thank you. And see you soon in the QA.
Yeah, thank you. Have a nice day, everyone. Bye.
Bye bye. Okay, let's move on to our next speaker. The next topic will be architecture thinking, aka how to run independent. With principal software architect, with you guys, we have Zenedic. Oh man, hopefully I say your name correctly. Hello.
Hello, can you hear me?
Yes, I can.
Okay. Thank you. Uh, just do you see my presentation?
Let me see. No yet.
Okay.
Yes, one. No.
Now you
This
should
one
be able
here.
to see my presentation.
Okay, right now. So, thank you. The stage is yours.
Okay. Thank you, Otavio. Hello everyone. Before we start, I would like to say thanks to the organizers that did a great job, despite some of them had to leave their homes or hide in a shelter. My name is Zdenek, and I work as a software architect in Heron Hego, and I'm founder of BIT lecturing and consulting company. And in today's or in my presentation, I would like to speak about architecture thinking. And because architecture itself and architecture thinking is a quite vast topic, I will try to demonstrate it on a product we were building in last year. So what is a software architecture? Some say that software architecture is stuff that is hard to change. I will go with a little bit more conventional definition and say that architecture is some high-level structure of our code that is hard to change. But now the question is, how do we wrap our mind around such complex structures that are hard to change and where every change is very costly and also not only costly but also can break a couple of things. One of the approaches I'm going to use in this presentation is to compare software architecture to a map. Similarly, as a map, uh, Similarly as a map helps us to find the location of some places we want. A good software architecture can help us to identify location of bugs of code that we want to change. For example, let's say we have a bug in user input validation for a specific domain. A good architecture allows us to look at one place and find the bug there without looking at the rest of the code. We don't need to search whole code base. Maps exist in various scales, and similarly does also software architecture. This is something that is called software level abstractions. And it's often drawn as this pyramid, where in the bottom we have code, we have our methods. On top of that, we usually have classes or some functions and design patterns. On top of that, we have organization of modules. Above that, we have application architectures such as domain-centered, domain-driven, DDD, microkernel, and so on. And at the top of that triangle, we have a system architecture where we can discuss integration of various systems and so on. Ideally, what we want to do when we are talking about design and architecture, we want to design our application or build that architecture, build its structure, draw those maps independently on each layer. So when we are designing, for example, designing our modules and their dependencies, we should not look at the classes or know much about the classes that are at the bottom. When we are designing architecture of our application, we should not know much about implementation of the modules. There's a simple principle that allows us this, and we all know it. It's encapsulation. Just to remind you what encapsulation is, the encapsulation is process of this is definition from Wikipedia. I find it really terrifying. But in simple words, I would say that encapsulation hides unimportant details and publishes reusable important parts. And of course, what I'm trying to say is that encapsulation is not a principle that works only for classes, as we were taught at school. It works for modules, layers, applications, and whole systems. So does this mean that we can build any system or any set of well encapsulated maps? Of course, no. As we could see throughout this conference, the topic is very complex. There are various aspects going into it. We can design our architecture based on organizational structure. Of course, we also need to think about time that we have for the solution. We cannot deliver ideal or the best solution with limited time. And we also need to look at the non-functional requirements such as performance, scalability, data consistency, and also something that Neil Ford called in his talk called vulnerability. Uh, this means that we want to reduce future changes. Don't get me wrong. Uh, of course, our software needs to evolve, so we will need to make code changes. We will need to change architecture. We will need to redesign stuff, but we want to reduce unnecessary changes because every change brings additional work and can break stuff. And this is what I will focus on in my talk the most. I will be talking about architecture mostly from this point of view. Because talking about architecture can be very abstract, I'm going to show this on an example of a product we were building in last 1 year and show you some of the challenges or some of the principles we use to design this product. But first, let me give you some quick introduction to the product or the products. 1 year ago, we were asked to basically turn multiple desktop applications for live broadcasting or video management to a web-based system. The cornerstone of this system is some playout application called Prime, which can do multiple things. It can switch between cameras. It can do audio mixing. It can add graphic. It can add images, and so on. When we looked at architecture of this application, I found something like this. What kind of architecture is this? Is it pipes and filters? Is it microkernel architecture? It looks like it has layers, so it might be layered architecture. But if it is layered architecture, what kind? Is it domain-centric? Is it data-centric? I don't know. When I really looked at it, it looks like it has layers. But usually, when you look at layered application, it doesn't look like this. I mean, it doesn't look linear like this. Sometimes the architecture of layered application looks like this, like a triangle, like a rectangle. But more often, it looks like a triangle. Why does or why layered application usually look like a triangle? To explain this, I will help myself with almost forgotten principle from code clean architecture that is called the stable dependency principle. And it basically says that in our application we have multiple modules, and some of them we want to be easy to change, and some of them by their nature will be harder to change. But first, what does it mean, stable? Stable here means stability in terms of code changes. Let's say we have two different modules, X and Y. X depends on three other modules, A, B, C, but Y has no dependencies. On the other side, A, B, C depends on Y. Very often when we are making code changes, we change one package, one module, one service, one class. It doesn't really matter. It's not module specific. It leads to changes in other parts of the code. So for instance, if we change module A here, it usually means, or sometimes it can mean that we need to make a change to X. Similarly, if we change B, it has no effect on Y, but we will probably need to change X. So it means the module Y is more stable and X is more vulnerable to a change. And this is why layered applications that are built like this usually have a triangular shape. Let's say we make changes to the bottom layer, to one of the modules at the bottom. These are more stable because they have no dependencies, at least in this diagram, and we make a change in it. It often means that we need to make a change to a module above it, to a domain, and so on, also to presentation. If we change persistence to module, it again will mean that we need to change domain A and presentation X, and similar. So um, the bottom modules are the most stable, and those above it are less stable. Now we have to ask a question. Okay, so we know that some of the modules are less stable, some of them are more stable, but which of them should be stable? Usually, the modules that we want to have stable are modules that contain core logic and reusable code. These modules usually contain logic that makes our application unique. Which might be domain logic, but in some cases, if our application is focused on performance and if its main selling point is performance, that it's doing something the fastest on the market, then it might be the module that doesn't really contain that much domain or business logic. But it can be this one because it contains the logic that we value the most, and we don't want to make changes to it just because someone changed the package. Okay, so this was some theory why layered applications usually have triangular shaped architecture. But let's go back. Let's look at architecture of our layout application. So it has a linear shape. There's nothing wrong about it. It means that there are not many dependencies, which is good. But when we took a closer look at the modules, we found out two problems. The first problem is that layers are not separated. One module very often had the presentational and domain logic, and domains were often mixed. So it was hard to tell where is which logic. We didn't have time to solve both, not that we didn't want to, but we had to identify which of these problems is more important, is more crucial to us. And because we want to turn a desktop-based application to a web-based system, we decided that the more important problem for us is that layers are not separated. Why? Because if you have mix of domain logic and presentation logic, it brings a couple of disadvantages. Let's imagine that for some weird reason, our domain code calls presentation desktop logic that opens a dialog window. So if we want to build a service that will serve data to front end, this means that this dialog window will most likely block whole service. Also, it brings lots of dependencies on stuff that we don't really need, dependencies on UI libraries that we don't need, and they also have dependencies, and so on. And it's hard to upgrade, for example, to new versions of the frameworks when we have these dependencies, because it means that we also need to upgrade dependency for desktop libraries and so on. So the first problem we decided to solve is to separate layers. Let's say layers got separated. It's still a work in progress, but it was working, or it's working for us quite well right now. And now we need to deal with the second problem, and it's that the domains are mixed. Because if we want to build something on top of this application, we want to build another presentational layer that will provide some web services to our front end. It's very hard to do a good design when the rest of the application doesn't have it, or at least doesn't have design sufficient for us. So what we did, we came up with something like this. Uh, Now it looks like a triangle, not as a rectangle, but this is just to demonstrate you what we came up with. We basically created a new presentation layer with web services. We created a layer with domain, and at the bottom, we created layer with adapters. And the goal of the adapters was to split the logic to sensible domains and to separate us from the code that is being refactored at the moment. This is something you might know from book domain-driven design, and it's called anti-corruption layer. And of course, we do not want to have this at the bottom of our application. We want to improve it. We want to refactor it and to change this to a better design. And the purpose or the goal of anti-corruption layer is to do this part by part. So what we want to do is to slowly move this anti-corruption layer down to the application and move mixed logic to the adapters that are domain specific. So this was one of the challenges at the beginning, and we got design like this. Another challenge that arrived are notifications, because we have a web frontend and we want multiple users to use this frontend, and also one user can have multiple tabs in his browser open. And because this application is for live broadcasting, we need to be real time as possible, and we don't want one user to change something and another user to have old version of it. So we always need to keep all these tabs and all the users up to date. So we needed to introduce some notifications. The flow was following. For example, one user changes something on a front end. It sends a request to a web service. Web service then calls domain. Domain does some magic, and sometimes it publishes a notification. The notification can go from domain back to web service and back to front end to all the users and all the tabs in the browser. But quite often, one domain also needs to call another domain, which might lead to another notifications. So from this, we saw that we need some kind of notification system that will prevent dependencies and that will allow us to send notification from domain to web service, because build time dependencies are web service to domain, not vice versa. So this approach that you can see has two problems. Domains have dependencies, and domains need to send notification to web services. Of course, another approach would be to send notifications from domain to web service in another domain, but this makes it even worse. So let's focus just on these two dependencies. We have a web service module and domain module. Domain contains some notifications that need to be sent to the client. How do we turn this? How do we allow domain to send some notifications to web services? Or we can ask in general, how do we get rid of this dependency? Or how do we turn this dependency, which is very often what we need to do when we are doing some refactoring or redesign? The answer is very simple. We separate something that we can call notifications, but very often abstractions, or in some cases contracts. And this allows us to break this dependency. We can generalize this and say that separating abstractions or contracts breaks dependencies, not only for classes, not only for modules. It works similarly for web services or whole applications as well. So, okay, we will need to separate these contracts, these abstractions from our domain layer. But if we have multiple domains, and these domains have dependencies, it will lead to something like this, which is not a desired design. So what we did, uh, we basically introduced publisher subscriber queue to publish notifications to break all these dependencies. So the domains are not affected by changes by other domains. And we created some module or some modules that contains all these notifications, which very simplified the dependencies. The final design could look like this. Just one domain publishes some notification, and other domains or other web services can react to it. You've probably seen a similar approach, but not for in-process communication, but probably between microservices or something like this. Again, we can generalize this. Even queues or message queues simplify dependencies by aggregating abstractions and contracts. It's a very similar approach as the previous one, when we needed to break dependencies by defining some abstractions or contracts. What this does is that it basically creates another abstraction on top of abstraction. We say this module or this queue or this service is responsible for having all the abstractions. So this aggregates all the dependencies for us. But it all comes with a cost. It is important to realize that even queues, even though they are very useful to break dependencies, they bring indirections to our system, to our application. Which means that sometimes it's very hard to predict what application does or what a system of microservices does. I will give you an example. If we have a domain, one domain calling another, and then another, and then another, when I come to you and ask you, what happens when I call this web service? Then you will simply go to a source code and you will see, okay, web service is calling this domain is calling another domain, and you can give me a list of stuff that happens. With events and event queues, it's more difficult, because when I come to you and ask you what happens, you will tell me it produces an event, and then you need to search all the code or even multiple repositories if you are using multiple repositories for microservices, and to search all the places that are using this event. So this should be really used with caution. Okay, now we got to a state where we had one application working. It was well encapsulated. We could say, okay, this is its responsibility. It does these multiple things. We don't know. We do not need to know much about its details. Our another challenge was to integrate replay application paint. It's a very interesting application, as you can see on this video. It can do lots of stuff. It can create clips and replays. It can add illustrations. It can track players, and so on. And again, it was a desktop application. So we got these working parts. We have frontend that has server-side rendering and is using web services to communicate with both of these applications. If you are interested in the technology, we use gRPC because of performance reasons. We have some storage or to be honest, multiple storages of assets. What is an asset? It's a graphic that you can include into a video. For example, a list of players or some infographic. It can be clips, it can be images, almost everything that you can insert into live broadcast. And we somehow needed to integrate this. And for example, one of the use cases we needed to support is that a user goes to front end and he creates a clip. And this clip is then visible in playout application that can include it to a video. Clip is being prepared by Paint, by the replay application, but is used by playout application prior. So the first approach could look like this, or first two approaches. Frontend could go to replay, say, okay, create me a clip. A replay application says, okay, I will create a clip, I will save it to the storage, and I will notify playout. By notification here, I mean to call a web service in playout to tell him there's a new clip. We can do this vice versa. Frontend can go to replay, it will create the clip, save it to the storage, and playout can check replay application for newly created clips. But is this a good approach for us? It is not. The reason why it is not is that we still want a replay and playout be reusable by themselves. They still should be in the independent applications. So it's very hard to tell which logic of these should be more stable. They both need to be very stable, the most stable in the system. So it means that they should not have dependencies. So both of these approaches are wrong. Okay, another approach is that front end on the left side will ask replay to create a clip. Replay will create a clip, will send a response to front end, and front end will then go playout application, say, oh, there's a new clip, you can use it. Actually, this showed to be a quite good approach because front end had to get the response from a replay anyway, and the response contained most of the data it needed, and it already has dependencies on replay and playout. So we can keep both applications separately. We are not adding another dependency to front end, and this will work. However, for multiple applications, if we had multiple applications there, not only replay, playout, but multiple other, this would mean that front end would turn from front end to some kind of coordination layer, which might not be desired, because front end has some logic by itself, and very often my recommendation would be not to combine logic and dependencies. If you have something that has lots of logic, it should have minimum of dependencies. Another approach would be the same as we used for in-process messaging. But instead of creating queue in one of these processes, we could use some known message queue, for example, Kafka, RabbitMQ, something like that. So frontend would call a replay, it would create a clip, and it would publish a notification. Playout would then check the notifications, and it would find out that indeed there's a new clip and it can be used. This approach can be okay. However, there are some downsides to it. We decided not to go with this approach at this stage when we had there only two services, because this would bring, basically another service, another application to maintain, which would be the queue and in direction to the system. But now we are getting to a phase where we don't have two applications. We have five, we have six, and we are going to integrate eight more. Oh, sorry, we are going to get, I guess, to eight applications. And in that scenario, it's not feasible for frontend to coordinate everything, and the queue looks like a good option. But again, it's important to realize advantages and disadvantages and to know what is cost of this. We were facing a similar situation with other applications. For example, we have a configuration service that provides configuration to replay and play out. And the question we had to ask is, okay, we have a service that unifies configuration for replay and play out because they both, for example, need to use the same video transport protocol. So should this application depend on configuration service or not? Or should it be vice versa? Of course, we want to have this vice versa. Configuration service is very simple, doesn't have much business logic. It stores configuration and it tells all the part in our system to it tells all the parts in our system what their configuration should be. What I was trying to demonstrate is that thinking about these dependencies um, is usually the same if we are talking about classes and if we are talking about modules, layers, application, and applications. If there is any recommendation I would like to give to you is don't let your dependencies control you. When you look at your design, and it's not important what scale of the design is, if these are classes, modules, or services, every dependency should be justified and direction of every dependencies. You should always ask, does this dependency need to be there? What does it bring me? And does it have a correct direction? Very often when I see some legacy systems and I open their architecture or some design, it has some weird dependencies and nobody really knows why it is there. Or dependencies on modules it should not need, but it does. And dependencies just themselves can tell you, for example, that some modules do not have or services do not have well-defined purpose. What also I would like to stress out that managing dependencies in your system and in your architecture becomes more and more important the higher you get in software level abstractions. Because for classes, you can easily change it. For modules, it will take some time, but you will change it. But it's still, these are still only code changes. But when we get to application level, to microservices and so on, to change dependencies will be harder and harder, and to maintain them as well. Because now we are not talking only about code changes, but about the DevOps infrastructure, about deployment management. Because if one service has dependency on another, it probably means that when one changes, you have to deploy or you have to develop a new version of the second one and deploy both of them. So please do not let your dependencies control you or your architecture. Thank you.
Hey. We are back. So we have a couple questions here. The first one is about your slide. Do you mind if you share your slide to us?
Sorry, what shall I share?
The slides. We need just the link.
If I can share the slides. Yeah, I can do that.
Yes.
I don't have
And
it uploaded anywhere right now, but I will, I think, upload it
okay,
before Q&A.
thank you. And can OpenShift be used to build on-premise Kubernetes cluster?
This is a question to me.
Yes.
Uh, I guess so, but sorry, I don't have real experience with this one.
Uh, but anyway, you're gonna have our head person next talk. So everyone, if you have any question, that's time to raise your question, to fire your question. That's an amazing opportunity to talk about architecture thinking and how to run, about modules. And by the way, every time I talk about architectural map, what I saw in my mind was C4 model. So it's a nice way to,
Yeah, that's the same. Yeah.
yeah.
For
So
those of you who don't know what a C4 model is, it's these are basically maps, or you are looking at the architecture at different scale.
yes, so interesting. So if you don't have any questions, thank you, Zeneski, Zenedik, or
Zdenek,
Zenek,
yeah.
and see you soon in the Q&A session.
Okay, thank you. Have a nice day.
Have a nice day. See you soon. So right now we're gonna have one more speaker, and then we have our Q&A session. I'm not sure if Rafael Cordona is here. Um, Let me see. Okay, Rafael is still working to stay here. But anyway, if you have any questions about architecture, I try to give feedbacks to the answers. But anyway, we still have the QA session. Yesterday I talked about cloud native. How can you take your application and move your application to the cloud, especially in the highest level when you talk about multi-cloud application where I don't have any vendor lock-in. I decrease the complexity, so this way I'm able to use Amazon, Google Cloud, and Oracle Cloud. Both are at the same time. Or if something goes wrong in a vendor, I'm able to use another one instead. And the whole session, at least most of that are on YouTube. So if you want to know more, you can watch several times the presentation. And to me, it's an amazing opportunity to learn as well more about these topics, especially because at least me, I usually watch this presentation twice, third time, to understand better, to process it in my mind. Okay, and it's a good way um, to solve any kind of discussions or to learn and finally apply this concept in on production. One second. Don't worry, I'm gonna fix it soon. So the next presentation will be Open Data Hub, a data and IA platform for Kubernetes by Rafael Cardona. Oh yes, finally one is name to spell. So hopefully he'll be here in more 2 minutes. So see you around. It's an amazing time to you. Relax a little bit, take 2 minutes break, and then we return. Hello, hello everyone. We are finally back. So let's do the last presentation of this moment with a cloud solution architect at Red Hat. He will talk about Open Data Hub, a data and AI platform for Kubernetes. Uh, this person is Rafael Cardona. Hello, Rafael. How are you?
Hi guys, how you doing? Good afternoon.
Good afternoon. It's nice to see you here.
Thank you,
And
thank you.
finally, I'm able to speak your name easily. Uh,
Okay, it's
t-
pretty Spanish. Eh?
yeah, the Spanish one. Okay, so um, let's move to the next step. So please share your screen and then the stage is yours.
Cheers, man. Second.
Okay, don't worry. And just remember, okay, right now we have
Here
your
we
screen.
go. And second. Banana.
Okay, let me return. Yeah, some technical issues where Rafael will
What
return
you
soon.
what you cannot see me?
Okay, okay. For now it's okay. Please continue.
Okay. Okay. Okay, guys. Let me start this. Okay. First of all, thank you guys for being here today. My name is Rafael Cardona. I'm a senior specialist solution architect for Red Hat. My domain is OpenShift, and I see that you cannot see my screen very well. Hello?
Yeah, it looks like your screen sharing is not working properly. Sorry.
Oh my god.
Can you probably try to share just a tab of your browser instead of your full screen? That could
Sure.
help.
Okay. It is a bit better. Okay. It looks like it's decent now.
Yeah, it's loading. So let's see. Hopefully it will work right now.
From this side, it looks fine.
Yes, maybe if you do a refresh, so it
Okay.
stop to sharing and then share again because it's still loading, loading, loading. However, it does not show anything to us.
Yeah, Rafael, you chose window sharing, but you should choose tab sharing,
Tap
just a tab
share.
of your browser. Oh, you are still sharing your window instead of browser tab. So yeah, you should either share your tab browser or just upload slides
Only
from here in the app.
I choose share, then share screen, right or not?
Yeah, share screen, and then there should be a third option if you're using Chrome browser.
I'm using okay. I need to use Chrome browser because I'm using Firefox.
Oh yeah, if you do you have Chrome? Yeah, sorry, folks, we didn't do a tech check with Rafael.
Sorry, guys, it's all my fault. I opening that right now in Chrome.
Yeah, sorry, just a few more minutes.
I'm using Chrome now.
Oh, nice. Hopefully it will work.
Okay, share the slide. Yeah, much better now, guys.
Oh, yes, much better.
Excuses, it's all my fault, guys. I didn't do
Don't worry. It's
the
happened.
okay. Well, again, Rafael Cardona, Special Solution Architect in Red Hat. I'm very pleased to be here in Gecko. And today we're going to be talking about the Open Data Hub. It's an open source project that is backed by Red Hat. And yeah, we're going to jump into agenda straight away because I already took 10 minutes of the whole story. Okay, I'm gonna give first a short overview of what is Open Data Hub about. Then we're gonna go a little bit deep in the technical part. So what is in fact Open Data Hub? Then we're gonna jump into the operator part. That is where I explain how is done, how the magic of Open Data Hub occurs. And the fourth is a very short demo how easy it is to install Open Data Hub. Okay, we go to the overview. Okay, first of all, I'm sure most of you are professionals in this environment, and you are pretty familiar with all the concepts. But I need to start to explain the concept from the system engineer's point of view. I'm an infrastructure engineer who happen to do OpenShift and happen to help data scientists to do the job. So I start to define what a data scientist is from my point of view. So data scientists are highly skilled professionals that do complex data analysis. They do that by creating machine learning algorithms and models. An algorithm in machine learning context is a procedure that runs on data to create a machine learning model. In a nutshell, a model represents what is learned by a machine learning algorithm. The model is the result that is saved after running a machine learning algorithm on training data. And it represents the rules, the numbers, and any other data structure required to make predictions. But data scientists do not work alone in the wild. In some cases, they do some ninja work by themselves. But in enterprise environment, they need to collaborate with different stakeholders. And one of those predilect stakeholders, companions, are the system engineers, where I fall. System engineers are those hidden heroes that are in charge of preparing the needed infrastructure for the tasks that the data scientists perform. When a data scientist requests an artificial intelligence tech, the system engineers understand other words. When a data scientist requests a AI system, a system engineer here, we need hardware, we need the network, we need operating system, we need patching, we need security. All in all, these stacks deliver delivers in two main identifiable features for the systems, and those are platform integration. Um, as mentioned before, an artificial intelligence platform is by nature stack. It is rarely composed only by one application. In fact, I have never seen a system of artificial intelligence that's only one application. So, when a set of applications mean to be integrated in an orchestrated ecosystem, there is some plumbing that needs to be taken in account. Version control, resource management, multi-tenancy, storage, and a couple of more that are always present. And you should think that it is only about making it work. It's not even talking about the artificial intelligence part. But after a system of this complexity is deployed, the minimum that is expected is that it is enterprise ready. What is enterprise ready in this context? It means monitoring is in place, logging metrics, resource usage, authorization and authentication, performance tuning, disaster recovery, and so on. And that's what we're going to be talking today. The way that we, Red Hat, are helping our customers and partners to address these challenges by means of Open Data Hub. Okay. Okay. Open Data Hub means primarily two things. First, it is a metadata project. Metadata projects are often called toolkits because by themselves they do not provide any application service. Instead, a meta project serve as an umbrella for integrating a set of underlying applications. In the case of Open Data Hub, it provides a comprehensive artificial intelligence platform stack. For some applications, some of those applications are Apache Airflow, which is an open source workflow management application to create data pipelines. Kafka, Spark, Apache Subset is another one. Argo, very important. Jupyter Hub, the most important of all. Then Prometheus for having eyes and vision on what's going on in the cluster, and Seldon, which is a multi-language framework accelerator to scale machine learning models on Kubernetes. But I will detail them a little bit more in the coming minutes. Further, Open Data Hub is also a blueprint. This is a key differentiator with traditional artificial intelligence platform infrastructure. When I say artificial intelligence platform infrastructure, the traditional way, I mean servers and virtual machines, because the key differentiator starts, or the inception is because it enables system administrator and users, which in this case are the data scientists, the end users, to manage, create, delete, modify, and deploy complete artificial intelligence stacks via a single platform, programmatically, scalable, performant, and on demand. The ecosystem, but there is a problem here because I'm jumping. Okay, and jumping when I click one slide, I jump two. Okay, then this is another slide. One slide. Then we go to the part of components. Here we're going to talk about only the software components, the so-called the middleware, because Open Data Hub is a project that enables the machine learning stacks to run on enterprise Kubernetes. We will not care about how that target infrastructure is being provided to the middleware. we just care that OpenShift that job for us, and we just concentrate in the component that help the Open Data Hub run and host the application needed in the artificial intelligence stack. The list of components that I see there, the first would be Airflow. This this is an engine that enables configuration, scheduling, and execution for complex data pipelines. Apache Kafka is used to build real-time streaming data pipelines and real-time data streaming for applications. Apache Spark is a powerful processing system used for big data workloads. It utilizes a memory caching and optimized query execution for fast analytics queries, again, data set of any size. Apache Superset is quite useful. It's an easy to use business intelligence tools that collect and process data in large volumes, to produce visualized results like charts and graphs. Argo CD is an open source container native workflow for Kubernetes. Grafana, that's also quite important in the context of visualization. Grafana allows you to query, visualize, alert on, and understand metrics no matter where they are stored. Create, explore, and share a dashboard with your teams, and drive a data-driven culture. Jupyter Hub, that's the most important of applications that compose the Open Data Hub. It is a tool that serves a Jupyter notebook for multiple users. It gives user access to computational environment and resources, address of multiple installations, and it's simple abstract of the complexity of running a multi-tenant environment. Prometheus is a tool that collects metrics in the form of time series data for node and store them. Seldom is another key component of Open Data Hub. Seldom is an open source platform that leverage the core building blocks of machine learning, and it is designed to streamline the data science workflow with audit trial, advanced experiment, continuous integration and deployment, rolling updates, scaling, model explanation, and more. That we're gonna jump to the ecosystem. We have built an ecosystem around Open Data Hub that enable our customers and partners a faster go-to-market strategy. This ecosystem provides tools for tight integration with Red Hat products such as Red Hat OpenShift, Red Hat OpenShift Data Foundation, that is enterprise storage for Kubernetes, the Red Hat Decision Manager, the Red Hat OpenShift Service Mesh, that is the SDN for microservices and OpenShift and Kubernetes, and the Red Hat 3Scale, that is the API management product that Red Hat offers. To showcase this integration, we build multiple industry use cases, showcasing Open Data Hub integrated with Red Hat products such as fraud detection and Open Data Hub and the Red Hat Decision Manager. We also work with third-party vendors to get them certified to use the UV images, and certified operators. Certified partners provide support for their tools integrated with Open Data Hub, such as Seldom for model serving. As part of the ecosystem, we also have a team dedicated for AM, ML consulting service to help our customers to succeed into their transformation and into digital transformation plans and accelerate development and time to market. Okay, all in all, what problem it solves? It is painfully known that artificial intelligence computations required a significant amount of resources. Outside the context of containerized environments, artificial intelligence stacks have been initially deployed on virtual machines or, in more expensive use cases, on dedicated bare metals. The more venues that adopted the system, the more expensive the infrastructure become. A very common example is the misuse of artificial intelligence models for high performance GPUs, for example. In this case, they are physically placed on a server. Therefore, they cannot be shared across nodes. It means that computations need to be queued in some cases, and in other cases, that expensive resource, the GPU, is left idle, and that can be translated into waste of money. The idea of containerizing artificial intelligence platform is pretty similar to the idea of containerize any other enterprise platform. It's about integrating the extensive resource management and enterprise capabilities of Kubernetes that Kubernetes can offer. In the specific case of OpenShift, it does not only maximize the resource utilization and reduce the infrastructure costs, but it enables artificial intelligence platform to be resilient, to be infrastructure agnostic. When I say infrastructure agnostic, I refer to the target infrastructure. It can be public cloud, it can be hybrid cloud, can be private cloud, and GitHub capable, pluggable, extensible, and all in all, providing out-the-box monitoring and be part of a wide ecosystem that I mentioned in the previous slide. The operator. I refer to all components that can be deployed with the Open Data Hub. However, for you that are familiar to Kubeflow, you might be wondering how this is done. First, what is the relationship between Open Data Hub and the Kubeflow? You can see Open Data Hub as a Red Hat own initiative of running Kubeflow on steroids, basically creating a highly reliable tuned Kubeflow instance on OpenShift, addressing all security implications that demand running this type of workload in production, and managing the operator who will take care of the complete lifecycle management. I'm sure that for those that have interacted with Kubeflow and its complexity, you are wondering how big of an effort it is to get Kubeflow running on OpenShift and why we do even need Open Data Hub. Our goal is to get Kubeflow adapted to our OpenShift best practice that the Kubeflow community might not have as top priority, but for us and for our customers, that's a key changer. For example, some of the things we have changed till now are the operator and the operator lifecycle management itself are back. The target of using namespace of wide use Kubeflow use cluster-wide permission. That's quite risky when you do that in production environments. The fact of using a default service account to install all the components, running container with root privilege, that's mitigated with the KF serving. Another one is the restricted users IDs and group IDs. Implement the finalizers in the operator. That's a big difference. The file system access issues that we completely mitigate in the Open Data Hub. We eliminate the Docker dependencies. The KF pipelines are one of them. Another key element that is a differentiator is the existence of mutating webhooks and injecting containers. And very important as well is monitoring. Is the integration of Prometheus and Grafana. Now we get to the point that you ask, okay, it is all done, and that is probably the best part of all. How it is installed? Well, Open Data Hub Operator does this for you. The complete lifecycle management of operators and the instances is not part of this presentation. You will have a presentation on operators, I believe, in a couple of hours. We're gonna see how it is done, but functionality will be explained by Werner. Let me find the name of my colleague. There will be a colleague explaining that from Red Hat soon. But anyway, to keep in mind that operator is a piece of it's an application running in Kubernetes, but in this case in OpenShift, that abstract all the complexity of treating an application as a first-class citizen in a Kubernetes ecosystem. Go to the part of the demo because time is kicking, so we're gonna do it fast. I install this cluster out of the box. Okay, you can see this pretty new cluster. We don't have anything installed. I don't know if any of you have installed Kubeflow before, but when you see this, you might be a little bit impressed how it's possible that you deploy a complete artificial intelligence stack that is backed up by an operator, means full cycle lifecycle management with a few clicks. Well, that's the way we do in Red Hat. We go to the operator hub. Then here there is a huge number of operators. Some of them are provided by Red Hat, some of them by the community. We choose the operator. We read the description. By default, it will always install the latest version. In case you need to work with older version, you need to do with a different type, a different version of the CSV. Keep the defaults. The default was fine. It normally takes between 10 and 20 seconds to be ready. Okay, then you go to the operator. First of all, we create a new operator. I'm gonna call this a Kiev University. University, we choose the operator, we create the instance. By default, all the stanzas are included, but this is a huge amount of applications. Not all of them are needed, depending of the type of application of the artificial intelligence workload you want to run. You're gonna be needing them, but we're gonna use the smallest set for the sake of simplicity. Seldom node, superset node. It can be gone. We will not be using Kafka, Grafana as well not. We are not in production. Prometheus as well not. is important. This is very important. This is more important of all. The notebooks. Airflow norm, Argo norm for GitOps. With this, we got 4 stanzas. That is more than enough for a simple, good open data hub. And then we go to networking, the routes. You get a bit. They already created, but if we look in the workloads, compute, it's still created. It takes normally 3 to 6 minutes to be all created. We're gonna have a section of QA at the end, but because it's gonna take a few minutes, if you got some question, guys, I will be very happy to hear them. I'm sure that you guys would install all these components by hand. Will be very surprised that all this is done through orchestration in an operator. Here we got the default SDN for services, traffic. In some cases, you can use Istio. Yeah, almost ready. We are done. There are the different type of flavor images that you can use to deploy your system. Here we got Tensor. That is a widely used from artificial intelligence machine learning stack. Here, if we will have a GPUs, you will see the images also available. You choose them when you install. You define the stanzas. Here in the stanza, you choose that you would like to access the GPUs offered by OpenShift. In this case, we don't have it, we don't use it, they're quite expensive. Again, we deploy a server. I'm gonna take a couple of minutes to be ready. You will see that this post is being created. Just put in the image and doing all the magic. Complete. Here you got the flavors. We create a notebook. You got your job done as a system engineer, and then from this point on, the data scientist can do the job. Then I would like to share this with you. These are the useful links that will help you to get to know a little bit more in depth what the Open Data Hub is. The first is the website of the project itself. The second link is the GitHub that contain all the code. All the code is open. The third link is about Kubeflow, the project. Then GitHub Kubeflow also refer to all code open for Kubeflow. And the fifth is the part of Red Hat that we provide to our partners and to the open source community, where we provide exercises and workshops on how to use not only Open Data Hub, but most of our products. And that's it, guys. I completed the time, so I finish on time.
Thank you, Rafael.
My
That
pleasure.
was a good presentation. Right now, we're gonna run the Q&A session. Please stay here. If possible, show yourself. So turn on the camera.
I already, I don't know how to turn it on because I see myself, but you don't see me. I'm gonna refresh.
Okay, okay. And let's bring the other speakers. So, Zendesk. Okay. You also. And there is one left. Rafael, who is coming. And that's an amazing opportunity to bring your questions. Oh, Rafael is here. So, just to remind, it's there are several questions that's directed to a person. However, if you want to include more information, please feel free for. For example, let's find the first one. Can OpenShift be used to build the on-premise Kubernetes cluster?
Yes, indeed. So OpenShift platform is like a container platform built on top of Kubernetes. So it contains 100% of Kubernetes, and on top of the native Kubernetes from upstream, it contains the PaaS features, the platform as a service features, and many enhanced features. So yes, it can be built on-prem, on bare metal, on a virtualized environment, in public cloud, private cloud. So yeah, there you go.
Oh, nice. So, is there anybody else who would like to complement that? So, or not? If not, let's go to the next question. Why not? Do this principle also apply to design infrastructure as a code in DevOps?
Yes, it does. That actually we didn't. I didn't talk about ML ops, but there is a very huge initiative in that context.
Okay.
Yeah, I think it was question to me.
No,
Oh
it's
yeah.
an open question. Don't worry. So you can interact. Think about a bar conversation. So somebody give you a question, and everybody's open to answer that question.
Yeah. I, okay, I think they do. However, there are a couple of couple of buts. The first one is that infrastructure as a code should be much smaller in terms of lines of code, in terms of size, rather than the application itself. So the principles are, you know, they are still the same, but their impact is less important. And my experience is that with infrastructure as a code, you don't have so many tools to analyze the situation as with the product itself. Sorry, I cannot hear you.
Ouch. Sometimes technology make me crazy. But anyway, how do we decide if we should use managed service like SQS on Amazon or follow a cloud native partner?
Well, maybe I can start answering this. Um, as usual, it depends. I will give you a couple of examples from my previous experience. For example, the product I was describing for live broadcast we are building right now should be working both on-prem and in cloud. So the answer is clear. It should use cloud native approach. Um, However, even in the situation when you do not need on-prem solution, uh, it really depends. For example, in Honeywell, we were building something for IoT, and the devices we were selling to our clients were supposed to last 20 or even 30 years. Usually IoT devices running on oil platforms and so on. They need to be working for a long time, and no cloud platform could guarantee us to support their services this long. So, for example, in that case, we also had to go with cloud native. But in most cases, or if you know that your application will be pretty small, you do not have a DevOps team, using uh, cloud straight services straight could save you lots of time.
Okay. Does anybody else? No? So just to remind, please share your slides with us. So if you don't mind, we're able
Sure.
to maybe share in social media, whatever. Just
Sure.
remind you guys. And let's go to the
And
next question. Will OpenShift Kubernetes deployment work with multiple clouds? How does OpenShift handle connecting multiple clouds?
That's a great question, actually. So, OpenShift, like I said in my previous answer, can be deployed on multiple clouds. When you say multiple, it means, let's say, you can have multiple clusters across different cloud footprint, public, private, or any flavors of the public cloud. Uh, OpenShift connecting with multiple clouds. So there are two aspects of it. So the applications running on one cluster in one cloud connecting to the application running on other cluster in other cloud. So that's of course possible. But using multiple clusters, OpenShift deployed across multiple cloud types. You can also have a unified management layer, so you can manage them centrally, and you can have, let's say, in a single pane of glass kind of environment, you can have a look, manage around, let's say, orchestration of your workloads, securability, patching, and everything through a common pane called as advanced cluster management from Red Hat. So yes, you can connect between the clusters, of course, and you can also manage multiple clusters together. I think you're on mute.
Yes, I always forget to remove mute on myself. But anyway, let's move to the next question. Again, guys, if you want to answer or complement or put further more information, you are free to. Okay. How do you ensure security in edge computing? Another one would be how do you ensure edge device availability? As we know, the fallacy of distributing computing, much appreciated.
That's another great question. It's easy to think that when you're moving away from your on-prem, where the security is kind of given, let's say, universally for all of your infrastructure within the data center. you know it is not available in your edge compute locations or edge compute devices or even the regional data centers. But the whole paradigm of security is kind of shifting left. So, like, DevSecOps model. So, like, when you say zero trust policy and everything, so that's not true. So zero trust, for example, if you're doing kind of an HTTPS request response, you are even kind of trusting a certificate which is at root level, signed by some other party. So differentiate between explicit trust and implicit trust, but the security is kind of shifting in DevSecOps model. It's not just securing the perimeter, deploying firewalls, but it's securing at every stage of application development. Other than that, you can also have, let's say, at the edge deployed your firewalls still, but yeah, going towards the real cloud native and not just towards the edge computing. The DevSecOps model is really trying to shift the overall security at left and moving security at each of these layers rather than as a last mile in the any kind of development and deployment activities. Does that answer your question? Maybe you can also do a chart and okay, then you can bring it up.
Yes, it's good one. Please, if you have more information, want to know more, just put in the chat. Isn't SQS a cloud native partner in managed service?
Yeah, this probably refers to me. Um, Maybe guys, can you advise, because I'm always confused by these terms. What means cloud native, cloud based, and cloud enabled? So
Yeah, if I can answer. So so SQS is kind of a queuing service from Amazon, and cloud native pattern is kind of a terminology where you move from, let's say, traditional application development and also traditional infrastructure towards a really cloud native where you can manage and orchestrate at scale. So in my opinion, this is they are two different things. You can also have both together. You can still use SQS as a managed service. You can use a lot of managed services from AWS or anybody, but you can still go with, let's say, a cloud native pattern. So I think these two can go hand in hand. Yeah.
and maybe at me one more thing just to clarify what I said when I was mentioning cloud native. Um, I meant, for example, a service that you build yourself, and when you start building it's prepared for the cloud. So and you already have, for example, the deployment pipeline to the cloud, but the service itself is not provided by Amazon. It's built by you, um, and it runs in a Docker or something like that.
Oh, no, this time. Finally, I remember to remove mute myself. Let's move to the next question. Um, and again, there's an amazing opportunity to bring your questions right now. So if you have any questions, feedbacks, share any kind of experience, please do it. And what are the advantages offered by Open Data Hub compared to Google Cloud AI platform?
Okay. What Google Cloud or Amazon or even Red Hat offer as a SaaS offering got always its limitation. The user cannot tune the platform to their needs. They are allowed only to use what is given. Normally, of course, those enterprises are able to provide a ready battle platform, but in many cases, users need to run highly customized workloads, and you definitely cannot tune the things in the way you want in when they are SaaS offering. Open Data Hub gives them the complete control to be able to customize the infrastructure and the way that the middleware use that infrastructure to the max. Um, Open Data Hub at the moment is not a supported product. It's a project. There are customers using this in production. There's no official support. It's a support on base A4 basis, but the level of control that the partners and customers able to get by managing the complete life cycle of their stack really worth to be implemented. So basically, you lose a little bit of support, but you get complete control of over how your artificial intelligence stack behave.
Okay. Does OpenShift have threat detection toolset in the overall edge infrastructure, or do we have to install third-party toolset for cert detection?
Yes. Yeah, I think all the great questions keep coming in around OpenShift. Yes, the threat detection tools. I mean, OpenShift and build security. I mean, OpenShift has RHEL Core OS as the base operating system for all the nodes. So there are lots and lots of security in build, like security context complaint and C groups and everything, which is coming as part of the RHEL Core OS. But OpenShift has itself some threat detection, and compliance management. But what really adds to the overall security layer is advanced Red Hat Advanced Cluster Security. So this is again a single pane of glass for managing a security across scale. So OpenShift and also RHEL CoreOS has some security features, but they are complemented by the advanced cluster security by Red Hat. So these are the two management systems on top of OpenShift, which customers can choose. For example, Red Hat Advanced Cluster Security and Red Hat Advanced Cluster Management.
Okay, let's move on to also edge device. Baba Barebone. What is your suggestion for security edge device?
Yeah. So bare bones. I guess it's mean bare metal devices. Let's say small footprint. So edge devices can be. I mean, there are device edge and there is edge devices. Like what I discussed in my session. So when you talk about edge devices, I assume they're really the far edge and really the device which are generating the data. So there needs to be, let's say, a perimeter security also. But like I said, if you're deploying any kind of workload which is utilizing the compute capacity of the edge device, it needs to be built rather than the traditional security measures, perimeter firewall and everything. It needs to be secured at every layer, let's say infrastructure security and also the workload security. So things like verifying the workload, securing the workloads, and detecting anomaly and everything also extends from the cloud towards the edge devices where the smaller footprint compute is running.
So, guys, I wasn't really paying attention in your talk, but about what edge devices were you talking? Were you also talking about IoT, for example, or really small devices?
Yes, exactly. So IoT sensors. So all these security principles needs to be built also on the devices. Let's say the application security, access security, and also the workload, vulnerability detection, etc. So these things are, I mean, all the loopholes needs to be secured also at the edge devices. Bare bones means, let's say if something is running like a firmware or on a bare metal, then that security also needs to be built in the application which is running on those bare bones. Other than, of course, the perimeter and the firewall and all the security.
Yeah, I'm asking because a couple of years ago I used to work in IoT and we were adding some security features.
Yeah,
I remember that most of these really small devices had a dedicated chip to store, for example, certificates or uh, RSA keys and so on that could not be really changed or were really difficult to change. And the computing power they had was really small,
exactly.
especially when they were really processing doing something to add encryption to them. That
Yeah.
was really a big deal.
Yeah, if you talk about, let's say, if mobile phone is an edge device, it works at the edge. It has compute capacity. So there are, other than encryption, there are also some security features built into mobile phones. So yes, encryption is one of the features which needs to be there at the edge devices, and there can be other features depending upon how far it is away from the data center. So there can be various mechanism of the edge security.
Okay, let's see if there any more question. So everyone, again, please use this unique opportunity to talk with those amazing software engineers slash architects. So bring your questions. Why it's not happening? I just have one curiosity. Do you guys Are you guys using C4 model or any kind of another documentation to your architecture right now?
Well, personally, I'm not using C4 or well, I'm not using C4 modeling tool that is there, but very often we draw something like that. If we need go to 4 levels, we do so. Very often, just 2 levels. 2 levels are enough for that. So we do something similar based on our needs. But personally, I'm not using C4 modeling tool right now. I did it before.
Okay. So let's move to the next question. What is the most challenge activity to be architect these days?
I will go first.
Do you want to start?
Okay, so I'm the solution architect, and my job really involves working with the customers. So the most challenging, I would say, activity I do as part of solution architect is getting customer to understand the value and understanding from them, because there is a principle called as 9x model. So the customer thinks that everything he holds at this moment is 3 times more valuable, and every new thing is 3 times less and more expensive or something. So the most daunting task is to take customer from his perspective of what he thinks the solution is or where he wants to go, and working with the customer towards their success and telling them this is how it can be, these are the possibilities. So yeah.
Okay.
Okay,
Is there
maybe
anybody?
I will go next.
Okay,
Yeah,
please.
right.
I would say in general, what is difficult about architecture, that the higher problems you're trying to solve, the less rigid answers you find. And sometimes the solutions, there are no ideal solutions, which is still fine. You can identify a solution you think is the best based on your experience or based on some evaluation. But then comes the difficult part, because to suggest a technical solution or some technical approach usually means that you need to convince people about it, that you need one team to do something differently that they did, that they need to refactor or change something, or you need to convince management to or stakeholders to give you more money, and you need to convince them about these ideas, and sometimes you need to convince them to do something that is not comfortable to them or that they were not doing before. So very often it's question if this team or this person or that team will do additional work, and you need to go and tell them and convince them that it's the right thing to do.
Okay, Rafael.
Okay, well, what interesting question is that? It took my time to think. Okay, what part of my job, my daily job, bring me to a situation that I feel exhausted or compromised, or well, being honest, very honest about what the challenge is. Precisely what the Seneca said about isn't it's not that complicated to enable new technology, transform customer needs into technical solution, especially functional solution. But there is a trade-off, especially in the security context, that you need to tell or you need to share with customers that they might need to change the way they do things. Uh, Kubeflow Open Data Hub is an example of that. A lot of customers test their workloads and unprotected Kubernetes, vanilla Kubernetes, and it works very good. Then they want to jump into production and they move their workload into enterprise Kubernetes like OpenShift. You or they not be able to run the same type of workload with the same conditions. There is a big constraint, security constraints that that are being handled by OpenShift that make that transition from a pure test environment into a production environment. Technically, is very straightforward to change that, but in the way that process, especially mind process of people, developers, to do that jump from a test environment into a production environment is a big step, and sometimes it takes time to explain that. Okay, you should not run a rootful code into a production environment, and that conversation sometimes take even longer than change the configuration of the deployment. That I believe is the most difficult part, changing minds of people.
Okay, and let's move to the last question. And then, is 5G required for edge computing or is 4G LTE sufficient? As I understand it, 5G penetration is building is an issue, and we think of warehousing settings.
That's another great question. 4G LTE is sufficient. I wouldn't say it would do the job, let's say to some extent, but it will not, because 4G LTE, even with carrier aggregation, is still going to work at 800, 900, 18, 2600 kind of frequencies. But 5G is really going to work in gigahertz, so 3.45 gigahertz, is kind of a sweet spot where it's going to work. So 5G is a technology which will enable, way higher bandwidth and ultra low latency. And what 5G is also doing is it's enabling Can you see me? Yeah. So 5G is also enabling kind of massive machine type communication. So you can communicate with the radio technology, which is really working at a light speed. So 5G penetration in building is an issue. Yes, because the higher you go in frequency, the penetration goes really down. So the whole landscape setting of 5G is also going to change. So there will be way more cells like picos and femtos and micro cells, which will be deployed strategically, to maintain kind of a better line of sight and better stability. So 4G, yeah, the penetration and the range was higher, but there were a lot of not drawbacks, but 5G is really advanced. Penetration can be handled, by various technology, various cell placing mechanisms. In warehouse, yes, you can have, or in office, or in any kind of setting where it's hard for the 5G carry reception. You can you can actually have things like microcells, picos or femtos. So yeah, that shouldn't be a stopper.
Okay. That was a little bit about automation and security in supply chain CI/CD pipeline in both traditional and AI pipeline contexts. Your view of zero trust and shift left in SDLC lifecycle. Oh, it's a good one. And look, it's so hard that nobody's able to answer. So, um,
Uh, uh, I don't know if I can go first, but yeah, I don't know about the AI pipeline context, but uh, yeah, I don't know about the AI pipeline context, but in the whole CI/CD pipeline, with or without the AI workloads, yeah, the zero trust, like I said, it's shifting from let's say implicit trust to explicit trust. Zero trust is kind of a misnomer. In the end, you end up trusting somebody or some authority, but it has to be an explicit trust, like a said trust. So when you shift in a whole DevSecOps model, when you shift the security also to the stage one rather than kind of a last thing you do in your whole supply chain of CI/CD, it is important to have security at each step, and automation can really help you with that. And when you're doing security at each and every step, you will not be doing a lot of things manually. You can automate your supply chain. You can even now you automate your CI/CD pipeline, but you can also build in explicit security measures in every steps of your CI/CD pipeline. So yeah, this is the new paradigm called as DevSecOps rather than just DevOps. Security at each and every step. I'm not sure if Rafael or
Rafael?
This is a very, very long, complex question, actually, and it touches many different parts of OpenShift. I would love to give you more information about security on CI/CD, but I'm very far away from that. I'm an infrastructure part, and to talk about CI/CD pipelines, it's a little bit far away from my expertise. Um, what I do in OpenShift is making the OpenShift deployment satisfy the demand of compute and storage to further application usage. But these are very complex questions, so I don't reach that far. Uh, but
Mm,
uh, but what my colleague said is was quite accurate. What Saubara said. Um, the principles that apply for CI/CD should apply also for the pipelines in artificial intelligence. But how deep in that, I haven't tried myself.
whatever you
okay.
I'm sharing the slides. I can also try to share the security principles in cloud native environment. Let's say I will try how I can share it. But we have kind of a book shareable where we are discussing kind of security principles in the whole cloud native paradigm. Yeah.
By the way, guys, have you ever seen CI/CD pipeline with zero trust model? Personally, I have never seen it working. I think it would be quite difficult to build.
That looked like a wonderful use case, actually.
Okay, that's all those questions. Thank you, everybody, to this amazing opportunity to do QA session. Just to remind you about the Geeko campaign. So, as much you help in the tickets, Geeko will give 100% donate to charity to help Ukrainians in need. So, again, thank you, Saraf, Rafael, the easiest one, at least to me, is in deck to those amazing presentations. And yes, for your time on QA.
Thank guys.
Yeah.
Thank you. Have a nice day.
You too. Bye bye.
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 for joining in. This is the Worldwide Software Architecture Summit 22, and my name is Anugrah Sinha. I am here in Japan, and I am a senior data scientist working along with the Geekle team to get the session running. We'll be starting off with a session from Ali Parker. He's the software architect platform group in the United Kingdom. He'll be talking about experiences using GitOps and policy as code to create. And it's basically more on the DevOps part. And I think Ali would be shedding more light on that topic. Let's just wait for a couple of minutes, probably around another 30 seconds before we go ahead and start with the session. Hi, Ali. Good to see you.
Hi, nice to see you too. How are you doing?
I'm doing absolutely fine. I hope.
Fantastic.
How's the climate out there? And you based out of London?
I'm just up in Cambridge, just a little bit further north, and I think we've got to that point of the year known as fall spring, where it looks like things are starting to become spring before it all turns into winter again and it gets frosty. But yeah.
I think the pandemic has also given us very, very different kinds of climate and weather to see all across the world. Things have been very different as to what they used to be 2 years back.
Absolutely.
All towards you. Please take up, and we are looking forward to listening to your thoughts on GitOps and DevOps. The stage is yours. Go ahead.
Thank you very much. So great, I'm going to tell you a little bit about creating an isolated and multi-team Kubernetes environment using GitOps and policy as code. So obligatory introduction slide. I'm Ali, I'm a software architect, and if you want to get in contact with me after the talk, feel free to get me on ali@parkers.xyz. So let me tell you a small story. So back in time, there was a platform team who were asked to come up with a shared cloud-native environment with a bunch of common platform resources such as service mesh and ingress and some other common services that would allow another team to go ahead and deploy their services on top of them. The big questions we had were, how can we create a cloud-native deployment environment with separate environments for dev, test, and production, and common shared infrastructure and capabilities? We wanted to make sure that our multiple engineering teams could ship independently, add new deployments in a self-service manner without needing to talk to the platform team, and without interfering with each other's deployments. We also wanted to make sure that our platform team had oversight of what was being deployed and where. So what is GitOps? GitOps is using Git as our source of truth for our desired system state. In order to do that, we declaratively create our system definitions to put into Git, and then we have some software that automatically deploys those changes and converges on the desired state. So what are we trying to solve with it? Well, again, it's that one source of truth, that golden source of truth, which is the key thing. We'll also have continuous deployment working there and continuous convergence, which is that key thing. So if our real life system diverges, our software will converge back to what is in Git as our source of truth. So today we're going to look at Flux CD. This is just one way of using GitOps against Kubernetes. And in fact, GitOps isn't unique to Kubernetes. It can be used for all sorts of different systems out there in the world. It's just a way of using Git and using all those nice tools that we're used to using as engineers, like our diffs and our rollbacks and PRs and branching and things, in order to control our systems. So, well, now all my nice animations have gone out the window, but let's talk about Flux. So how does Flux work? Essentially, let's say we've got our repository with some different deployments and services, just bog standard Kubernetes manifests and things. How do we get those into our cluster? Well, we start by deploying Flux into our cluster. Flux is really just a set of custom resource definitions and controllers that consume them. I'm going to start by talking about the Git repository custom resource definition and the source controller which consumes it. Now, the first thing we need to do once we deployed Flux into our cluster is tell Flux which repositories to look at to deploy manifests. And that's where we create, down here on the left, in our Flux manifests, a Git repo manifest pointing at our repo. That goes across into Kubernetes, and now Flux knows all about this repository, but we haven't yet told Flux what manifests we want to deploy into the cluster. So that's where the customized CRD and customized controller come in. We create a customized manifest which says to use this repository and point at this directory or customization in order to deploy our manifests. Those then get deployed into our cluster, and we're all good to go. So there are several components in Flux CD. The first are source controllers. These are things like a GitHub or any Git source that we can point at to pull manifests from. Also Helm repositories and S3 buckets if you prefer to store your manifests there. We also have the deployment controllers, so the customized controller and Helm controller. This allows us to run customizations to deploy manifests into the cluster, or even deploy Helm charts with whatever values we need into our cluster. There's some other nice bits on the side as well. So we have a notification controller, which allows us to call an HTTP endpoint or write into Slack or Teams whenever something changes in Flux, whenever there's a deployment or a problem, and you can filter it and do all that kind of nice stuff. And finally, one of my favorite things is the image automation controller. What this does is it watches our container registry, looks for updates of our images, and using Semver patterns, it will then update our manifests in our repository with the latest versions of our images, which Flux will then see and deploy those changes out into our cluster. So let's talk a little bit about the structure we're going to be looking at today. I'm going to do a demo in a minute or two. So we're going to start off with a fleet repository, which is owned by our platform team. In this repository, we will have the manifests and definitions for Flux CD. We will have the manifest for our clusters to bootstrap Flux CD in there. We'll have our infrastructure components with their different environment overlays, so dev, test, prod. And finally, we'll have our tenant definitions. In this case, when I'm talking about a tenant, I'm talking about each of those different teams that are going to deploy applications into our cluster. So those tenant definitions will be owned by the platform team. So there'll be a Git repository manifest, which will point at the team's repository, some RBAC definitions to create service accounts and namespaces, and finally some resource quotas. Then we'll have a couple more team repositories, which will contain those teams' bog standard application manifests and environment overlays, potentially in more complicated scenarios, some Flux CD customizations and Helm charts. So what's the first problem we have when sharing one of these clusters across multiple teams? How do we prevent our tenants from interfering with each other's resources? And how do we prevent those resources just being sprawling everywhere all over our cluster and being deployed? Well, the first way we can control that using Flux is Flux's create tenant functionality. The idea here is that it will create a dedicated namespace with a service account with only permissions on that namespace. And that will be the service account that's used by Flux to deploy into that namespace. Secondly, Flux can be configured to prevent cross namespace references to stop different tenants creating resources in other namespaces. The second problem that we usually run into here is the classic noisy neighbor problem. How do we stop one team's application from monopolizing all the resources in our cluster and potentially upsetting other teams and degrading the services of our other teams? Well, we can control this using resource quotas and limit ranges. So a resource quota limits the aggregate resources used in a namespace, and that can be by compute or memory, it can be storage or even object count. It essentially requires that all workloads going into the cluster will need a resource limit or request defined on it. And for those situations where we don't always have a resource limit or request, we can create a limit range which will apply a default limit to it. The last problem I'm going to touch on today is ensuring best practice. How can we ensure that the applications that are being deployed follow best practices, that they're secure, For instance, that our containers aren't running in root mode, or that they have resource limits defined, like I said before, or that maybe our images are coming from a known safe container registry. Well, we can control this with policy as code. In this example, I'll talk a very little bit about Kyverno. I particularly like Kyverno because its policies are built as standard Kubernetes resources. It feels very native to the Kubernetes environment. What Kyverno will do is it's essentially a Kubernetes native policy engine, which is enforced through admission controller. So whenever a new resource comes into your cluster, it will either let it through if it doesn't violate any of the policies, or it will stop it from coming in. And it can either enforce that, or it can just order the output there and still let it through. So I'm going to go into a demo. This is pretty closely based on the standard Flux 2 multi-tenancy demo, which you can get from this link here when I share the slides. Right, I'm going to go ahead and share my screen, and we'll see how we get on. So I'm hoping we can change to my screen now. Perfect, thank you very much. So what we've got here is a pretty empty kind cluster over here. So I'm just using kind Kubernetes in Docker to spin up a cluster. This is our dev environment here. And I'm gonna just show you these repositories that I've got at the moment. I have 3 repositories. I have my fleet repository, which is currently empty, and I have 2 team repositories. One, in the team one, I've got 2 folders. I've got a dev manifest and prod manifest. And these are just a couple of small deployments. It's just Nginx, so we can get something deployed. Nothing particularly special in here. So how do we have these 2 teams repositories shared in the fleet repo, shared in this cluster right here? Well, the first thing I need to do is I need to bootstrap Flux. So I've got a command here. I run a Flux command to bootstrap it, and I just need to grab a GitHub personal access token. This is just used to create that initial deployment key so that Flux can start reading from that repository. So I'm just going to pop that in, and that's going to connect. It's going to start bootstrapping my cluster, and over here you'll start seeing things happening. So that's great. That's doing its thing. We're spinning it up. So the first thing we need to do is we need to apply our isolation. Now this is the configuration that we're going to add to Flux in order to make sure that our namespaces are isolated from each other. So what's happened down here is it's actually created all of our configurations, and I'm just going to pull those back down from our from GitHub. So if we're now looking fleet, we should see we've got clusters, dev, Flux system. And that's all set up like that. It's all looking good. So back to the isolation policy here. Ooh, whoops, gonna have to delete that one. So what this additional configuration is doing is to, I'll just explain it, disallow cross namespace references, and also set up a default service account. So each of these controllers is going to use, each of the Flux controllers is going to use the default service account in each namespace. And that's going to have 0 permissions whatsoever. So in order to get that deployed, I'm going to have to push that up to my repository. So I'm just going to check that in and push it up. Best comment ever. So I'm going to push that up. What you'll see on the right is it will redeploy the Flux system there. So now, whilst that's going on, we're going to start adding our teams to our cluster. So I've got what we're going to end up with is a structure where we have prod and dev clusters, a tenants directory with a base, prod, and dev. So we're going to use customize to customize the base there. So I'll just take a couple of these commands to start with. So what we're doing here is we're using Flux create tenant to create a team 1 tenant inside the namespace apps1, and that's going to export it to file. So this isn't run into the cluster yet. I'm going to have to check that in just a moment. So here we've got our brand new namespace. We've got our service account inside that namespace and a role binding, which gives it permission to deploy into that namespace there. So that's great. That's the first step. Now we need to point Flux, or we need to tell Flux to look at that team's repository. So I'm going to create a source using git create source, and it's going to point at the WAS team1 repo there and create a sing file, and that's done. And finally, we need a customization to tell it what to deploy from that repository. So let's take a quick look at this thing here. So this is pointing at the WAS team1 repo, and then this is pointing at the root there. So it's going to be looking at the root of this repository at the moment. So that's obviously not quite what we want. We want to be pointing at that dev folder over here. I'll get to that in just a sec. So the last thing I need to do is just to create a customization in this folder to tie these two files together and to get it to run into the cluster. So that's looking pretty good. We've got that, but the last piece of the puzzle is how do we tell in our clusters folder, how do we tell our dev cluster to start looking at this tenant folder here, and in particular to deploy team1? Well, the first thing we need to do is add our tenant overlays for dev. So that they're going to go in here. So I'm just going to take these and I'll explain them once I put them in. I'm going to create our dev folder like that, or not. So in here, we have a customization which leverages that base team1 folder and applies a patch over the top. That patch is saying to look at the dev path in the team1 repository. So that's this folder down here, and that'll deploy it there. Finally, we need to tell our cluster customizations about our tenants. And I've got another one for that. I'm going to pop that in the dev folder like this. So just to review very quickly, in Flux system, we have a sync and a customization that looks at that cluster's dev folder. That's this folder here. That's going to find this tenants file, which then looks at the tenants dev folder, tenants dev, like that. We're just going to apply this customization, which leverages these base manifests up here. So that's all looking good. I'm going to check all of that in. Ooh, lots of changes. Another great commit message. Send that up to the to GitHub, and on the right we should see lots of magic starting to happen. Now, I talked about resource quotas before. I'm going to apply some resource quotas in here as well. So I'm going to take a look here. So I'm applying one CPU hard limit on our team1 namespace, which is this apps1 here. So I'm just going to take that and put that into our dev folder. So what I'm doing here is I might have a different resource quota in dev from production. In order to get that to be picked up, I need to add it in here as well, like that. And then if I check that in, that'll get deployed. Hopefully on the right, you should see our new app up and running. Fantastic. That's looking pretty good. I'll just do that and push that up. Right, now I'm going to add my team2 into my cluster and get that up and running before showing you some of the isolation work. So I'm going to do pretty much exactly the same as I did before, only with twos all over the place. That's all this stuff here. So again, I'm making a directory. I'm creating a source to point at team2's repository. I'm creating the syncs and the customizations to link all that together. So in here now, we should see team2 like that. And finally, to link it all up, I need to say in the dev environment, I want all that team in. So I'm going to stick that there, make that team2, and create a patch for team2 as well. And increase that. And that's looking good. I've prepared my patch file here, so I'm just going to take that, This does the same thing. It's pointing at the dev folder inside here, which is going to deploy another Nginx container into the apps2 namespace. That just needs to pop into here. And I'm just going to update my quota for team 2. And I'm going to give them a 200 millicall limit there. Where are we? There it is. Put that in. Oh. So if I check that in and push that up, it's going to add my second team into the cluster. Again, quick tick, quick push. And we'll see that ticking over. That should come along like that. So now, oh yeah, off we go. So there's team 2 coming in and that container creating. So what happens if we have a naughty person in team 1 who tries to deploy into team 2's namespace? So if I go into this deployment in team 1 and I make that try to deploy into apps2 namespace, let's see. Is that all deployed? Yeah. So we've now got team 1, team 2's apps in their own namespaces. What's going to happen when I push these changes up? So it's starting to reconcile there. Okay, so we've got an error here. What's it telling me? It's saying forbidden error deployments app1. So the user, so this is our service account. I was gone. The team 1 service account can't deploy into the apps2 namespace. That's great. So it's definitely enforcing that. It's a good start. So I'm just going to change that back and fix that up. Pair space. That is not the button that I wanted to click. There we go. Just going to fix that up, push it back, and it's going to resolve itself. And finally, let's see what happens if we try and go over our resource limit. So this is the final bit of the demo, I think, today, because I'm running a bit low on time. So if I come down here, so our limit for this namespace is 200 millicores. That's currently set to 0.1. What happens if I create another 2 replicas? So that should take us to 300 millicores over here. As you can see, that's righted itself on the left. Now I've got rid of that naughty namespace bit. So let's add this in and see what happens. Check that in and push it up. We should see in just a moment the next pod spin up in that deployment. So we've got 2 replicas now. Great, so we've got 2 replicas, but we should have 3, and we're not seeing any errors here. Certainly that's because resource quotas are part of Kubernetes rather than part of Flux. If we want to see what's going on there, we need to look at our events. And if we look up here, oh yeah, here we go. We can see all of our events, and we can see failed create, error creating pods, we're over our resource quota. So that's making sure we're not using more resources than we expected. Great, so I'm going to come back to my slides now. I just stop sharing. Could we grab my slides again, please? Thank you very much. That's great. So learnings. I'm going to wrap up with a few learnings of my experiences of using GitOps for multi-tenant scenarios over the past year or so. There's a few gotchas that I want to highlight. The first is that the term customization is sort of overloaded. We have customized customizations, which are bog standard customized customizations, but Flux also uses the terminology customizations. And that's how Flux knows to point at a particular customization. So that can be a bit confusing. Watch out for that. GitOps can feel a bit circular as well. So the Flux CD manifests are deployed to the cluster, but also into the repo. If you were to remove them from the repo, it would end up deleting itself. So you've got a bit of a chicken and egg thing going on there. Don't worry, it's not you that thinks it feels circular. Everybody feels that way. Finally, another gotcha that I've seen a few times is when deleting namespaces. So Flux will prune things for you, but it Occasionally, there are finalizers left on our namespaces, which prevent them from being deleted. Another set of learnings are that you've still got these leaky concerns and cognitive loads. So the upside of using this and having each team's manifest in their own repositories is they can manage their own manifests. They're in charge of their own destiny, albeit with the safety rails of only being able to deploy into the right place. But then the downside of that is that each team needs to manage their own manifests. You're still leaving that cognitive load of Kubernetes and doing all that kind of stuff. And finally, in those more complicated scenarios, it's easy to add Flux customizations to a team's repository, in which case Flux is sort of leaked out across your organization, which isn't great. So you need to keep an eye out for that. And another decent one to think about is that branching can be really confusing. Let's imagine I've got a development cluster and I create a new dev branch to work on. The dev cluster is looking at the main branch because we're using overlays. So I update the main branch to say, oh, dev cluster, you should look at the dev branch. Great stuff. So Flux then sees that change. It starts pulling all the manifest from that other branch into the cluster. But I've forgotten to update my Git source in my dev branch. So it's still pointing at main. So Flux grabs the manifest saying, oh, look at the dev branch, which updates itself and says, oh, have a look at the main branch again. And you end up in this horrible loop. So it gets a bit confusing. It's better to not change the branches, I've found in practice, and just work off main. So that's something to bear in mind. Another thing we learn is that that image update controller should be deployed elsewhere. When we created our clusters, we put the image update controller into our production cluster. So it would monitor the container registries and look for updated images. Then it would update our Git repository, our GitHub repository, and then Flux would see that and deploy those changes. Now, if we were doing it again, we would change it because we don't want our production cluster to be able to write to our Git repo. It's a bit of a security concern. So we'd probably deploy that into a separate operational cluster where we could run all sorts of other operational concerns. Finally, you're still going to need your CI for these manifests. This was quite a big learning for us. It's still entirely possible to create invalid customizations or to create changes that Kubernetes is going to reject. So one way we got around all of this was to run a customized build against all of our customizations and overlays before deployment to make sure those customizations are going to work properly. We can then take the output of that and do a kube control apply dry run against the server to find out whether the server is going to accept those changes later on or not, even before it gets merged into main. And finally, it's not always obvious what the changes will do in each environment, especially if you've got a lot of layered, nested customizations going on. You might want to be able to see what the difference that's going to be applied to your clusters is going to be in each environment. So we got around that by then taking those manifests and creating a kube control diff against the clusters to see exactly what's going to change. And we gave ourselves bonus points when we posted the results of that into our PR conversation. So whoever was reviewing the changes could see exactly what the diff was going to be applied to the clusters before hitting merge. So those are a few of my learnings. Thank you very much. I believe I'm at a Q&A a little bit later. I hope you enjoyed the demo and that went smoothly enough. And yeah, I look forward to your questions later. Thank you very much. I think I may have finished with a couple of minutes to go, but we'll see.
All right. Thank you very much.
No problems.
For that insightful session. Definitely, I mean, I really don't come from the area of DevOps, but looking at the demonstration and the way collaboration can work across different teams, it's really interesting because in the age that we are in right now, where developers want to put their apps into production as soon as possible rather than going through longer processes or manual processes. So I think these things can definitely add up as to how we go take our product to the customer as quickly as possible. And needless to say, this also helps at fixing production bugs as well when we want to release them and get it into production as soon as possible. So I mean, I think that's really great. I'm sure the attendees would have had a great time listening to it. Any last comments? I think you have a couple of minutes before we move on to the next
Yeah,
speaker.
I wish I'd had a bit more time in the demo to show a bit more of Kyverno and policy as code. I think it's a really powerful way of. I don't know if we've touched on policy as code yet at this summit, but it's a really nice way of taking, in particular, security constraints or things that we care about, like is this actually the image that we're deploying? We were talking about supply chain attacks previously, I think in the previous Q&A. You can have the shards or the verifications of your images running inside the cluster. So Kyverno can prevent a random image from starting up. You can also have policies in place that only allow you to look at your organization's repositories to stop it just randomly bootstrapping other things. So there's a ton of power there. And really, that could be a completely separate talk, maybe next time, maybe at the next conference, who knows?
And so we'll be looking forward to that. Thank you very much. All right. So thank you once again, Ali. Great talk. Thank you very much for joining us, and I hope you stay up for the Q&A session. If there are questions, we'll forward it to you. Thank you.
See you then. Thank you. Bye.
Bye. All right. So we'll be coming up soon with our next speaker. Let's just hold on for about a couple of more seconds, and we'll be bringing them back on stage. Thank you very much. Please hang on. All right. Thank you very much, Benny, for joining in. Benny is a principal software engineer at Red Hat. He'll be talking today about operators per se, automating the lifecycle of stateful application the Kubernetes way, right, Benny? And
Yes.
it's an honor to basically have you with us. I mean, Red Hat is a wonderful company, maybe a dream company for a lot of engineers and people out there in the world. Probably one of the first to really bring out Linux on a production scale rather than just running it in universities. So, I mean, obviously you work with a wonderful and prestigious organization, and we'll be looking forward to listening to you about Kubernetes from a stateless application platform and the concepts around it. Over to you. The stage is yours. Please go ahead, Benny. All the very best.
Okay. Do you hear me well?
Yes.
Okay. So now I need to share my screen.
You can share the the tab that you have on Chrome, and that should do the job.
How do I share it?
There'll be a button at the bottom. If you see, there will be a share button that says.
Yeah,
Right.
it's live. Oh, from Google Slides.
Yeah, Benny, it depends on what you're using for your presentation.
I'm on Firefox.
Yeah, but what application you're using for slides?
Google Slides.
Yeah, just if it's Firefox and Google Slides, you should just share your full screen. Just share your entire screen. That should be enough.
Okay. Now. Okay. So you're seeing my screen?
Yes, we are.
Okay.
You're good to go, Benny. Go ahead. It is yours.
Okay, so as was already mentioned, I will be talking about Kubernetes operators, how they help us basically extend the Kubernetes API with your own application. So What I will cover today is I will go through some basic core Kubernetes concepts. I will make the case for operators by showing how good it works for stateless applications and how hard it is for stateful application. Then I will go into the definition of an operator, and hopefully, if time permits, I will get to a short introduction on how to go around and build your own operators. First, a little bit about me. I agree Red Hat is a great company, but I'm recent hire. I've been in Red Hat for about 5 months, working as a certification engineer in the telco ecosystem. This means that we're getting we're working with our partners in the telco industry to certify their applications run in the OpenShift platform. But I do have a lot of experience working on virtualization, cloud, containers, Kubernetes. Basically, I spent most of my career building management systems for distributed applications. And this is a complex problem that has many, many different layers. Kubernetes basically has removed the complexity of one of these layers, the distributed platform layer. It basically has standardized in a way that all the new applications basically are now built on top of Kubernetes, because it really helps hide away the complexity of some of the layers in the system. What happens is when you add operators, this magic that Kubernetes is doing at one of the layers basically takes over most of the work. I wouldn't say all of the work, but all of your automation and management operations of most of them, including some of the hardware configuration and hardware monitoring components, can be done as a Kubernetes native application. That means that you use the same commands that you use to deploy, to change, to update, to scale a Kubernetes pod. You will use them to do these same operations on your application. Having so much experience in this area, I really think this is a wonderful solution, because it means that your customers will have a much simpler and much more consistent approach to your application. So let's start by going quickly through what is basically Kubernetes. And I will start with very, very high-level concepts, which is what we need for to understand what operators are all about. Resources. Resources are basically endpoints in the Kubernetes APIs. Everything that you can do a kubectl get something is basically a resource. And these are some of the most commonly known resource kinds. There are many others, but this is something that everybody that has had some experience with Kubernetes knows: what pods, what deployments, stateful sets, config maps. These are all basically resources. And the way that Kubernetes works is that for each resource, there is something called a controller. Basically, a controller is a control loop that is constantly monitoring the state of your resource and making sure that it is in the desired state. So Kubernetes is a declarative system where you declare what is the desired state of your application, and the controller will make sure that the deployed application always matches the desired state. So the desired state might be the number of instances, might be the version. There are many different things that you can capture in this concept of the desired state. The controller is basically continuously watching for the state of the resources, compares the current state with the desired state, and if there is a difference, then it fixes it takes appropriate actions to fix the situation. Let's take an example of a replica set. The state, in this case, the state is always captured in the spec, in the different Kubernetes manifest. So in here we have a very simple example where we're defining a replica set with three replicas. This is our desired state. The replica set controller will constantly get the current state. If the current state is equal to the desired state, does nothing. But if we have changed the desired state, we added some more replicas or removed some more replicas, then it will take appropriate action as you see in the act. If the difference is less than 0, it means it has to delete some pods. And if the difference is bigger than 0, it needs to have to create new pods. This is basically the way Kubernetes works with all the resources. Now, this clearly is great for stateless applications. In a stateless application, here we see a very simple example where I'm trying to deploy a web server, basically an NGINX server using version 1 of the image. If I deploy this, the system will create 2 instances. For the sake of simplicity, the animation just puts them on the same node. This doesn't have to be the case. Usually will not be the case, but just for the animation, it's in the same node. Now I made some changes to the container image. I added some content. I fixed some bug. I now want to upgrade. Since there is no state, I just will update the manifest. We'll do a kubectl apply with the new manifest. And what the system will do is it will throw away the existing instances and replace them with new instances of using the new image. Clearly, this is doable just because there is no state inside the pods. The pods have no identity, have no state. So I can throw one away and replace it with another, with a new one. Or I can add new or remove some, and my application will keep working. However, if we want to move this same concept to stateful applications, it becomes more complicated because the replicas have state, the replicas have identity, the replicas have to sync among themselves. They have it is not as easy to just throw one away and just put a new one in there for the system to work. Usually this needs some human to make sure that, okay, I backed up my old database, now I can shut it down, I can create a new version, maybe migrate the database because the schemas have changed. All of this is usually requires a human, and it's very specific to the application. It's not something that we can say, okay, there is a single way to do it for all stateful applications. It pretty much depends on how the application is built. So what is an operator? An operator is basically a mechanism to capture this human operational knowledge that the application operator does when he wants to take a maintenance operation or an upgrade or a scale. We capture that operational knowledge in software so we can automate the whole operation. But we do not only automate it, we automate it in a way that fits the Kubernetes desired state resource, controller, and desired state model. So basically, we add to this very simple concept, we add the application-specific knowledge. We need to do this for every single application that we're trying to create an operator because it's application specific. When we put all the three together, it's basically when you have operators. What kind of application-specific knowledge is there? How the application is installed, how the application is scaled, how the application is updated, what to do when one of the instances breaks, how to do high availability and bring a new instance up to date, sync with the existing instances. All of this is knowledge that usually the administrator of the application has, and we will capture it into an operator and deploy the operator in Kubernetes, so there will be a control loop that will make sure that these things happen automatically. There are many benefits of using operators. First, it reduces complexity. If we go back to the 4 layers of management that I showed at the beginning, using operators, you basically have a single, for most cases, you have a single API. The Kubernetes API is standardized, so your users have only one thing to learn to manage the full software stack. By automating the manual processes is improved consistency. You will get the same results whenever you do the same operations, because by doing it automatically will reduce the risk of errors. The Red Hat has a program to certify operators. Probably other companies do. I don't know, but Red Hat has a mechanism to certify your operators such that you have full certainty that your operator will work in the environment with the right performance. And what level of automation? There are several layers of automation. It can be something simple, which you can just install your application through an operator. You can add upgrades, you can have backup and failures, and you can go all the way to automatic scaling. What way of level you want to implement in your operator is up to you, and clearly you can do it in stages. Okay, so do we have time left? Yes, okay. So how do you go and build an operator? Theoretically, what you need to do is you just create a custom resource definition. A custom resource is a resource that you define the state, and there is a kind in Kubernetes called the custom resource definition, a custom resource that enables you to create your own resources. Then you have to have some library that enables you to connect to the Kubernetes API, and now you will watch for changes through the API to your resources and the resources it created. And communicate back to Kubernetes when things have changed. You also need to take care of all the administrative sides and create all the resources that enable to manage your custom resource. So in summary, it is not simple to go and do this from scratch. Fortunately, there are many tools around to ease the process and basically let you focus on your business logic. If you use Ubuntu, you can use the Charm operator framework. If you want to write your operator in Python, you can use Cove. In this presentation, we're gonna be focusing on the operator framework, which is an open source framework supported by Red Hat that lets you create operators in Elm, Ansible, or Go. So the operator framework consists of 3 components. The operator SDK is a command line tool that you use to generate the code that is needed to integrate your operator into Kubernetes. Then there is all the integration code that talks to the Kubernetes API in the right places, and it declares all the watchers and events and listeners and everything. And you have a skeleton on very simple skeleton where you put your code. Then we have the operator lifecycle management that basically is an operator of operators. It enables us to update the operators, distribute the operators, basically. And the last component is basically a platform for metering the performance and of your operator. The operator framework enables you to build operators at all the levels that I just presented. If you go only level 1 and 2, you can choose either of the platforms. If you want additional functionality using the operator framework, you have to go with Ansible or Go. Statistics show that most of the operators are actually written in Go. It makes sense because it fits very natively in the platform. So the operator framework in action, the developer basically uses the command line operator SDK to generate the code. It adds the logic that is specific to your operator, and the result is a Kubernetes operator. Then you package this operator, go through some certification process, and then when you know it works, it properly works, then you can deploy it to OpenShift, which is Red Hat's versions of Kubernetes. You can deploy to Operator Hub in OpenShift. Basically, you will see your operator as part of the console, the OpenShift console that the users of our version of OpenShift have. And then it will, if the user deploys your operator, you have an operator instance from which you can instantiate your application. Metrics are collected by the operator metric system, and you can use these metrics to basically improve your code. I'm going to now focus on the first stage, which is the creation of an operator. And if we look at the code, in this case, I generated Go code, and it creates a lot of files. As you can see, I don't know if you see it, but at the bottom you see there are 18 directories and 45 files that are automatically generated for you. Fortunately, there's only a couple of files that you need to know about. It generates a file to declare your resource. In here we see the podset types.go. After the automatic generation, it looks like this. I am trying to define a new resource called podset, and it just creates a skeleton of the code that I need to implement. This is how it looks after I added some fields to the structure. I added the number of instances, the memory size, the compute, and the version. There is a command tool that now takes this file and generates basically the custom resource definition. As you can see, we have here a custom resource definition for the podsets. If you go further down the file, you will basically see how the fields that I define in the Go struct get translated into the spec section of my custom resource definition. In terms of code, there is one file that is called the whatever your custom resource control is named controller.go. As you can see down here, is the podset controller, And in here, there is only a single function that you need to implement for your operator to be integrated into Kubernetes. Is the reconcile function. This is the function that is going to be called periodically. And what you have to do in that function is basically read the state, parse it, check if the current state matches the desired state, make the appropriate changes, and notify back to Kubernetes about the changes you made. Basically, this is, or it can be very complex what you do in each of these steps. In particular, in the third one, the reconciliation of the current state might be very complex according to the complexity of your application and the state of your application. But there's only a single place where you need to put your code, and then the operator SDK generates all the files that are needed for you to actually deploy this operator in your Kubernetes. As I mentioned, the operator SDK and the operator framework as a whole are open source. You can get them out of GitHub. And here is the link. Clearly, there's a lot to learn, and you cannot learn about all this in the 20 minutes that this talk is. So here I have some links where you can actually, if you're interested, you can learn more about operators. I mentioned that when you deploy, you certify your operator in Red Hat's platform, it will show as part of the operator hub in the OpenShift console, but you do not have to go that way. There is an operator hub IO, which is a home where you can put your operators and people can find it for a more general deployment. The Cloud Native Foundation white paper is a very good, it's an excellent paper to actually learn about operators. The first thing you need to do is operators are basically custom resources, so you need to learn about custom resources. There's an O'Reilly book on operators. The link here will bring you to the free ebook. I have to warn you that it's a little outdated and the manifest there don't work in current versions of Kubernetes. So you either have to update them manually if you want to use the code samples, or you have to use an older version of Kubernetes. There is in the Red Hat Developer Program, we have interactive lessons where you can basically create, deploy, and play around with operators. I highly recommend taking this. So, any questions? I think I even managed to finish on time.
Right, Benny. Thank you very much for the sessions. We do have a dedicated Q&A section towards the end of this leg of the conference. I think if there will be questions, the attendees will be posting it to on the chat or through different means, and we can take up the questions at that time.
Okay.
Thank you very much for the session. It was really informative. Hope you had a good time giving the session as well. We'll be moving on to the next speaker now. Benny, once again, thank you very much.
Thank you.
Bye-bye. So we'll be moving on to a recorded session by Kaushik Bhattacharya. He is the associate at Distinguished Engineers. He's from India. He'll be giving a session on event-driven architectures as to what event-driven architectures are, what problem does it solve, and how does it compare with other communication styles. So we'll be bringing that up in a while, just a few seconds down the line.
Hello. Thanks for bringing me here and giving me a chance to speak in the summit. And good morning, good afternoon, and good evening to everybody who have joined in this session. So let me give a short introduction about myself. I am Kaushik Bhattacharya, Associate Distinguished Engineer, playing the role of a technical architect in Nagaro. And I have about 20 years of experience dealing with software systems. Today, we're going to look at a very interesting topic, event-driven architectures and their use in modern systems. And I hope I should be able to keep you engaged and excited in the next 30 minutes or so. So without further ado, let's look at the agenda. So what is this? Well, this is called something called a silk route. A silk route is basically the mechanism through which a spider keeps a note of whether a prey has fallen in its trap or in its web or not. Okay, so basically it's a notification to the spider that a prey has fallen in its web. And if you're thinking it's something similar to what we are going to discuss today, probably you are right. So let's look at the agenda. First of all, we look at events and how they work in real life situation. And then we will look at the difference between a typical request driven versus event driven approach. And then we'll look at some very critical patterns which are used today in modern systems. And they go hand in hand with event driven systems, especially microservices. And finally, we'll look at a couple of case studies, especially from my experience. And then, of course, the most important thing, lessons learned. Okay, so without further ado, let's get started. First, let's have a look at a very traditional restaurant, which is having nothing automated in it. It's a totally manual driven system. There's a customer called Sam, and he comes into the restaurant. He looks for John, the waiter, and also there's a chef called Lucy at the kitchen. And for the sake of argument, let's assume that there's only one waiter and one chef in the restaurant. Now what happens is Sam calls for John. John comes and then Sam places an order to John. John says that please wait till I come back with your order. And then John calls Lucy, the chef. Lucy comes in and then John says that please prepare this food for this customer. And then Lucy says that please wait while I prepare the food. And then Lucy starts cooking, of course. And then once Lucy is done, only then Lucy calls back John. John comes in and takes the food and serves the customer. Now, what are the issues over here? First of all, till the time Lucy is done with the food, there's absolutely no way that the customer can know what's the status of the food. So he has to repeatedly ask every time. That's the first issue. The second thing is that everybody has a tight dependency on each other because everybody knows the other by the name in this case. The third thing is that there is no guarantee that the John the waiter will be able to hear. If there's a noise, then there's a communication loss. And so it's not a reliable communication. The other thing is, of course, that it's a single point of failure system because we have only one chef and one waiter. The other point is that it's very difficult to introduce a new chef or a waiter in the system because of the tight coupling between each entities. The only thing plus point is that there's a direct communication happening between the entities in each case. Now, if we can try to relate this to what happens in a typical HTTP synchronous communication, we'll see there is a lot similar. First of all, it's totally request driven. Everything is initiated by the request. Tight coupling, polling is needed in some cases, and performance is at stake because it's a request response driven synchronous communication happening. So now we will see how events can help in this situation. So now let's look at the same restaurant system with some small subtle changes. First, now we have more than one customers, we have more than one waiters, and more than one chefs in the first place. The customers now don't have to call the waiters by name. Instead, what they do is they put in their orders in a mailbox for which all the waiters have been subscribed, which means that whenever an order is put in, they will get automatic notifications, right? So now the customers don't have to wait for a response from the waiters. So that's very important. The customers just put in orders into that mailbox, which is kind of a black box for them. And that's all. Now it's up to the waiters, once they get their notifications, whatever they will do, it's up to them. The same thing happens with the chefs. For the chefs have a separate mailbox to which they have been subscribed. And so in this way, you will see that everything is now decoupled. And now, basically, even the customers, as you see, they get automatic notifications when the order is ready. So they don't need to keep asking repeatedly for the status of the order. So this is how we have actually resolved a lot of issues in the previous restaurant system using asynchrony and events. A lot of people have confusion with events and messages. So messages are nothing but ways of making independent entities talk with each other in a very decoupled way. And events are specialized messages wherein we use events to notify changes in state of the system. And events work in a pub sub model, which means that the event publisher has in no way any knowledge of the how the event will be processed by the event subscriber. Okay. And apart from that, events have a stream history of their own, and they are immutable, which means that an event logged right now is different from an event logged just a fraction of a second before, right? And that's why they are immutable. Like, for example, a correction in a ledger is itself another entry in the ledger. Similarly, that's how events work. Another thing is the difference between bus and broker. These two are used interchangeably a lot, but the basic difference is that a broker is more of a centralized hub spoke architecture, wherein the intelligence of routing, etc., are embedded in the hub. Whereas bus is more of a distributed architecture, wherein all the applications use the messaging channel only for communication, and all the intelligence is actually in the applications, and the message bus is more of a dumb pipe for that matter. And examples are like service bus. Azure Service Bus is an example of a messaging bus, and Event Hub and Mule, for example, MuleSoft, they are examples of brokers. Kafka, for example, is another broker. Okay, so that's about the messages bus and message brokers. So enter distributed systems, and let's see how event-driven systems, event-driven architecture influences distributed systems. So let's take an example of a typical order processing system, which is having different subsystems in it, like order service, payment service, inventory service, location service, fulfillment service, and the shipment service. So, and all these services, or you can say subsystems, they talk with each other, but in terms of events. So when the order is created, the order service emits an event, publishes an event called order created, and that is subscribed by the payment service. The payment service, when the payment is successfully done, it publishes an event payment success, which is subscribed by the inventory service. And as you see, that way, a chain of events is being created, and a very loosely coupled architecture is devised. Now, the advantages over here, I think we have seen most of them previously. A couple of them are over here new, like they will have a very good monitoring due to the events in the system. It's like a monitoring is a first-class citizen of the system, and it's loosely coupled, as I already told you, and there is no need of any polling as well. So that's EDA in distributed systems. We will now look at some patterns that are usually followed in distributed systems and microservices especially. So the first problem we are looking at is called distributed transactions. So the problem is that suppose you have a monolith system, in that having a transaction distributed across multiple modules, for example, the ordering, payment, inventory, is very simple and straightforward because you can have a two-phase commit in your database, begin a transaction, and then if your payment fails, then you can roll back, so on and so forth. Things become difficult when you break the monolith into multiple microservices and your transaction is actually spanning multiple microservices. Saga pattern is a concept to just address that same problem. The thing which it implements is called compensating transaction. So for example, if you have added 2 units of something in your inventory and your payment has failed, then you cannot roll back that previous transaction. What you can do is you can reduce your inventory by 2 units of that same item. Okay, so that's the basic thing of Saga pattern. We'll see how it is being implemented in the next slides. Saga is implemented in two ways mainly. One is called orchestration. So this is basically similar to a music orchestra where there's one person coordinating the entire music. So each of the persons, each of the singers or musicians in the team, they will perform based on whatever commands is given, whatever directions is given by that central coordinator. As you see in this diagram over here, so it all depends on that one person. So for example, if you have this orchestrator interfacing your client requests, then there will be no individual interaction between the different services. Instead, the orchestrator will have all the business logic in it as to whom to call first, whom to call next, or if there is any condition whatsoever. On the other hand, there is another system called choreography. Choreography is again, if you think of a music choreography, a dance choreography, where all the dancers do their bit, they know what to do, and there's no central coordinator over here. Each of them knows when to do what or when to perform which action after the other person. So basically what happens is that here this is implemented in event stream, which means that again this is a pub sub model, and all the services basically subscribe to the event bus or event stream, and then each of the events just produce each of the services just produce an event which is consumed by the other service, and that's the way they communicate with each other. There is no central coordinator. Advantage is that there is no single point of failure, of course. On the other hand, the choreography is a bit complicated, especially to troubleshoot and monitor things, because the entire logic is distributed over here. And so if there is a very difficult workflow, quite complex workflow in your system, you better go with a orchestrator pattern. Okay. Moving on, we'll see some more patterns over here. Uh, as you've seen in choreography, the main emphasis is on decoupling, and as a result of that, what we usually end up doing is adding a layer of abstraction in the system, and we will see that being repeated in a lot of patterns actually. The next thing which we'll see is a very common need that we have. So a lot of times we have a logic of, let's say, top N firms we need to show to a user who are onboarded to a specific business program, or we need to show some order summaries for order which will be selected by the customer. So in all these cases, what happens is that when the customer ends up in that page or screen, we need to have that aggregation done. And if we do that repeatedly every time somebody comes in a system, that will actually end up in a performance hit. So in order to avoid that, one of the patterns which we use is called the materialized view. In this, what we do is that we have a view created which has the aggregation done upfront with that storage. So, and that aggregation is a kind of a snapshot which will be used to show the aggregation to the customer, and we don't have to repeat that processing every time the customer lands in that page. So that's the example of a materialized view concept. The next pattern is about decoupling a request from the controller and the business logic. So again, it's a matter of abstracting things and decoupling the controller, which is handling the requests, and the main business logic of the system. So you want to introduce an abstraction over here to decouple these two. And the way we do it is by using something called a mediator. A mediator is nothing but a mapper which will map a request to a handler which is actually going to process that. And this pattern is used a lot of times with CQRS, which we'll see in the next slides, wherein we map a request to either a query or a command handler, depending on whether it's a query or a command to be processed. Okay, so that's the materialized view and the mediator. Event-driven systems, we introduce asynchrony, and with asynchrony comes some tricky situations to be dealt with. Let's consider a seat booking system. And due to the asynchrony in nature, what happens is that let's say that we are already in the last seat to be booked, and there's a request to the API, and the API accepts that request for the last booking, and of course the booking in the actual database that has still yet to be done because of the asynchronous nature of the communication. And meanwhile, there's another person coming in and he's asking for the view of the system. The view to be shown to the system, that user, will be that the one system, the one booking still left to be done. However, we know that it's just a matter of seconds that the system will be consistent and the user will be shown that it's not is a full the bookings are full, right? So that is called eventual consistency. Some systems are okay with that, like the online air ticket reservation system, where airlines usually, due to the reason that there are a lot of cancellations, they are okay to have that problem and go overbook with their bookings, right? But eventual consistency is there to be with asynchronous systems. Another important pattern, which is a lot of times used with event-driven systems and microservices, is the CQRS, or command query request responsibility segregation. So basically, the problem we are solving is decoupling the reads from the writes. So a lot of times what happens is that you will have a transaction database, and you will have a read database, and your all the transactions are being in that OLTP server, and there's a data warehouse kind of a server which is actually used to serve all the reads. Similar thing over here. It's a kind of a same kind of concept applied to application models, where we have separate application model for read and separate application for model for writes. As an advantage, we can scale the reads and writes independently over here. Any change to your write model, you don't need to change your read model, and vice versa. There's no contention. So basically that is CQRS for you. Example of code is given here, like you have this iCustomer service. We have all the getters and the writes mixed up over here, whereas here we have decomposed it into write and a read service. So basically all the changes that in the system is done in the write and all the getters in the read. So that is the CQRS. And a very good example of how it is used is over here, where we have this two different flows for the command handlers and the query handlers in this, and we often use a mediator in between to map both of them. Another common pattern which we use is the outbox pattern. So the problem is that in an eventing system, basically we notify changes in state of the system. Now what happens in an order creation if the order has been created in the order table, but while logging the event, there is an issue, there's an error, exception, and due to that, what happens is that you get the order created in the database, but the event is not logged. So to prevent that kind of scenario, we use outbox. Basically, what that means is that typically what happens in your Outlook, like you have a outbox where your mail stays till the issue is being resolved. Similar to this, we have a table for the events, and we don't log the events straight away in the event bus. Instead, the the events are logged in that table, and then the event publisher takes that and publishes it to the event bus, and then it is deleted from that table. Until that time, it stays there. So it's a two-phase kind of thing, and it is called the outbox pattern. Next, we're looking at something called event sourcing, which is a very popular system today. So to understand, let's take an example. So let's consider that we have a shopping cart, and the state of the shopping cart right now is this, like we have a item ID 20 with quantity 5. Next, what happens is we have an entry added in the shopping cart for item ID 21, and so now we have two items. Next, what happens is the one item has been deleted from the shopping cart, as you see. And then what happens is that an update has happened in the shopping cart, and the final state is this, where we have item ID 20 with quantity 10. Now, the same thing which we'll see now in the event sourcing system. Everything will happen in terms of events. So the same thing now, the first state of the system is represented by this event, where item added in cart is an event, and there are some other details. Next is another event, item added in cart, this time ID 21, right? And the same details are there in the event. Next is that item is deleted from the cart, item ID 21. And next is item ID, item updated in the cart for item ID 20. So if you see here what is happening, the current state is truth in the traditional system. Events may or may not be logged, but in an event sourcing system, events are the sole source of truth. As an example, Git is a very good example of event sourcing system, where all our commits and whatever we do in the Git, right? Everything is actually logged as an event, which is why we can just take everything anywhere and just log it to the current state. Another important problem which we face in distributed systems is tracing. So again, in a typical traditional monolith kind of a system, tracing is going to be trivial. Why? Because whatever happens, you have control in one single system. However, when the same thing is distributed, especially your events, the tracing now has to be done in a distributed way. And this is basically dealt with in two ways. The one is called a correlation ID. Using a correlation ID, we usually correlate different contexts of the same chain of events that are happening, or the tracing that is happening, right? So event logged in the order service, an event logged in the inventory service, all of them will have one single context, and that correlation ID is basically tying up them. And the other way is using some tools for distributed tracing like Jaeger, Serilog, ELK, Splunk. All these are good enough to implement the distributed tracing in microservices. Two important ways to implement event-driven style of communication are webhooks and SignalR. So if we talk about webhooks, as the name suggests, it's just a hook to the HTTP request response communication. Consider this ASP.NET application over here. So we have a webhook source which is emitting some event, and this ASP.NET controller is receiving an HTTP callback in this case, and this is tied up to a webhook receiver, and then that connects to a webhook handler. So this is another way of implementing event-driven communications. The SignalR basically works on top of WebSockets. It's a very efficient mechanism on top of WebSockets, wherein it has a SignalR hub which emits events, and we can have different clients subscribe to those events. By the way, webhooks and SignalR are both mechanisms of handling situations like a live dashboard where you can't wait for a request to trigger the state change of your dashboard. You need to have instantaneous updates, right? So now this slide is showing you three use cases, three very common cloud native use cases. The first one is Azure Event Grid, and it's basically compares to AWS SNS or Event Bridge. It is used for notifying status changes, low costs, serverless, and it's very good for reactive programming. On the other hand, Event Hub is used for streaming use cases, and it's for situations where you'll have millions of data, big data streams, and again used for IoT. And the third one is Service Bus, which uses message bus capabilities, PubSub model, and uses a lot of message brokers like RabbitMQ and SNS plus SQS in AWS context, reliable messaging and optional ordered delivery, and very good for enterprises and high value data. Okay, so these are cloud native EDA use cases. So now very quickly, let us see a use case that I have been involved in. It's a medium scale investment bank for a financial accounts reconciliation system. The main features of consistency and availability were important, about 50 transactions per hour and 100 concurrent users requirements. Initial state of the system, so it was basically a transformation from on-premise, from monolith to microservices. Initial state was about the AngularJS front end, ASP.NET backend monolith, MS SQL Server 2012, TeamCity Octopus used for DevOps, and IIS web clusters and etc. The pain points are shown here, like low speed of releases, availability and reliability, and low response time. And this is the transform state where we had Angular 11 front end with micro front ends, ASP.NET Core microservices with separate databases, and MS SQL Server 2012 partitioned in order to have some optimization, Docker containerization, Kubernetes container orchestration, and ActiveMQ message broker. And of course, some of the plans are for the future to move to cloud and use AKS. Architecture of the system is basically this. So if you see here and try to relate it with the orchestrator which we saw previously. So we have different services, microservices. Each of these microservices are basically different sources of reconciliation, and the orchestrator, recon orchestrator, is basically figuring out which source to actually give the command to, and that is where the business logic resides in. In between, we have the ActiveMQ message bus, of course. So this is an example of an orchestration. Now, second use case, we are looking at a cloud native multi-tenant auditing system So in this case, the NFRs are shown above, like consistency, availability again, and there are 99.9% availability need and 70 to 30 read writes. Initial state is as shown over here. It's a monolith again, and ASP.NET Legacy Web Forms is there, and we didn't have any CI/CD. And again, the issues are the same once more. Let's see the transform state. So we have again micro frontends with Angular 11, ASP.NET Core microservices with separate DB, and MS SQL Server 2012 again, partitioned and sharded in this case to implement the multi-tenancy, and Azure DevOps for DevOps and Docker containerization with Azure Kubernetes, and we had Azure Service Bus. Plans for future to use WebSockets and SignalR for some live dashboards. Let's see the architecture. So in terms of the architecture, the main difference over here you will see is that we have services like party management, user management, audit management. So and each of them are basically publishing events on different Azure Service Bus topics, and each of them are also subscribing to some of these events. So this is an example of, if you can relate to, choreography, right? So that's an example of choreography which was used over here. Again, as I say, if you have a complex workflow, go for orchestration, not choreography. Choreography is good where you have small services and less number of services, less dependency, not a workflow as such. So in our last case study, we're looking at a medium-sized investment bank, and this is a cloud-native solution for a process called advisor onboarding, where we have different kinds of documents to be processed for these advisors, like some for background check, some for criminal investigation, and all these kinds of documents. We have different ways of parsing them, and we have different extractors written in serverless lambdas. So we use something called a router lambda over here, which has the main logic of uh, orchestrating and routing it to different queues, and different types of extractors have subscribed to these different queues, and that's how this works. It uses mostly SQS as an SNS way of communication, and mostly using chain of lambdas, and it's a serverless solution. Finally, we have reached almost the end, and now what we have to do is take the lessons learned, right? So in terms of learnings, we have a lot of them. If you're not ready, if you do not have, if you have your business logic in your database, you are not ready for any kind of transformation. First one, which I found out, loosely coupled is something mandatory with dependency injection. Knowing your cap is very important. Avoid single point of failures, and always make it testable. It's not a choice, it's mandatory. DDD is a very good way of designing things, domain driven designing. And CI/CD is again must. It has to be there. And events are replayable and atomic. So and don't make them chatty. Capture enough details in events, and retries again are something by default you will have to have. For example, with frameworks like Poly, prefer serverless and stateless services, and sometimes use chaos testing. So yeah, so those are some of the learnings for you. And if you have anything to discuss or have any questions, you can get in touch, and I'll be more than happy. So that's pretty much all. I have some references over here. So thank you. And I always believe that the more we discuss, the more we learn. So I have given my email ID there. Please reach out if you need. Thanks. Bye.
All right, so that was Kaushik from Nagaro about event-driven architectures. We'll be moving on to Gautam Upadhyay from Microsoft. He'll be talking about distributed application runtime. Hi, Gautam. How are
Hey,
you?
hi Anurag. I'm doing good. How about you?
I'm fine. Thank you very much. So I believe
Awesome. First
you
of
will
all,
be
thanks for having me.
sure.
Great to be
Sure.
talking to you as well.
Yes, same here. Thank you very much for joining in. So you'll be talking about DAP, that is distributional application runtimes. So I believe you can go ahead and start sharing your screen now, and I'll
Yep.
put you on the stage.
Awesome. Thank you so much, Anurag. Yeah, let me share my screen and then we'll start off with the presentation that I have open. Just give me 1 second, please. So, quick check. I hope you are able to see my deck, right?
Yes, your deck is visible and it's live right now.
Awesome. Thank you so much, Anurag. All right. So, yeah, first of all, like I said, thanks for having me. Yeah, it's been a great journey so far in terms of me working with cloud. I thought I'll quickly introduce myself and kind of tell you guys what I do and what's some of the things that I day in and day out do for our customers working with Microsoft, right? So I'm basically a senior global cloud solutions architect. What that means is I work with enterprise customers to build solutions with various building blocks of Azure in order to meet them or in order to meet their business objective, right? So, as part of my role, I help architect solutions, which kind of takes care of all the architectural principles, right? May it be the security side of things, or may it be the performance side of things, or may it be the cost optimized architectures, or may it be anything to do with reliability and operational excellence, right? So these are some of the core areas I kind of focus on, kind of helping our enterprise customers achieve their goal, specifically around application and infrastructure side of things on Azure. So in today's talk, we're going to focus on the distributed application runtime. Now, I truly believe this is going to take uh, the world by storm in terms of the microservices way in which we build application. And probably post this session, you'll agree with me in terms of what Dapper is and how Dapper kind of helps microservices development and kind of how it makes a developer's life easy in terms of reliability, security, and some of the portability aspects of things which always it's some of the challenge, it's one of the challenge, right? Designing portable microservices applications. So that's the agenda. In terms of modern microservice architecture, you can think of any application that you're building today, right? So obviously a world is moving from monolith to microservices architecture, and few of the goals of microservices architecture is to effectively scale out and then do it in a cost optimized and efficient possible way. And the second aspect, like I said, reliability is something which is core of any microservices architecture. So how do you build those reliable architecture is something that you'll be focusing on when we are developing microservices architecture. And as a developer, you don't want to kind of worry about the plumbing infrastructure components. You just want to kind of write those microservices which kind of solves a business problem, right? And then we are kind of transitioning to a serverless world where we kind of write minimalistic code which will kind of take your code to the cloud, right? So if I had to kind of visualize that, right, like you have bunch of code, you want to kind of move it to cloud to kind of get your microservices up and running. So how seamlessly you can kind of get or achieve that is another objective that you will be typically thinking when it comes to microservices architecture. And last but not the least, you will be writing these microservices in your own set of programming languages, right? So you might be familiar with Java, you'll write microservices in Java. You might be familiar with Node, you'll basically write with Node, or anything of that sort, right? So that's the objective of typical modern microservices architecture. But with those objective comes the challenge, right? Meaning there are so many tools and runtimes out there which kind of tries to help a developer, but eventually it's going to be a bit complex and it's all disconnected and disjointed set of tools and frameworks that are out there, right? And the other challenge, if I had to talk through, is the coupling of the runtimes versus the language. So sometimes you will write something, but it is not language agnostic, but it will be kind of tied. The feature set will be tied to a specific framework or a language, which is again a challenge, right? Like let's say tomorrow you have to refactor and redeploy your microservice because you are tightly coupled and you're kind of closely coupled with your language runtime, you will have problem. The last bit is obviously the portability, and I believe this is a common pain point for every microservices developer or every company as of today. Meaning they might be running in on-prem or they want to move to cloud. How seamlessly you can do portability, or maybe like you're running on a specific cloud, you want to kind of move that microservice from one cloud provider to another cloud provider. And personally, trust me, I've worked with a lot of enterprise customers. This is the biggest pain point that I see. They would have written microservices targeting maybe on-prem. They would have written microservices targeting to a specific cloud vendor. But in order to take that particular microservice, deploy it to another cloud provider, it takes a whole lot of effort. And I have seen projects ranging from 3 months to 2 years, 3 years kind of time frame in order to achieve the portability aspect of moving a microservices running from one particular cloud provider to another. So the answer for all of that is Dapper. Now, Dapper kind of solves all of those problems in terms of language agnostic, platform agnostic, reusability, uh, taking care of some of the best practices that you require for building your microservices, and really kind of running it anywhere. That's the whole and soul uh, goal of a distributed runtime, I mean, application runtime. And this was primarily initially built with a bunch of community folks, and it's something that Microsoft also kind of contributes to. And basically, what we have done now is this particular project is now part of Cloud Native Foundation project. So you'll you'll get to see all other names like gRPC or CADA along the lines of Dapper. Right now, if I had to kind of summarize in terms of what Dapper can build, so you can think Dapper as building blocks, right? So in a typical architecture, what do you do, right? You take building blocks, you kind of make those building blocks and kind of create a Lego. Now, these building blocks are the Dapper's foundational pillar. So, what that means is, let's say you have a need for observability, you have a building block. Let's say you have a need for PubSub, you have a building block. Let's say you have a need for state management, you have a building block. And what you can really do is connect all the building blocks together with the help of Dapper. And like I said, Dapper is language agnostic. You can use any language, any platform to kind of run Dapper. End of day, it is an API call. So as a microservices developer, you will be interacting with a Dapper sidecar, and that sidecar can be a sidecar process or a sidecar container. But eventually, your application will be interacting with Dapper, and Dapper really does the heavy lifting for you, right? So Dapper takes care of managing your PubSub, Dapper takes care of managing your state, Dapper takes care of managing your observability, Dapper takes care of managing your secrets and what have you, right? So we'll basically see all the stuff in action. But like I said, it is community driven. Like-minded folks like you and me are kind of working together in terms of making Dapper better. And it's vendor neutral, right? Like today, you kind of run Dapper on on your local machine or anything on cloud. Basically, you can reuse the Dapper components across. And I talked about some of the industry best practices, right? Some of the things are baked in the platform so that you don't have to do some of these stuff on your own. For example, the retries for calling your APIs, or making sure your application is resilient and things like that, right? And then the end-to-end security is also kind of taken care by Dapper, and I talked about observability. That's also kind of part of the Dapper. Now, if I had to summarize in terms of what Dapper is and what Dapper can do, uh, this slide is kind of best depicting what objective of Dapper is going to solve, right? Like I said, you might have a scenario where you want to kind of store the state information, may it be on-prem, may it be on any cloud. You will basically interact via Dapper to state management. And state management is really set of configurational files which are set exposed with set of APIs or SDKs that you can use in your own language, and you can interact with the Dapper, and Dapper kind of does that heavy lifting for you. So these are some of the components of the building blocks. Service to service invocation. Let's say you have multiple microservices, you want to interact with all of them. Dapper kind of helps you to bridge that service to service invocation. Or if you want to have state management, let's say you want to store it in DynamoDB of AWS, you can do that. Let's say you want to store the state with Azure Cosmos. With few configurational changes, your microservices can change the state in which it kind of operates. So it's kind of plug and play kind of model, where with a set of configuration files, you can really plumb in terms of what you want to run and what you want to kind of bind with. So Dapper kind of does all of this for you. So it also helps you with PubSub. So the underlying PubSub can be anything. You will be interacting to Dapper via PubSub kind of model, right? So there are a few other things like bindings, triggers, actors, observability, configurations, and secrets. That's also kind of baked in, and it's all exposed via HTTP API or gRPC API that you can interact with from your any application targeting any platform. Now, this is what I was talking to you. So your application, whatever application that you are writing, you will be interacting with Dapper with a set of APIs. Now, those APIs, depending on whether you want to do PubSub, whether you want to do state management, that will go and talk to different data sources based on-prem or any cloud and things like that. But eventually, your app is going to talk to Dapper, and Dapper is going to talk to the state management service, and the underlying implementation is what it doesn't need to know. And things like service to service communication, let's say service A wants to talk to service B, all that is again possible via Dapper. So these are some of the building blocks. Let's kind of dwell deep in terms of understanding what are these components. And like I said, it's all swappable, right? Meaning today you write your application to target on-prem, or you write your application to talk to any state store which is specific to a specific cloud vendor. Tomorrow you can easily plug that out and then punch in the new set of YAML file that will now kind of start talking to the other data stores that you have. So it's really plug and play kind of architecture, swappable YAML files through which you'll be doing it. And like I said, these are the building blocks. Like if you are having a need of talking to a data store, you will use Dapper to interact to the state store. If you are in need for building your PubSub, you will interact with Dapper for doing that PubSub, and that PubSub can be anything, right? So you can replace this PubSub with any of this with ease, or with a bunch of YAML constructs. Everything else is kind of taken care by Dapper for you. Similarly, you have triggers, you have secret stores, you have observability, meaning you kind of target Dapper, and you kind of make sure your application works for Dapper, and Dapper kind of maps that to any underlying observability or data store or PubSub that you have. So yeah, I kind of talked about this. Basically, it's a sidecar model. Everything is kind of invoked in an API way. Like I said, uh, depending on what building blocks you are using, you will be interacting with those APIs. If let's say you're dealing with state store, if you're dealing with PubSub, if you're dealing with secrets, eventually you will use these keywords in terms of the API calls, which will kind of do that mapping for you. So eventually, your application will be calling these HTTP endpoints via HTTP or gRPC, and Dapper kind of talks to the any data store that you might have. So if I had to pictorically represent, this is how it will look like in terms of building portable microservices application. You might have multiple microservices running, may it be in on-prem or may it be on any cloud. And these microservices really have to talk to each other in terms of service to service communication, or it has to talk to a pub sub, or it has to kind of talk to a state store. It has to talk to in terms of observability or secret store. Everything is configurational, and the same microservices that you write with few changes in the configuration code, you can make it work across any cloud, and it can work for any programming language and any constructs. So that's the beauty of Dapper. And if I had to kind of show you end to end how it looks like, uh, you might kind of write a front end application. You might have different microservices, right? For example, checkout, shipping, inventory, and the cart and payment kind of microservices. Now, these microservices uh, can do service to service communication via Dapper. It can talk to the data store via Dapper, but right now, if you see, it's kind of hooked up to Azure Cosmos and Kafka and what have you, right? But the same application, you can kind of break it down, and you can make Dapper to kind of work in terms of platform agnostics, right? So in this example, what I'm going to show you now in next 5-10 minutes is a demo wherein I've created a couple of microservices, or in fact, three microservices: the order service, the inventory service, and a store API, which kind of orchestrates the different calls. And these microservices are calling state stores, and they're kind of doing service to service invocations and things like that. And I'll show you how easy it is to kind of build such Dapper based microservices application that kind of reduces the complexity of doing things. So what I'm going to do now is going to show you some of these things in action. Basically, I have put my code in the GitHub repo. So if you see here, this is the GitHub repo where I have put. So what I can do is I can click on something called local. I can basically clone this repository to local, or what I can do is I can run this particular application in something called as code space, wherein a machine will be spawned out on the cloud, and we will be able to run an application onto on in within or a container based application, which is kind of code based, right? So what I'll do is I will run my application now in the code space, and while it runs, I will show you what I have done in my microservice. Basically, if you see here, I have three microservice. uh, there is a Go service, there is a Node service, and there is a Python service. Now, all different language, different microservices. Basically, the Node service is the front end application that I just showed you uh, in terms of the approach. And just give me 1 second, kind of got frozen. Not sure, maybe it is because of this. I will just kill that and hope I get that control back. Okay, so essentially, if I go to the node service and if I go to my routes, so here basically we are seeing an application which is written in Java, JavaScript, and that is calling basically a Dapper endpoint. If you see here, I am creating a sidecar and I'm interacting with the Dapper. And post that, if I had to invoke any other microservice, I will be interacting with the Dapper sidecar. All that I have to do is just pass the Dapper ID, and post that I will be interacting with the Dapper sidecar. So if I had to do a get or a post request, which is gonna call a specific microservice called order, I will be essentially calling that microservice, right? Similarly, I have I have application written in Python that is gonna talk to a data store. And basically what I'm doing there is I'm kind of writing it onto uh, the local Redis instance because that's kind of lightweight. So if I had to show you how I'm interacting with the state store, basically all that I'm doing is creating a Dapper client, and post Dapper client, all that I will be doing is I'm going to be calling get state or put state or what have you. So anything that is going to be done with get state will go ahead and talk to the Dapper, and Dapper will do the state management for you. Now you might be wondering how is all this happening, right? In terms of where am I defining those uh, the state management or the definition in terms of YAML that I just talked about, right? Now that's the beauty. So Dapper, you can define a YAML file, which kind of takes kind like a component, and you can basically specify the type. So if you replace this type by, let's say, maybe Azure Blob or Cosmos, all that you'll be doing is you'll be interacting with Dapper, and Dapper will kind of write this to a Cosmos or to a document or database or to a Redis instance or anything. Basically, all the supported all the supported channels through which you can kind of do in terms of state store is all documented. Meaning, if you want to write to a Cosmos, all that what you have to do is just specify the state. In this example, if you see, I'm specifying state as DynamoDB, and if I rerun my Dapper application, now I'll be able to kind of connect and talk to the DynamoDB. If I change this to Cosmos, I'll be able to kind of talk to Cosmos. So similarly, you can pretty much do all of that by uh, just changing the configuration. So that kind of gives you a good flavor of what portable application or portable microservices looks like. So I just wanted to show you a couple of case studies in terms of how this can be achieved. Basically, any application that you want to develop. In this example, we have a front end load balancer, which is layer 7 load balancer that does kind of passing the traffic onto the pods via an ingress controller. And really, those set of APIs that are written in Java are talking to the Dapper sidecar, and Dapper sidecar is in turn doing that heavy lifting in terms of secret management, state management, and PubSub. The advantage of doing that is I can replace any of this with anything. For example, tomorrow I decided, let's say I want to change this to Azure Blob Storage or to a Redis that I'm running on cloud. It's just set of configuration changes that I just showed you, right? So that's the advantage in terms of writing portable application. You need not touch or change anything with respect to your application. Just by changing the configurational files, you'll be able to run a Dapper application anywhere. So the second case study that I wanted to show is again from one of our customers. Basically, it is a microservices application. Like you can think of a typical e-commerce application, right? Wherein you have orders, you have payments, you have delivery options and things like that. And everything is basically set of microservices that are running in a Kubernetes cluster. It's front-ended by order processing system. And basically the same pattern, any microservices will interact with Dapper, and Dapper in turn kind of does that uh, configurational thing to make sure that secrets or data store or PubSub or the state store is kind of handled for you. So in this way, like you are building a microservices which is uh, cross-platform, cross-cloud, which is language agnostic, and you'll be able to achieve something like this with the ease. So yeah, so we kind of talked about all of this. Let's do a quick recap and then we'll call it off. Basically, we looked at service invocation. Like I said, your app will interact with Dapper. And let's say microservice A has to talk to microservice B. uh, You'll be kind of using Dapper to interact via the Dapper with respect to a secure MTLS kind of service. Let's say you want to do a pub sub. your application will talk to Dapper, or microservices will talk to Dapper, and that Dapper will be able to keep will be able to basically hook up to any specific PubSub model that you have today. All that you have to do is just change the configuration and you're good. Same with state management. Let's say today I have an application that is talking to Redis. Tomorrow, let's say I decided I want to kind of make sure it works on Cosmos. All that I need to do is just change the Dapper configuration file, and I need to change from the Redis to Azure Cosmos, and your microservices just like that work, right? And in terms of APIs, you'll be eventually calling Dapper set of APIs to do the same thing. Nothing changes whatsoever in terms of your plumbing logic, right? So in terms of observability, I mean, today you might be using Datadog or Zipkin or what have you, right? Or application insights. Tomorrow, let's say you decided to change to something else, you don't have to change anything, configuration file, you just kind of use the observability capability of Dapper, you're all set. And I've seen majority of my customers struggling just with this bit, right, in terms of end-to-end monitoring, and they would have probably taken some native solutions of a specific cloud platform or something with on-prem. In order to refactor to make it work on cloud, it's the biggest challenge. So Dapper kind of solves that top challenge for you. You just need to change configuration files. You'll be able to do that. Same thing with secrets. You might be hooking up to any secrets that you might have, uh, but once you target Dapper set of APIs, you will be able to change the secret. So in this case, if you see, I'm using HashiCorp Vault, and I can kind of change that to Azure Key Vault if I need. Right. Same thing with input triggers. Let's say you want to have based on an event, you want to do something. Again, Dapper triggers can be used. Or if you want to bind something based on an event, you have different connectors and that can be used in order to kind of do those triggers and bindings. And yeah, same thing with virtual actors. You have basically a stateful object for storage and compute that you can use. And basically, it can handle that virtual actors for you. So Dapper kind of does that actor bit for you. And yeah, the syntax goes something like my actor. So yeah, basically you can run this Dapper either, like I said, on a standalone process or on a container as like a sidecar pattern, a sidecar container pattern. You can self-host it, or you can basically run this anywhere in terms of a Docker hosted environment, and you should be able to kind of run it on Kubernetes as well. And basically, yeah, you will deploy or you will instantiate Docker runtime in your cluster on any cloud, and then your application will just start talking to the Dapper components, and Dapper will take care of anything in terms of PubSub or secrets or anything of that sort that we discussed. And last thing that I wanted to highlight is there is this confusion in the industry in terms of service mesh and Dapper and what it can do. Basically, if I had to summarize, the service mesh is primarily for traffic routing or traffic splitting, and in some cases, it helps you with tracing and metrics and resiliency. But Dapper is much more beyond a service mesh. So Dapper is basically a bunch of building blocks which will help you to do service to service communication, which will help you to do state management, helps you to configure PubSub, helps you to configure input bindings and triggers and secrets and actors. And this is the key, right? Like you can run Dapper on any cloud, and you can write Dapper based application with any platform. So that's all about the building blocks and what have you. With that, I'm gonna stop my presentation here, and I want to pass this back to Anurag in terms of any questions that we might have or anything that we want to kind of discuss in the Q&A
Yeah,
panel.
sure. So, thank you, Gautam. That was really insightful, and I think the live demo was pretty wonderful to look at things. And I particularly like the way the presentation was built up. I mean, although a little bit of animation letting to know how the data is moving
Yeah,
and how it could be integrated into different other Azure components from IoT Core and as well as from a messaging queue perspective. So, I mean, I think that was really insightful, and how Dapper can really bring in the compatibility across the components at the input side and also at the side where you want to have your data punched in, whether it is the cold path, warm path, or the hot path data elements. So, I mean, I guess in totality, what I want to say is that it was a great presentation. Any comments from you to conclude?
Yeah, thanks, Anurag. Yeah, I'm glad that you liked. And yeah, like I said, Dapper is still evolving, right? And it's been almost like 1.5 years. We're seeing a lot of traction in the community, especially building portable microservices application. And it's really great that Dapper kind of abstracts all of that for you. So I've seen a lot of projects just to migrate from one cloud or from on-prem to cloud. It takes good few months to years. With
Hmm.
Dapper in place, it's just configuration change and you're good to go. And yeah, there are quick start samples in dapper.io. If you want to play around, if you want to kind of deploy it locally, or if you want to do it on cloud, yeah, you can pull those repos onto local and you can run them. It's all Docker based containers. You can kind of run it and you can kind of check things in action. But yeah,
Sure.
that's kind of exciting things that's happening in the microservices space.
Right, and with that, we'll bring this session or this talk to an end. I'll open the floor for Q&A. I'll bring on the speakers, and if there are some specific questions that we would like to ask the panel, please go ahead. You can post them in your in the chat sections also. All right. So since we have this time period for discussions, I mean, I guess another 20 to 30 minutes, I believe there have been a lot of talk around the cloud part, the gravity of all the talks that I've seen out here has been more around microservices and Kubernetes and more of moving away from the, how to say, the older full blown architecture diagrams that we used to have, where you had everything running from ground below all the up. So I mean, Ali was talking about the CI/CD pipelines, how things could be punched into production, while Gotham was talking about the Dapper part, where from on-prem you can go on to cloud part, and the mixed, I mean, hybrid cloud as the migration of data. Kaushik again comes from he brings both the things together. You've got an event-driven programming architecture, live dashboards, how they need to function, and then we go back to Benny, who has a rich experience about Kubernetes. I'm kind of thinking, in the whole architectural paradigm that we're talking about, there is one element which I believe nobody had touched, and I was actually looking forward to listen to all of this. There's a lot of MLOps work that is going on in this area, from machine learning. DevOps is there, but MLOps is also there. So when you have models and that need to be put into production, and there is a whole different pipeline that goes behind it, where Gotham also comes into picture, where data is coming at a very high frequency and high velocity, and that is processed, and model accuracies are being judged in the background, and then models are being deployed. And then the event-driven programming also comes into picture, where you have user controls, where you have model metrics controlling when deployment needs to happen. So I'm just wondering how all these concepts can be combined together in the area of data science if you really want to do that. Any thoughts from any of the leaders that we have on the panel today? Anybody would like to go? Sorry, if I
Yeah, I'll go first, Anurag. See,
sure.
basically, what's the problem? We have bunch of code. I mean, that code might be any microservice or any machine learning component that you want to kind of build and kind of want to deploy. Basically, taking that code onto the cloud, right? That's the challenge that we have. And if you look at any pipelines that you write as of today, it might be any CI/CD tool or anything that you take. The goal is the same. Like you have code, how easily you can take that code, make it work on the cloud or on the edge or anywhere to that matter, right? And that's the beauty of it, right? Like you might be following any architectural pattern, like you might be writing microservices application, or you might be writing machine learning application. End of day, you just want to have a seamless way in which you will build the code, deploy the code to somewhere. And really, one of the things that I wanted to share is the GitHub side of things. So if you look at GitHub today, uh, previously it was just a code repo. Now there are a lot of components that you can do in GitHub. For example, GitHub Actions. You can basically trigger a workflow, and you can take the code, build the code, and deploy it to any cloud or any place that you want, right? And that's kind of holistic, and it's taking advantage of everything, like security side of things. You can basically embed a small piece of code that will basically trigger, build, and then deploy. And yeah, I see any kind of application will be kind of going forward, will be in this model where how easy or how quickly you can take code, kind of get it deployed anywhere. So I think that's the gist that
Sure.
I wanted to share. Maybe others can pitch in with their
I
experience.
just got the the list of Q and A's as well. So we'll probably park this question and we'll come back to it. I'll straight away go to the first question that I have, and it's coming for Ali as of now. It says, can resource quotas and limits be configured so that in case of resources, example CPUs, are currently not needed by other teams? And a follow up of that would be the second part of the question. This is they're available only if the other teams require those quotas taken, so the neighbors can be noisy as long as I'm not at home.
So absolutely, you can overcommit. So you're not going to get. So say you've got 8 CPUs on your node or on your available in your cluster, you can definitely overcommit. And what's interesting about CPU is it's only going to start throttling once you start going over that resource quota. But with memory, you're going to get out of memory exceptions, and your pod's going to be restarted. So you need to watch out for that. But yeah, sure, you can totally you can totally go above quota with the understanding that if everybody starts being noisy at the same time, you're going to run into problems. But then you can look at horizontal node scaling at that point to try and take that into account as well.
Sure. Okay. So I'll go to the next question. Probably I'll engage Kaushik over here. So Kaushik, this is for you. That you mentioned something at the beginning about no polling, but using the outbox pattern will need it, right?
Hey, so I'm audible?
Yes, yes, you are.
Yeah. So when I said that the polling will not be required in an event-driven style of communication, what we mean is that uh, without the events, we have a need of asking, or which we call a request-driven communication, wherein like the requester is initiating the communication. As I gave in my presentation, the typical example of that restaurant wherein the customer is having to ask for his status of the order, whether it is ready or not. And probably the waiter is having to say that, please wait. So that's the typical wait that we want to avoid. And that's inevitable in a typical HTTP request response protocol, right? And the inherent reason for that is the synchronous way of communication which happens there. And as they say often that there is a saying that tell, don't ask me, right? So the thing is that don't ask, but actually tell, which is like push the notification to the person who is interested in it. So what happens in events is that we have a pops up model wherein if I'm interested in an event, I will have to subscribe to that, and automatically I will get the notification. So that's why I said that we don't need polling. When we have two different microservices, in order to communicate between them, you don't need to ask. You get the notifications when you subscribe for them. The outbox pattern is where is a way to avoid uh, issues in the transactions, wherein like if you have some kind of a distributed transaction where you have a event, you will have to do two things. you will have to log the event, and of course you'll have the actual operation done. And if these two are not done without any issue, and again, like the eight fallacies of distributed computing, right, which is one of my favorites. So it will always happen. That's what you'll assume. So given that, what we are doing essentially is that we have a repository to which we log the actual operation, and then there is a different process which polls and just makes sure that that event is actually getting logged. In case of an issue, there will be a retrial for that process, but that process is, you can say, like a outside the scope of the main business context in this case. So you still have your microservices running with minimal polling, if you wish. So
Sure.
yeah.
Okay. I'll go to the next question, which is for Gotham. So with DAPR, what about latency? If we do it also for state and so persistent data in DB, would latency be increasing, Gotham?
Yeah, that's a great question. And to be honest, like whenever we are doing microservices application, right? So you'll have multiple hops, and obviously Dapper is gonna be one component that it has to pass through, but it'll be in the order of magnitude of few milliseconds, one fraction of few milliseconds. And when we have tested it or stress tested it, uh, with the observability piece in picture, whenever there was an API call, right from the client all the way to the data source, you'll be able to kind of look at the end-to-end piece in terms of where the time is being spent. And like I said, it is few fraction of millisecond through which Dapper kind of passes through. But end of day, it's a API call, right? So obviously it has to execute something. It has to look at the configuration, kind of talk to the right data store. Obviously that is there, but there's always the trade-off, right? Like you get a lot of other benefits with Dapper. So you get things like portability, any language, any platform development, and things like that. And yeah, eventually you'll basically pick and choose across all of these advantages as compared to latency. But yeah, that's a great question.
Sure. I guess there was another question on the same lines about maintainability and Dapper versus cloud native API. So I guess it covers into the same bracket. I guess, Gautam, there was just one more question which was around Dapper again, and since because it's more around the cloud area, which goes like this: with Dapper's abstraction, don't you lose a lot of functionality? You could not use all the features of those infrastructure services. And while you answer that question, I'll show the follow up of this as well.
Yeah.
So these building blocks have a lot of differences in feature sets, not just performance. So basically, I think what they're asking is about functionalities, and are we losing something on top of that?
See, exactly. So there are few capabilities which are like very native to a specific platform. But like I said, Dapper is evolving. Most of the usual suspects in terms of feature set capabilities are there. But if you need more, again, this is a community, right? And we are building with the community. So the more and more community gets involved, the more and more features and functionalities come in, the more and more mature Dapper gets, the more and more reach it kind of gets through. And it's a journey. And what I anticipate in next few years, this will be the new norm. Like people use Dapper as just like any other programming constructs. It will be part of any microservices development, and the community will build features for different set of components that are involved. May it be the data store, may it be the pub sub side of things, and things like that. So eventually, whatever differences in parity in terms of feature will be covered. But you're right, there are limitations in terms of what you can do today and what offers the native side of features functionality you get. But we are getting there. But like I said, we have seen a lot of production grade application across a lot of enterprises deployed and running expected, like working as expected with all the benefits that I talked about. But yeah, there is this feature parity that kind of exists, but it eventually will catch up. And I'm kind of envisioning that Dapper will be kind of having those every functionality in terms of any feature that you're looking at. And there are some in production ready phase. There are some still in development phase. But like I said, eventually everything will be catched up, and then you should be able to do it just like how you do it with the native side of things.
Sure. All right, Kaushik, the next question probably goes to you. It says, could you please elaborate a little more on distributed transaction error handling strategies?
Yep. So let's start from the problem of distributed transaction, why it came. So if we go back to our traditional way of designing services, which we call a monolith system, wherein like we have everything in one place. So for example, let's say that you have an order processing system, and it's just one big chunk of code. In that you will have inventory, in that you will have the payment and different modules. So it may be a modular code, but it is still a monolith, which is again a different pattern today. So you can have that. Now what that gives you, that has an advantage, is that if you have to manage transactions between these modules, which is what will happen definitely, it's very easy. And which is why I often recommend people that think 10 times before you move to microservices. Microservices may not be for you, right? So yeah, so that's one of the advantages which you lose once you move to microservices, simply because of the fact that microservices is just one name for distributed computing. So things get distributed. Now your order system is in a separate process. Your payment system is in a separate process. So now what happens is that if your order has been processed and your payment is not through due to whatever reason, maybe the credit card of that customer didn't have enough money or whatever, in that case, what do? It's not a two-phase commit, because the order has already been processed and that database is already done with that commit. You cannot roll back. There is no rollback option over here. So the only thing which we can do is that we have something to compensate whatever we have done. And that is what we are calling a compensating transaction. So what that means is that, again, additional complexity. So whenever you design your transactions, you would have a complex compensating transaction corresponding to that main transaction, so that whenever an exception occurs, the compensating transaction can actually compensate whatever has been committed. And that's the saga pattern, right? uh, what I also said, that there are two different ways of implementing saga pattern. Of course there are other flavors as well, but orchestration and choreography are the two main ways of doing it. And if you use choreography, you are obviously choosing decoupling for your problem. You will definitely have decoupling. It will have a lot of advantages. You can scale each microservice independently. However, be careful, because choreography is good if you have small number of services. However, if you look at different real life use cases like Swiggy, Flipkart, they don't use choreography more often. They use a centralized coordinator which coordinates everything. And that's easy for developers a lot, because troubleshooting is easy, monitoring is easy, and of course, transaction handling is easy. You have everything at one place centralized. So, yeah.
All right. Uh, Kaushik, I would probably go to one more question at your end, which is implementing CQRS pattern. Should we always design it to use different databases for reads and writes?
Yeah, again, before going into the answer, I would like to say that if you're an architect, always take everything with a grain of salt. So don't do anything just because it's a happening thing. CQRS is one of the most popular things today. Whenever I see microservices, event sourcing, CQRS comes into picture. But I would still say think a lot before you implement CQRS. CQRS may not be needed for your use case. it may add additional complexity. However, let's go into this question. So, CQRS can be implemented in three different layers, if you wish. The first is that you will have separate APIs for the reads and writes. So, think about the problem that you are solving over here. Essentially, you are just decoupling the reads and writes. Whereas you had one operation, now you are having two operations or two separate endpoints for that matter. So that's the first step. The second step is that you want to even go and have separate application models or domain models for that matter. So separate domain models for reads and separate ones for writes. And then the final one, the final step is going to be different databases. So you want to segregate reads and writes even more in the database layer. And again, if you are a good architect, you will actually look at your problem, think that to what extent you will implement CQRS. Doesn't mean that you always have to have different databases for read and write. You can just do a semi kind of a CQRS and leave it to the domain models, same database. So let's be flexible over here, understand the concept, and apply as needed. Yeah.
Sure. Okay. Ali, I think this is more of a general question. If anybody would want to take up, what soft skill should a solution architect have?
Great. That's a fantastic question. If anything, I always like to think of software architecture more like people architecture, right? You got to think about when you're an architect, you very rarely got your hands on code. You're very rarely really the person who's implementing that architecture. You're always implementing it at a distance through maybe 1-2 layers of people until you actually get to the people implementing it. So really, being a solutions architect is all about soft skills, really, in my opinion. So communication is absolutely key. I don't know if you've ever read the Software Architect Elevator. It's a fantastic book with a really great initial analogy about how the software architect needs to be authentic down at the code level with the engineers, but needs to be able to not only talk the language of the engineers, but ride the architect elevator all the way up to the C-level execs and be able to talk in terms of business value and commercial challenges of the architecture, be able to talk that language too, and everywhere in between. It's a really great book. I'd really recommend it if you're interested in the soft skills side of things. Yeah, I could talk for hours on this, so I'll let one of the other guys on the call.
Anybody would want to go for this? Gautam, Benny, Kaushik, somebody. One more comment from many of the guys.
Oh well, so
Sure.
I think
Yeah.
you want to go ahead?
Go ahead, Kaushik. No, go ahead, Kaushik. I'll go next. Thanks.
Yeah, I think I was when I was answering some of these questions, I touched upon some of these things. I guess that communication sets apart a developer from an architect. So, in order to be an architect, you definitely need to be experienced a lot to different kind of software systems. But what's more important is what Ali just said, and that software elevator or whatever that I don't remember the name, but I have actually read a bit of it, and I know that it's talking about like you being a kind of software architect elevator, right? So you are the
Mhm.
middleman. You are the middleman between the coder who is just sitting and writing the code and the management who is just looking at the dashboards, right? So it's not a easy job. Yeah.
All right, so Gautam, I think there's one question on the deck that probably went unanswered. When would you? I'm sorry, that just went off. Sorry. When would you really prefer Dapper and or any other alternatives? And when from platform as a solution that provide the same features as part of the platform. So, what would be the decision point or the drawing line or differentiating line when you would want to choose it and when you would not want to choose it?
Yeah. So, see, basically, when you are leveraging some of the native capabilities, right? So you're tightly coupling that feature with respect to your application. Now, tomorrow, let's say you want to change it, right? You have to rewrite or refactor and do a lot of changes to make it work on any other platform or any other cloud or any way that you want to run. Now, that's the beauty of Dapper, right? If you are writing a new microservices application, why not leverage Dapper, which will kind of create that abstraction layer for you. And no matter what is behind Dapper, like let it change the state store, the pub sub, the secrets, service communication, and things like that. No matter what it is, you're not gluing your application with those backend systems, right? Like you are decoupling it. So eventually, you're just talking to Dapper, and Dapper abstracts that for you. So I would say Dapper will be the new norm of developing microservices-based application, and you'll see that, right? Like I said, already a lot of customers are exploring, and based on my experience working with so many enterprises, right? So they do as of today. With their custom implementation, meaning they will write some kind of abstraction and they will try to make it work on prem, they will try to make it on cloud and things like that, but that is an effort. Now, if someone has already done that and it's proven that it can work at scale, considering the security, performance, and reliability aspects, why not leverage that as opposed to build something on your own, which will makes it independent, right? So that's where I see Dapper has got a lot of potential in terms of how things would eventually shape up in terms of microservice development, as opposed to leveraging some of the native capabilities where you're coupling it with some platform specific features, while industry is moving towards more of open source kind of model, wherein you write once, use many, I mean anywhere, anytime, kind of with any platform.
All right, thank you. Just in time, probably one last question, and I think this might go to Kaushik. So Kaushik basically says we mostly use one ID to develop monolithic, systems. So microservices, a feature involves multiple microservices. So how many IDs does a dev usually use to have a coding microservices?
I believe the ID is not important. But having said that, what I would like to say is that an important advantage of microservices is that it encourages a polyglot kind of a pattern, wherein, uh, like in one of my previous organizations, we had a Java team and a .NET team, and like they were working on a separate ordering service, and we were working on a campaigning service, and it went pretty well because the teams can be totally isolated. They can work on their own methodology, technology, and whatnot, right? And in the end, we are actually building one solution, but the microservices pattern is helping us to achieve that. uh, so I guess, like, yeah, independence is in everything over here. Like, IDE is, again, like, you can use whatever ID you want for your microservice, for that matter.
I guess Visual Studio Code has probably become the de facto for everybody who uses
I was about
coding.
to say that, but somehow I restrained myself by not saying, because I work
I
for Microsoft,
personally,
right? But
yeah, I
but
personally
I've seen
use,
industry adopting Visual Studio Code.
yeah, I
Sorry,
personally
Kaushik, go
use
ahead.
a lot. Yeah, because I come from a .NET background most often, so I use it a lot. But yeah, I would be pretty much neutral over
One
here.
one little thing I might add is if you're making a change that is going across multiple microservices, have you really got the boundaries of your microservices right at that point? That might be a bit of a smell, maybe, that you do have the boundaries in the wrong place if a change means you need to update multiple services at the same time. So watch out for that. Just another thought.
Sure. Yeah. All right, so we're just in time, right on the clock. We've had a wonderful session from all the four subject matter experts. It was wonderful talking to everybody: Gautam, Benny, Ali, Kaushik. Personally, I would definitely say I learned a lot from what Ali shared, and Gautam, Benny, and Kaushik what he shared. uh, being there in the industry for more than a decade, but then I listening to you guys, I can definitely say that there's a long road for me to go to learn more things. Thank you very much for sharing your insights. It was wonderful. Thank you for joining us, all the people who have joined the Architecture Summit 2022. We look forward to all the participants stay along for the other sessions that are coming up. In the meantime, we'll have a 30-minute break coming up. Take some rest, have some coffee, drink some water, go around, stretch your legs. Have a great time. Good evening, and to everybody who still has their evening left, and to other parts of the world who are joining in. For me, it's about 2 o'clock in the night, so it's kind of a good
Oh,
time.
man. Anyway, thanks and bye bye.
Bye bye.
Thanks,
Thank you.
everyone.
Thank you
Bye.
all. Bye bye.
Welcome back, everyone. And now we want to say thank you to our sponsor, Site 24/7 by Zoho. Site 24/7 is a full stack performance monitoring tool, and it will help DevOps engineers and IT operators to monitor websites, apps, services, cloud, and network. And this is a part of Zoho Corporation. And today, if you follow the link that we will post in the chat, you will receive access to 250 US dollars value of services at Site 24/7. It will be added to your account, and you will be able to use it around 6 months. That's what it's worth to do the monitoring of websites, synthetic web transactions, and lots of great stuff. You can read more in the description, in the chat, and also you can click this link and you will receive this credit to your 24/7 site account. Thank you, Zoho, once again.
Okay, everyone. So we have a pretty long break ahead of us. So it's time for everyone to go stretch our backs to get something to eat, get a breather in general. And we'll be waiting for you in 25 minutes with 2 more blocks and 2 more moderators. So, yeah.
Hey everybody, this is Mike. Oh boy, this is the second round for me. I did a little stint last night. It was so super awesome. I mean, I'm just having such an awesome time here in an undisclosed location, by the way. And it's just my time now, my block. Hey, guess what? I'm gonna bring in my next guest here, and it's David. How's it going, David?
Hi, it's doing great. How
Is
about
it
you?
doing? How you doing? How's it in? Where you from? Where you talking
I'm from Tel Aviv. I'm in Israel,
Oh,
from Tel Aviv.
nice.
Yeah,
Nice. So how's the weather been? Sorry, I just
weather's
asking.
great.
Jealous.
Weather's great, thanks.
Yeah, cool. Hey, so what are you gonna talk about? What do you have for us today?
So I would like to talk about special topic. So about the war between mono repos and multi repos in the microservices world. So I would
Right.
like to take a special angle on that war and show people how to implement centralized CI, which is one of the issues when you're using multi repos, because
Right.
then you will need to implement it all over. And here I want to show an example of how to implement that within 30 minutes in Python. So that would be great.
Well, that sounds awesome, man. I'll tell you what, I'm gonna bring your slides in, okay? And just let me know if you need some help. And I'm gonna get off stage here, and you have it. And I'll talk to you later.
Awesome. Thank you very much, first of all, and welcome to my talk about forget mono versus multi-repo, building centralized Git workflows in Python. I would like, first of all, to thank the organizers of the Worldwide Software Architecture Summit for giving the opportunity to talk here. And my first thoughts are, of course, like many of you, to the Ukrainian people. We all think about you and will support you. The world is supporting you. So I would like, first of all, to give a little bit of word about me. Who am I, basically? I'm one of the 5 co-founders and the CTO at JIT, small cybersecurity startup dedicated to build a solution, a platform for developers to handle security, to handle product security. I'm passionate about technology and security. I've been in the field for quite a while, about 20 years, building software for leading companies like MyHeritage in the past, like CloudLock and Cisco, and so I'm really passionate about that. And now I'm working for JIT, and it's great to be able to implement and know the thing that I've been experiencing so far, and building a product around it. So the topic of this talk is around multi-repo and mono-repo. So everyone knows about the war that has been going for years in this area. Whether should I build something, all my microservices into a single repo, or should I use a multi-repo architecture? And both has pros and cons. So if we're looking at the multi-repo, of course, you have the independent deployments. You can have versioning differently. You can have autonomous work, meaning that you can decide to work with some language in one of the repos and one of the servers, and in another with another services. But you also have some issues about overhead in terms of management, and also sometimes teams are more siloed. That's one of the options, using multi-repo. And on the other side, you have the mono-repo, and there you have also some pros. First of all, everything is centralized, no overhead of management. It's easier when you want to refactor things because everything in the same place. If you have multiple teams, they can share the same culture because, well, you can have coding standards, and everyone can implement it in one place. But on the other hand, you have more issues about dependencies between teams, because all the people are working on the same code base. And also when you're tagging your whole code at once. So it's also something you want to think about when you want to consider one architecture versus the other. Now, I would like to talk about this specific topic here, and this topic of how do you handle CI in both architecture? Because on one hand, you have in the mono-repo, you can have a single CI pipeline, which is great, and this is one of the benefits, because you don't have any overhead in terms of management. On the other hand, when you're working with multiple repos, you have the issue that, well, basically you need to re-implement the same pipeline over and over. So of course you could, for example, have some templates to start your new service, and have the same templates used over and over. The problem is that what happens if you need to change something? Then you would need to replicate all the changes in all the different repos, and that's something that is a pain. But what if you could benefit from both for both type of architecture? So still having a multi-repo architecture, but having a central pipeline, and that's basically what I would like to suggest here. And I want to show you how you can really easily implement that. So the idea of a centralized CI system, it means that you would be agnostic to the type of architecture, whether you want to use a mono-repo system or a multi-repo system. And so you can leave the choice of the architecture to other considerations. And so if you want to use a centralized system, basically that means that you want to decouple your CI from the structure of your repositories. And this is what I'm kind of showing here is you have your ACM, so it can be GitHub, it can be GitLab, it can be any SIEM you want. And the way the system is supposed to work is basically you need to set some backend that will listen to all the PRs that are happening in your SCM. And based on that, you want to trigger your CI, but it will be the same CI pipeline. You will just add a payload that will include the specific of the PR. So which repo was originating the PR, and also the specific, the branch, and all the all the details of your specific PR. And what you want to do afterwards also, because you want to reflect some changes in the status of your CI inside the SCM. So you want the CI to be able to report the outcome, the results of your job, or your pipeline into the backend, and the backend will be able to update the SCM, and you will be able to see the results inside your PR. So basically, what I want to show you here is how you can implement that. And for that, I will take an example, and in the example architecture, I will use GitHub and GitHub Actions for the CI. And we'll implement a small backend that will be written in Python, because it's simple, and within a few lines of code, you will be able to see that basically it's working. The way the workflow is architecture is the following. So you have the GitHub organization, and you have your repository A. This is a repository where you will open a PR, and basically it will go to GitHub, and then GitHub will send an event to our backend, and specifically to our webhook endpoint. Based on that, our backend will dispatch, will be able to send an event to GitHub to trigger an API, the dispatch workflow API, and the specificity of this API is that it allows GitHub to trigger a workflow, so a CI pipeline, basically, inside another repo, and this repo will be our central CI repository. So it may look a little bit abstract, but I will show you that into practice in a few seconds. I just want to explain a little bit how it works behind the scenes. So the first thing we'll need to do, and here I'm adding the repo that you will be able to clone or fork at the end if you want to do it by yourself. And we'll go into the code into a few seconds. What we'll use in this demo are the following libraries in Python: AO HTTP, because we want to be able to call the GitHub APIs asynchronously, and IO HTTP DevTools. This is for the server, for our web application, and we'll also use GitHub Hub in order to interact, to wrap the GitHub API. Also, because I'm here, I will demonstrate that using the local server. I will also use ngrok, and that's for to allow me to have public local access, so that GitHub will be able to interact with my local server. In addition, we'll need to create a GitHub application. So for those who never create a GitHub application, it's actually quite simple. You can look up online how to do it, but basically the things that are interesting here is that we'll need to define a webhook URL. This is the URL where GitHub will send events to our application, and this is where we're listening. And we'll also need a webhook secret, and that will allow us to make sure that the request from GitHub is legitimate. In order to be able to interact with the GitHub API, we'll need a few permissions. And so these are the permissions that are needed. We need read-write to actions, because we're using dispatch workflow API. We need the checks. That's something that I will show you later, how to implement, how to reflect the status of this of the pipeline inside the PR. We need read-only contents, that because the PR in the workflow will be able to clone our repository. Metadata read-only, this is mandatory, this is default. And we'll also need pull request read-only and subscribe to events of pull requests, so that GitHub will able to send us events whenever a PR is opened. And so once we create this application, we need to store three information inside our environment, or on my local laptop here for the example: the GitHub app ID, the webhook secret, and the private key. The private key is a certificate, so in order to be able to store that easily in my environment, in my bash profile, I actually encoded it in base64, so that I can just have a simple string. Okay, and now I will show you how the code looks like. And what we want to demonstrate here is a central linter. So this is the example of the simplest workflow that I will demonstrate in the GitHub actions. So let me show you some code. So you will see that this code is really simple. You have basic requirements. These are the libraries that we'll use. IOHTTP, Git Hub, like I said, and the DevTools, basically. And so here we have a very simple web server using IOHTTP. So you have your web application and your routes. The only route we'll need here is the /webhook that I showed you before. And this is in order to listen to the webhooks from GitHub. Every time a PR is opened, we'll get here the events from GitHub. So how does it look inside? What we'll do is read the body of the event. We'll get the webhook secret. That's in order to verify that it's legit. And here we'll do something like dispatch to a specific function to using a co-routing. And that's because basically two things can happen for a PR. A PR can be either opened or reopened, and these are two different events. So in order to write only the code once, we'll use this co-routing here, and so we'll use dispatch here with the router. And in both cases, we'll go to the same function, this handle PR function. Now, what does handle PR do? You'll see it's very easy. Basically, we first of all need to create a token, and that's in order to be able to communicate with the GitHub API. So this is a simple function that will create an installation access token. So the access this token is created in the following way. We just need to use the certificate, the app ID, and the installation ID, which is sent as part of the event. And from that, we're getting a temporary token. Using this temporary token, we'll be able to call this special API from GitHub called dispatch workflow. Dispatch workflow is an API that will allow us to trigger remotely a CI pipeline in GitHub Actions. And so this is what we're doing here. We are posting basically this payload, and the payload include the following information. This is the owner, this is the GitHub organization, this is the repo name, this is the full path of the repo, this is the SHA of the last commit in the PR, the installation ID, and this is the GitHub token that we just created. And basically using that, you'll see in a minute that we'll be able to trigger this workflow. Now, let me show you how the workflow look like. Actually, I will show you inside GitHub itself. That will be easier. Let me show you here how it looks. So this is a sample organization that I created for the demo. It's called Centralized CI. And here we have a CI repo. This is our central repo. And inside that, you have in the GitHub workflows, you have two files. We'll look right now at this first file. This is a simple one, okay? So basically, for some of you that already know GitHub Actions, this is really basic. We're only here describing on which event we want this workflow to be triggered. And so here we want to be triggered on a workflow dispatch, which is basically the event that we're looking for. This is the API that we're calling on GitHub. And we're only here defining a mandatory input, and that's the client payload that will include all the information we need in order to run this workflow. This workflow here is very simple. It's a simple job that uses the latest Ubuntu. And here we can see that we're setting up Python 3.8, and that's in order to run Fleck8 for the linter. The first step here is basically to check out the original repo. And for that, we're using the information that we're getting from the client payload. And then we're just run Fleck8. That's basically the workflow that we want to test. Now let's see in practice how it works. So here I have my terminal, and let me start this small server with the code that I showed you. So here we're listening on port 8000, and here I also have ngrok that I'm using in order to make my local host available through the public internet. And so now if I'm going here into the centralized CI into my test repo, which is a sample repo that has only one file, it's a Python sample file that has some issues with Fleck8, right? So there are probably some issues here with with the spacing, and so this is what we want to test. We want to test this repo for linter. The other thing is, as you can see, I don't need to define anything here in terms of CI. This will be the magic. It will happen behind the scenes. So let's say here, just for the sake of the demo, I will just change something in the file. Let's do it like that. I will just, let's say, add here some spaces. Okay. And here at the end, what I will do is create a PR with this change. So here I'm creating a new branch. And here I'm creating this PR. Now, what will happen? So here I won't see anything now because the workflow is not running here. But if I'm going to the centralized CI into my repo here, first of all, I can probably check that, yeah, I got an event from GitHub here. I got a post to webhook. And so here, I want to go to the CI, which is the centralized CI repo, and I will go to Actions. And in Actions, what I can see here is that I have a workflow that ran 30 seconds ago. And if I'm going here into this workflow, I can see that it really ran. It ran my Fleck8, and looks like I have some issues to fix. So here I showed you how to basically run a simple workflow on another repo. We had a repo A, and here we had the centralized repo, the centralized CI. The centralized CI ran a workflow on the repo A. So that was the first part of this demo. And as you could see, it's really simple. We had only a few lines of code. I can show you again the code. The code is really simple. We only had a few lines of code, less than 100 actually. But now we have a problem because, okay, we managed to run it, but the problem is that there's no visibility on the original PR. So I have no idea if my workflow ran or didn't run successfully. And so what I would like is something like that, to be able to reflect the CI status in the PR itself. So how can I do that? Well, it's not that complicated, and I will show you how it works. Basically, what you would like to do is to be able to create checks on the original repo. In order to do that, we'll modify a little bit the CI pipeline. Instead of just running the linter, we'll also be able to communicate with our backend back. So the first thing we'll like to do at the beginning, it's to create a check. So we'll add another endpoint called /check in order to create a check on the original repo. And the thing that we'll like to do after running the linter is to update the check. And so for that, we'll have another endpoint called /check/ID with the ID that we got from the first endpoint. So the workflow now is working like that. So here I'm only showing you what we want to do inside the CI pipeline. First of all, we'll want to check out the code. Then we'll want to create a check. Create the check on our backend is basically our backend will call the GitHub API, and then it will add the check. And now after that, we'll run the linter. And then when the linter is done, we want to update the check with the result of the linter. calling our API, which will call the GitHub API, which will update the check. Looks easy enough, right? So let's see how it works. So for that, I have the code. I will show you the code. It's a little bit more complicated, but not that much. Basically, we have two additional endpoints. The first endpoint here is the /check. It's a post. We want to create a check. So what we want to do here is basically get a few information from the PR itself. And for that, we want to create a check. We need the repo name, the original repo name. We need the installation ID because we want to be able to create a token. And we also want the SHA, of course, because we want to be able to make the check on the right commit. So we'll just using the GitHub API for that. This is the GitHub API, which is the /check runs, and we're posting that in order to create a check. After that, once the linter has run, what we want to do is to update the check. For that, we want to do a put request to the check run ID, which will do the following. Very, very similar. The only difference is that first I want to get all the informations of the current check, and I would like to update the status. Before it was running. Now it's completed, and I want the conclusion, and the conclusion will be part of the payload, right? So if it looks easy enough to understand, now let's see that in practice. So let's go back here to the terminal, and this time I will use the full code. I'll do the same thing. I will start the server, and now we'll do exactly the same thing as we did before inside our test repo. So here I will modify this main file, just adding some something here, and creating another branch. And I'm creating the pull request. What I will do here is also check my terminal. In my terminal, I see that I already got the event about the webhook. And now we need to wait a little bit. Why do we need to wait? Because the check is only created once the repo is cloned. So once it's started. So as you can see here, we got the call from the check, and here we already created the check. And now the check is done. The linter was actually very fast, and now it needs to update the check. It should happen within a few seconds. Maybe let's refresh. And as you can see, the linter has failed. The step is failed, right? So as you can see here, I have a centralized CI, and I have also the ability to create a check on the original repo and to update the check with the proper status based on the results. Just to make sure it works properly, I want just to verify that indeed in the last actions. Let's see here. In the last actions, actually it failed. Let's go here into repos, into the CI. Let's import request here into actions, and this is the last action 1 minute ago. It indeed failed, and here I can see the details. It failed, and these are all the issues. Now for that, if you remember correctly, I didn't show you how the CI, the workflow has been updated. So let me show you that. Here, let me show you here. Basically, this is a second file. This is the full CI. So the difference between what we had before and this one is that here I'm creating the check. So here you see I have a curl request with the installation ID, the owner, and a few parameters, the name of the repos, the headshot, all the parameters that are required, and the name of the check, right? And so here I want to be able to save the check ID because I need that in the second code. Here I'm adding the check ID as an environment variable into GitHub. And then after that, after running a linter, I have here two possibilities. One, that this step failed. The second is that step actually was a success. So if it was a failure, I want to save an variable into GitHub that it was a failure, and otherwise that it was a success. And now the only thing that I need to do in any case is to update the check with the results, right? So here I'm adding a few parameters, the owner, the repo, the headshot, and the last parameter is the conclusion, which is here, the results. Okay, so this is how I know how to update the check correctly based on the result of the step, right? Okay, so going back to here, I show you how to implement a very simple centralized CI in Python using with the ability to reflect the CI status on the PR. But there's a lot of things that we can do in order to improve that. The first of all is that maybe I would like to make some differentiation between different repositories. Here, I only showed you that we have only one single pipeline, and maybe we have different tests that we want to run. So we need the ability to be able to differentiate between different repos. So that would be one enhancement that is possible to do that. The other is that, as you could see, the results of the findings, the results of the run, beside the fact that it was failing, were I needed to go inside the log of the GitHub action itself in order to see all the results. So one very nice enhancement would be if I could see those issues as findings, as issues inside GitHub. Okay, and the third point is that, let's say that we are not dealing here with linter. Maybe you have some other type of findings that you would like to ignore, and so it'd be really nice if you could also directly from the PR itself be able to ignore that, and having some kind of a central mechanism in order to ignore those findings. So these are a couple of enhancements that would be really nice to have in order to take this project further down. I just want to show you that everything that I showed you here is available in this repo, Central CI. I have the code here, the full code, including reflecting the check. So you can really fork it and use it on your environment. And I'll also put here in the samples the example of the CI that you can use, and this is the example that I showed you. So just to conclude this talk, what I showed you here is basically something that we implemented here at JIT, and the reason why we did that is that on the first day that we started the company, we said that we wanted to have CI/CD on the first day. And for the first microservice, indeed we did. We added CI directly with the service. The problem is that on the second day, when we added the second microservice, it didn't happen because it's an overhead to think about adding yourself your CI pipeline. And so we thought about a way where we won't have to think about it, where developers won't need to think about it. And the way we thought was to actually implement the centralized CI, because using that, our backend is basically listening to all the PRs, and anyone can add a new microservice without having to think about adding CI pipeline in its own repo. And also, if we're doing changes, if we're adding more checks, and here, for example, we're doing a lot of security checks that I didn't show you here in this talk, then basically we don't need to think about it. It's happening behind the scenes. And this is also the basis of the platform that we built here at JIT, this continuous security platform for developers. If you want to see it by yourself, how easy it is to add security to your own product, the product that you're building, early access is available. You can register on the website. You can also drop me an email. We're also hiring if you're interested into building also product for developers, and we'd be happy to be in touch. Thank you very much for your attention. If you have any question, I'm opening to questions now.
Wow, that was so super awesome, David. I don't even know where to start. I'll tell you what, maybe we got a few minutes. So, what kind of resources do you need to run this central CI repository?
So it's really minimum, because the only thing that you need to do is basically listen to GitHub events and then just trigger API calls from GitHub. So it's really minimal.
Okay.
You don't need a lot of resources. You can run it. Actually, the way we implemented that at JIT, we are using a Lambda, so everything is serverless.
Yes.
You don't need you don't have state. It's really really simple.
Right, that's really awesome, because another question I was going to ask, and I think you guys solved this, was how would I have to convince my management of this, for example, or do you think that you know what I mean? Sometimes we got to convince management we implement these new infrastructures because it could be a risk to them or something like that. So how do you go about
Yeah, it
that?
could be a risk, but the only thing that you would need is actually to install this GitHub application. And the GitHub application, as you could see, has limited scope. It can only read the code and listen to events and create checks, basically. So there's not a lot of risk in terms of security here. I don't think you would need a lot of buy-in from management in order to do that. But I think that if you're selling the fact that you would be very efficient, no one needs to think about CI in the first place. I think it's an easy win.
True. You can tell there's been battles in my past. We're trying to
Definitely.
Yeah, you know that because I saw you smiling.
Yeah.
We'll bring you back. Okay, I just wanted to throw a few questions
Sure.
in because this is very intriguing to me personally. And I'll see you later on in Q&A. Thank you so much, David.
Yeah.
This was really super
No problem.
awesome.
Thank you. Thank you.
Okay. Yep, sounds great. All right, everybody. Wow, I hope everybody's having a great time. That was a super cool talk because it just makes my mind go crazy. Think about all these new ways and new techniques of how we implement these architectures. I think I'm ready for my next guest here. I think he's ready. I'm looking at him here. It's Paulo. How's it going, man? How you doing?
I'm doing fine, thanks. How are you?
Oh, I'm doing good. So where are you located right now? Where are you?
Right now, I'm located in the Netherlands.
Okay,
so close
cool.
by to Amsterdam.
Yes,
by the
yes,
sea.
awesome. So, okay, one more question. How's the weather been? Just curious.
Actually, it didn't rain today. It was sunny.
Hey, that's awesome, man. Okay, I would tell you I'm from sunny California, but I'm not because every day we don't have the thing called rain, but that's another story. I just want to say that. So, what do you have for us today? What are you going to talk about?
So today I'm going to talk about strong security, strong authentication, and why we should stop using passwords. Basically, if I need to put it in a couple of words.
That is so super cool because I'm getting sick and tired of, okay, I'm not saying it, but storing my passwords all over the place and then I keep on forgetting. So this sounds like a really super cool talk. I'll tell you what I'm going to do. I'm going to bring in your slides. And then what I'm going to do is I'm going to get out of the way and let you have it. Have a good time, Paulo. See you
later. Oh, thanks. So today I'm going to talk about WebAuthn, or if you want to be more specific about the real name of the specification is FIDO2. And I'm going to talk how you can replace passwords with a strong phishing-free security. So before I start, I'm going to do a bit of introduction. My name is Paulo Lopez. I'm a principal software engineer at Red Hat. I'm also a member of the W3C WebAuthn working group. And you can find me on Twitter with this very nerdy handle, or you can find me also on LinkedIn with that URL. And if you want to follow me on GitHub, that's my initials. Okay, so before I start digging into the topic, let's just make a small introduction. So if you look if you look at Wikipedia to learn a bit more about passwords, you'll see that the history about passwords is a bit fuzzy, and the first mention about passwords is in 1961 when the MIT was building the compatible time-sharing system. This was like a $30 million computer back in the days where lots of people would need to connect to and share. And the main purpose of the introduction of passwords in that system was because given that the system was going to be shared about using all going to be shared by all the students and staff from the university. Everyone wanted to have their personal homes protected, and passwords was like the simplest way to protect this system. So it uses a very few bytes of memory, because remember, back in the days, memory was really expensive. You just keep like the password in a file /etc/passwd, like if you are into the Unix world. And this system was very simple. So you log in, you type the pass command, and you enter the password, and if the password was right, you'll be allowed to continue. So as you can imagine, the system wasn't really secure. And only like 15 years later, in 1976, when Unix, the 6th edition of Unix, came out, it came with this neat function called crypt, where passwords were like being hashed in using a modified DES algorithm that would like run for 25 times and use a salt of 12 bits. So this was like the first time that someone started thinking, okay, we need to protect the passwords, because it's just a file in the file system. Everyone can look into it. And as you can see, only 15 years later, people start paying attention to this. So if you flash forward to today, or if you look at the end of the year, I found on the internet a report. I cannot accrue for the accuracy of the report, but someone was stating that by the end of 2021, like an average user on the internet will have around 100 passwords per person. So like you said, like Mike said, just like you're gonna have like lots of passwords. And because we are letting the users manage the passwords, you end up with bad choices. And again, if you go on Wikipedia, we see the most popular passwords from last year, like the top 10. I just typed here the top 5, but the top 5 is like crazy. Like the most used password in the world is 1234566, and the second most used is 123456789. And the list goes on with a very simple password. So the problem is that because we gave the choice to the user to choose something secret, users, because they are overwhelmed with so many things they need to memorize, they decide to choose things very simple. So why are passwords bad? So there are lots of reasons. The first one is that they are bad, and that's why we have websites like haveibeenpawned.com, because they get leaked all the time. So if a user password is compromised in service A, and then an attacker goes and can try just to get this password leaked on the internet, he can try to use this password to enter service B, and because we are humans and choose simple words for passwords, probably will succeed going into the second service. And passwords are very easy to crack, although this sounds very complex. I'll just give you like a quick example. Like if you are on a new Unix operating system, you can create a user like Geeko, and you set the password to 123456 because it's the most used password, of course. And then you just use like a password cracker that is a public domain. It's called John the Ripper, and you use a word list from Wikipedia, and bam, in less than 1 millisecond, like my computer didn't took any time to compute it, it found out my password is 123456. So even if an attacker doesn't have the knowledge to run all these tools and get extracts from your databases with all the hashes, there are other ways to get passwords from your user. Like the most common way is using phishing. So phishing is a type of social engineering attack where an attack sends a fraudulent message created to trick the victim into revealing some sensitive information about to the attacker. And the most common way we get phishing attacks is through email. I just go on my mailbox and my spam box, and I see emails like this where people try to offer me services or lots of large amounts of money by sending my personal details to this person. And a second kind of attack is spoofing. So this is when an attacker creates a secondary website that pretends to look like something that I, as a user, am very, very familiar with. And if I don't pay attention to the URL or get warnings from my browser, like in this case, and this also came from my spam box, I I could just type in my real email and my real password for PayPal, and my credentials will be now stored on some attacker database. So, like in a dream world, when we create a system and we protect it with a password, we assume that users are gonna be very conscious and smart, choosing very complicated passwords with mixes of uppercase and lowercase characters, numbers, special characters, more than 16 characters long. But reality is that passwords are very weak. So we see that users will reuse the passwords across accounts, and this is like a big problem because, like I said, if once it's leaked in one place, it's leaked everywhere. Second, like the security questions that we have to do the password recovery are very easy to capture using social. Well, you just go on social media and you find that, and they are symmetric. And because they are symmetric, it means that the secret that I have, I need to tell it as it is to the service I'm going to use. And most of the times they're not really securely stored. So this is when leaks happen. And when these leaks happen, because they are not properly secured, people can do the reverse of the hashing function and get the password back. So once a system is attacked, is like a robbery. Your house gets robbed, you get more logs, and this is when multi-factor comes in place. So multi-factor authentication is about factors. And what are these factors? Factors are there are two factors: something that you know, steal the password, and something that you have. And if you want to talk about multi-factor authentication, there are like three kinds of applications, like Google Authenticator. There are Arbor tokens, and there is SMSs. So if I need to put a picture to explain more or less, this is kind of how it looks like. And the main problem that I have with multi-factor authentication is that they all have bad user experience. So regardless of the kind of multi-factor authentication we're using, they all are phishable, because I can impersonate to be your bank or some service that you trust and call you and say that there was a problem with your account, and in order to confirm your identity, you need to give me the 6-digit code that your application is generating, and bum, there I go. Second one, they have a very bad user experience. So they all work more or less like this. So the application will ask, after you enter your password, will ask you for a new code. Now we have like a timer, and this is really annoying because you need to work against the clock. And usually, well, in the beginning was really easy to do this on my Google Authenticator application, but now I have so many multi-factor authenticators applications on my Google Authenticator that I need to scroll and find the right one, so the time is ticking. I cannot make typos because, well, there are all these numbers and I need to type it right. And if I didn't make it on time, I need to go back to one. So this is, as a user, it's not really interesting, and that's one of the reasons why people don't really activate the second factor authentication. So if I need to put all the problems about multi-factor authentication in a table, I will do it like this. So if I go like column by column now, if I look at applications, they are all phishable and they suffer from the user experience problem. Plus, they work with a shared key and they are synced on time. So because they work with a shared key, if I don't use a secure Google Authenticator application like Google Authenticator, but I use some other application that you can get from App Store, nothing secures me or prevents that this application leaks my secrets to someone else. And if those secrets are leaked, the second person can just generate the codes for me. The tokens, the hardware tokens, this kind of a thing from the past. I don't see these very often anymore. Well, they are a bit of fragile and they are centralized. They rely on a specific software. So if there is no connection, it breaks. And SMSs, they also have problems because I can ask a mobile operator to issue a second SIM because I say that I lost my phone and I need to have my number back. Or if I don't have coverage in the place where I am right now and need to enter my code, well, I can never receive the code. So I'm locked out. So just to make like a small quiz, this is kind of interesting. So if I would send you an email and say you need to click here to continue with this specific URL, https google.com, would you click on it? Yes or no? And if I send you another email with this URL, google.com, would you click on it? Yes or no? Like if you say that you would click on the first one, well, I must say that I just trick you into a kind of phishing attack because the last E on Google is not the Roman letter E, but the Cyrillic E, which is encoded as two Unicode bytes, and the second one is the right one. So even if you are like paying attention to the details, there are lots of tricks that attackers can use to trick you into give your credentials. So what we need is a system that is strong and addresses all these and it's in so it started by a conversation by people, and the idea is that we want to create a framework to create web authentication that is based on standards. And these standards are defined by the W3 organization, which is the organization that defines all the internet standards. And it builds on top of the credentials management. So it's an API that is already available on all evergreen browsers. So if you're using Chrome, Edge, Safari, or Firefox, this functionality is already built in. It allows very secure multi-factor authentication based on this specification. So I said again that it's based on factors. So there's one big difference between the multi-factor authentication that I talked before and the factors that are used on web authentication. So on web authentication, WebAuthn, for short, the factors change to something that you are and something that you have. So now, as you can see, it's not something that you know, it's something that you are. Like your biometrics or something that describes you is what will unlock the first part of the authentication. And something that you have is a piece of hardware that you will carry along with you to complete the authentication. So the API, it was designed to be secure from the beginning. So one of the goals was like we will enforce using the best. We're going to enforce the developers to follow the best practices. So one of the things that you cannot do is use the FIDO WebAuthn API if you are not using a secure connection. So if you're not using in HTTPS, your browser will not enable this API and you will not be able to do authentication. So the second part is that there are two ceremonies involved with FIDO2. One is like the registration when you create a new account, and second one is the authentication. The ceremonies have been really well defined to make sure that the whole system is secure. So if I need to do the two ceremonies in one cycle, it's more or less like this. When I register on as a user to use a specific service, uh, my web browser will generate a public and a private key for that specific service domain name. This means that the public and private keys will not be reused across different services, which means even if something gets leaked from service A, it will not affect any of your accounts on service B. So you don't need to change passwords or change things like you need to do now. The second part is that because we're talking about public-private key, your private key always remains on your device, and you only give your public key to the service you want to register. So once you want to do a login, what happens is that you will use the private key on your device to do some signatures of some challenge, and this signature is then sent to the service, and the service, because already has your public key, will confirm that the signature matches your the signature was generated from the private key using the public key it knows, and then it completes the authentication process. So public-private key is not something new, so to say. For example, if you're a developer and use Git, probably you already use it without even thinking, because you created like an SSH key and you send the SSH the public key to GitHub, and you keep your private key on your computer. And in the beginning, I think most people will think, well, this is kind of a complicated thing. I need to create keys. I need to make sure that I never leak the private key. And this is where WebAuthn already thought about these use cases and makes the usability really easy for the end user. So if I need to go like in details of the process, it's more or less like this. So I would like to register, so I make a post request to my registration endpoint and I receive back some challenge. Then my browser will ask me to confirm that I'm there and does some biometric check, and then it sends back a public key, a signature, a public key, the challenge back, and my origin to make sure that my public key is linked to that specific origin, to that specific domain name, and I'm registered. So this means that no keys will be reused. The authentication, the process is similar. Like it's like a two-step. Again, you do a post with my username, I get a challenge. This time, the browser will again ask me to confirm my presence. And this time it sends back the challenge, the signature of the challenge and the counter. And the counter ensures that no replay can be done. So this also prevents like replay attacks. So if people go on the view source on your application and copy like headers from one place to another, they will not just work because the counters will never be in sync. So to demo this, I'll just make like a small side note. I'm a developer of the open source Eclipse Vertex project, which is like a small library to build scalable, high-performance React applications. And there I have a WebAuthn compliant library. So probably most people never heard about it, but if you are in the Java world and have heard about Quarkus, Vertex is like the IO engine behind it. So if you want to look at the source code of the demos, because, well, this is like a short talk, I prepare like a repository with some README and some different kind of demos, like using Vertex directly, using Quarkus, using JavaScript, creating an API gateway with Python and so forth. So you can see all the code. So what I did, I just prepared a demo that will show you to see how easy it is to use WebAuthn. So if I need to talk about this, like I said, the application that you create needs to be HTTPS. So I'm using a self-signed certificate. So I have this website that I created. I enter my name, I enter my email, and I click register, and now I see the browser asking me to confirm my identity by touching my YubiKey. This is one kind of authenticator, and the process is complete. And now I need to log in, and again the same way. So I enter my email, touch my YubiKey to confirm my presence, to confirm my biometrics, and I'm in. So on the desktop, this works with YubiKeys, but if you are like on Windows 11, you don't even need YubiKeys. It's built in an operating system, and it uses a specific Intel chip, which is called the TPM2, which is a requirement for Windows 11. And in the Windows world, it's called Windows Hello. So if you're like in the mobile world, I'm like here on Android, again, the same application. I go again on the same link. I need to confirm that I'm using a self-signed certificate, and I click register. I need to enter my details, again, my name and my email. I say register, and now I need to tell what kind of device, and I'm just going to use my fingerprint. I touch it, and now when I want to log in the second time, I just need to enter my email, so my username, so to say, and I'll be asked to confirm my identity by using my fingerprint, and there you go. Again, the system is quite simple, but it's very secure. So one of the questions I get most of the time is like, can we trust these devices? Well, you can, because the devices also have the API and the spec defines device attestation, and the device attestation is just like, can I trust this piece of hardware? And the trust is based on a chain of certificates, so it's a chain of trust, where the simple certificates are signed after each other, and they go from the hardware to the operating system to the bootloader and so forth. And if the whole chain is correctly signed, then you know that no hardware or software has been tampered. For example, if you are using a rooted Android device and you try to run this device attestation during registration, you will notice that the registration will fail because the certificate that is associated with the bootloader is not present, so it will fail to sign the last one of the steps. And because this step is missing, the whole chain is broken. So you know, like, now you need to decide, do I want to trust this device? Sometimes you do, because you don't really care about the hardware itself. Sometimes if you are doing something like banking, you care. And on top of that, the specification also attempts to think ahead in the future, because we are talking about software. In software, there are bugs. And if there are bugs, it means that hardware also might have bugs. So there's also like a list of services, a list of devices that are known to have security bugs, and you can consult that data to allow a service, a token to be registered, yes or no. So the whole spec is built around privacy. So before you used to have like usernames and passwords, now we just have like public keys. So public keys is something that you are supposed to share, so it's easy to store. You don't need to think about hashing functions, salt, and so forth. Second, there are no really usernames. The specification transforms usernames into a credential ID that you can use to identify users, and there is a counter to make sure that there are no replay attacks. But nothing goes without challenges. There are a couple of challenges with this spec. One is I could say two. Two is like multi-device registration and account recovery. I'll start with the last one. So account recovery is kind of a mission impossible, because you cannot extract the private key from your device. There is no way to recover it if your device is lost, stolen, broken, and so forth. So in order to address this problem, we need to create applications that allow users to register multiple times with different devices. And this part of the spec is still open and evolving, and there are a couple of there are some work being done by big companies like Apple. this slide comes from Apple. I just stole it, which I'm sorry. I shouldn't do. I should give some attribution here. So Apple created a prototype which they call passkeys, and in passkeys they use WebAuthn as the only way to do authentication on Safari. And instead of relying on the hardware on your MacBook, it stores the private keys on iCloud. So this means that if you register on Safari on MacBook and then use your iPhone, the private key can be used on iCloud to do all the signature validation generation. And Microsoft is also working on a similar alternative, and this is still ongoing. So my time is almost getting to the end. So if I need to come to talk about some closing notes, like FIDO2 is a web standard. It's already available on your phones. Like if you have an Android or iOS, Android 7 or up, iOS 13 or up. If you have a Windows 10 or 11, it's already there. If you're using a browser, evergreen browser, like let's not talk about Microsoft Internet Explorer, but let's talk about Google Chrome, Microsoft Edge, Safari, or Firefox. The API is already there. You can already use it today. The whole system is decentralized. Like I show you in the demo, I didn't need to use a service by Google or Facebook or Twitter, whatever. No, the whole system is meant to be used between you, the user, and your service. And as I show you, like it's safe for data at rest. Like it follows the GDPR requirements. Like no personal identification is user personal identification values are added to the data that it's needed to operate. So it respects the user's privacy. And a bit of a shameless plug: if you use Vertex.io, which is the product I work, it's very easy to adopt on your JVM kind of project. So if there are any questions, maybe because we're running out of time, I'll just relay them to the question to the chat we'll have later on, so we can talk more about this. And I thank you for watching me talking about web authentication. And if you want to follow me, contact me directly about this or any other topics, here are my contacts.
Thanks a lot, Paulo. That was super awesome. I'll tell you what, we'll probably, and I know this for a fact, we'll have questions, Q&A after our speakers, this block that I have, because I've got questions for you, man. It's a really good topic. It really was. And I was writing down some questions myself. And we got some questions that came in too. So just get ready, because there's quite a few. Security is really important. So this was a really awesome topic that you brought to us. I got to let you go for a bit. I'll see you a little later on in Q&A. Thank you so much. It was really super awesome. Appreciate it.
Thank you.
All right, everybody. Wow. I tell you what, I just really enjoy this, because I just learned so much from all these amazing speakers. They're just so incredible. And I think I got my next speaker now. And I think it's going to be Andres here. Here he is right here. Hey, Andres, how's it going, man?
Hey, Mike. How's it going? Yeah, doing great. I'm happy to be here, definitely.
Yeah, me too. You're wearing the Superman shirt. Is that what that is right there?
Ready for the challenge, isn't it?
Let's go with it, bro. Let's do it. Let's super it up, right? So
right.
That's awesome. I love it. So what are you going to talk about with us today? What's your topic?
Yeah, it's kind of funny because we're actually in the previous talk, we were talking about security, and we're also going into the same trend. So we're going to walk everyone through why we need to become a security architect, or even perhaps just getting a start with security, become perhaps a security analyst. And we're going to see why and also how, definitely.
That is super cool. And you know what? I just want to add this, and I'm going to let you have it. We tend to forget that, don't we? We'll build these really, really awesome applications, have great enterprise architects, but we always forget the security. I'm just going to leave it on that note, because I know this.
Yeah. I don't know why. Consider it a hindrance. Come on.
Duh. That's where you're going to help us out today. So I'll tell you what I'm going to do. I'm going to bring in your slides, and I'm going to let you have it. Have a really good one.
All right. Thank you, Mike. Well, and I would like actually to kick this session off by saying thanks to all the organizers, because I know that many of the organizers from this event are also coming from Ukraine. So understanding the current situation that we have in the country already, I mean, it's just unbelievable that we are still having this event today upon everything that is happening in the world. So hello everyone, my name is Andres Espes. I worked at MuleSoft/Salesforce for both companies. I work as a principal instructor, and today we're going to learn why you need to become a security architect. And you know, something that is really shocking me at this point, well, the clicker is not clicking. Okay, now it's working. Is that perhaps at this point, 30% of this room has already tried to scan the QR code that we presented in the intro slide. But yeah, I don't blame you for doing that, because that is in fact one of the most common human traits. And yeah, that is a human trait. Yeah, you know, it's called curiosity. Well, the geeks here, you know, that's the curiosity rover. And don't ask me why, but that was the best representation that we could have for the curiosity, don't we? But curiosity is something that sometimes makes us do probably unsafe things or even really stupid things. Let's take a look to this short clip.
Hold on. You have a choice. You can have the boat or the mystery box.
What, are you crazy? We'll take the boat.
No, not so fast, Lois. A boat's a boat, but the mystery box could be anything. It could even be a boat. You know how much we've wanted one of those.
Then let's just...
We'll take the box.
We'll take the box. You gave up a boat for free tickets to a crappy comedy club.
Come on, Lois. You're acting like this is the first time I've ever done something stupid. You remember the time I was supposed to get that boat? A boat's a boat, but the mystery box could be anything. It could even be a boat. You know how much we've wanted one of those.
Then let's just...
We'll take the box.
Here we see how our Peter Griffin friend and how his curiosity got on his way and disrupted his plan also with his wife. Would have anyone have taken the boat right off the bat? Probably me. Definitely, I wouldn't be that curious. But that curiosity is what always makes us question and intrigue us to know what is behind maybe that door or maybe that box in this case. Because exploration is a really fundamental part of life. It drives us to find perhaps healthier environments, better resources, better conferences, and exploration is what took you to this place, to this conference. We as humans, we always seek for information to reduce that uncertainty that we live in the world, and also to resolve our gaps in our knowledge. So for probably those that were more curious about, for those that were curious about the QR code that we show on the first slide, well, you can find it here, no props. So here's the complete version. And for probably those that were really lazy and didn't want to scan the QR code, you could probably guess what is the QR code that we are scanning here. That is the most popular QR code in the human history. Yes, you know what it is. Yeah, it's that song. Yeah, it's that song. So even though that we just met probably by this point 5 minutes ago, you are trusting me already. And please keep doing that and keep trusting me at least for the rest of the talk. Because after curiosity, we humans have another big human common trait, and that is trust. So what is the problem with trust? Well, we need trust in our daily lives, and you can probably notice when you go to your work and you expect that after a month later, after you had worked so hard, get up early in the morning, you expect your employer to probably just pay you back all that time and effort. Or perhaps when you go to a mechanic, you expect that person to repair your car and not just to rip us off, for example. Or when you buy some food, you expect that the food to be treated and processed in a healthy way. Right, food industry? Looking at you. So we can really live in this world if we are constantly doubting everything. And that's why we need trust. But what I'm not saying here is that we should always trust and in a naive way, or that we just forget our rationality. But the problem is that humans, we trust when we shouldn't. So those human traits are the backbone of what puts us at risk. There are different kinds of risks out there in the industry or on the internet. And those risks and threats are exploiting those human traits and human vulnerabilities. And that means that curiosity that we have, perhaps the ignorance or an awareness, can really be the cornerstone of the malware industry. Those are the opium for the hackers. That lack of probably cybersecurity awareness is what is creating this risky environment for all of us. And you know who is really curious and really aware? Well, hackers. Yeah, they are really, really curious. And these guys are going to do bad things to you, professionally and financially speaking. So, by the way, hackers don't wear these kind of masks. That's just ridiculous. Who on earth is going to put a custom just to break into a system? Well, probably you can put a bunny hop and just try to hack. So there is a famous saying that goes, my crime is that of curiosity. So the hackers are these persons that really exploit or have been honing their curiosity to exploit someone else's curiosity. And they exploit these human traits. They are curious and they want to know, and they sometimes know how the system works and understand the rules of the system. So these people are just going to hack for different variety of reasons. Well, in these days, some hackers do it for profit. You can probably notice in the media with the crypto hacking about the cryptocurrencies. Some others just do it for fun because that gives them some pride and joy of being able to get into a system. And some others, they just do it for political reasons or hacktivism. Well, with the current situation, that might be the case. So by understanding that we are in danger, we probably can foresee the impact that all this has in the world. And in the past year, in 2021, some serious companies that they are diligent to provide this data. So please be educated and consume this data. They estimated $6 trillion for the cost of the cybercrime worldwide. $6 trillion. If we just put that in perspective, that would be the third largest economy in the world. It's just insane the amount of money that we are losing due to cybercrime. Can you imagine how much or how many things we could do if we could start saving at least a half of that money or some percentage? Probably you could finally buy those NFTs that you were trying to do this year. And this is not getting better because every day we are getting more people into the internet, and also new developers and new people and new devices joining the network. So we expect, for example, and this diligent company, Cybersecurity Ventures, they also estimate that probably by the end of this year or next year, we expect around 6 billion people connected to the internet. So that's roughly 80% of the planet. So imagine the massive attack of surface that there's going to be there. And I know what some of you are going to say. Well, that's probably not going to touch me, and I'm probably too small, or I'm not going to be impacted by this. And well, for good news, for those out there with probably low self-esteem, you are the perfect match for a hacker and cyber criminals. And well, this talk is not meant to turn into a self-motivation talk, but you and your project matter. That's the reality. So every company in this planet and every individual matters. Cyber criminals and cyber attacks, they are just targeting even simple individuals just to get personal information. It doesn't even matter if you only have 2 followers on Twitter or Instagram. Your data is still valuable. And hackers, they're also going to target, of course, the big, large institutions. They can get a big profit out of that. But even the small businesses, because those businesses, they haven't adequately prepared and invest in cybersecurity. And the hackers, of course, they all know how to exploit that unawareness and then just get some profit out of it. So if we have some assets these days, that is data or data. So let's do an exercise here. Can anyone tell us in the chat, perhaps? Can you guess who's the culprit that this term, the fame of JNDA last December? We're going to be keeping an eye on the chat. And well, so if you would expect that last December, most of you were on holidays, just taking a break, enjoying Christmas. But no, in the middle of a pandemic in December, there were some few cyber attackers or some hackers that they have found and exploit this library that I'm about to show you using this concept of JNDA. For those here that probably are not in the Java ecosystem, this was a massive vulnerability found in the Java ecosystem, by the way. And check, this term high rank at the 100 points score for Google worldwide, not even for a country. And that was our lovely friend, the Log4j library. So remember, if anything or something can be exploited, it will be exploited. These cyber problems are getting serious because if you think about it, you know that things are getting serious when there is a magazine just dedicated to report data breaches and problems. So this cybersecurity is becoming a big issue and it's only getting bigger. Every day we see new malware, new techniques, new way to get into systems, and new data breaches are coming up or being published. And this pandemic also accelerated this problem. You might be wondering why. Chances are that many of you are working now remotely, and that remote working is bringing plenty of benefits for you. I know that many of us love not commuting to work or probably not interacting with some colleagues. But however, this situation is increasing the cybersecurity risks because now every person is connected through any device, any possible device. The security measures were not set in place. There were no policies, and people just join from their houses however they can. So consequences and the attack surface are just only going to increase due to this situation. In fact, one of these massive companies that also analyze all the problems that are happening in the world, please be diligent and consume this data. They are expecting to have, or that we are expecting to have, 3 times more devices connected to the internet than humans on Earth. That's just a mind-blowing number. 3 times more. So we are probably over 20 billion devices right now. So at this point, I would like us all to think about cybersecurity in this different way. I would like us to think that cybersecurity is like this large pipe. So we have this pipeline, and you can see each section of the pipeline is connected with these joints. Now, those joints are there in place to maintain whatever is contained and within the pipe to keep flowing in a safe, secure, and predictable manner. But now imagine that one of those joints were not properly adjusted, and then a leak of the oil, for example, starts dripping. Following this example, now we can think about cybersecurity on who's really responsible for this cybersecurity in your project or your company. Well, every one of us is just responsible. It's not the responsibility of the CISO or the CTO or the CEO. It's just everyone is part of this problem or the solution, perhaps. So that means that all these best practices that we are going to learn after this talk are going to be should be part of our routine and our daily lives. So why is this important? Just to summarize, we can see cybercrimes are just rising and becoming more prone to happen. Your data is still valuable. Don't consider or don't sell yourself too short. Your data is still valuable. Cybercrimes are going to have a massive impact from the financial perspective that we are probably already foreseeing. And also they can pose some real life threats. For example, imagine what could happen if an aircraft for wars can be hacked, or a drone, and they just start using these weapons. So how are we going to really, so now that we have clarity on why we need to become a cyber or get into the cybersecurity field, let me just give you a bonus, because who doesn't like bonuses, don't we? So let's get started our journey on this cybersecurity. And we're gonna start just by looking at what a security architect do or does. We have all these different tasks, but today I'm gonna wear a hat of nerd to English translator. So instead of looking at these different tasks, let me translate them into that a security architect does is to help hunting the bad guys, or these persons, this role will design a protection plan for the most valuable assets for you or your company. They will also get interested into enablement and training. And parenthesis here, that's what I do at the company. Also, this person makes sure that companies don't get into these legal problems with data governance. And last but not least, these individuals, they get badass skills just to help others. And that's part of the human nature. We like to be proficient and recognized for that. So how are we going to start this journey? Probably that's the question that we are all going to answer here. There is a wealth of knowledge to get started on cybersecurity and becoming a security architect. And these frameworks, for example, starting from the OWASP, Application Security Verification Standard, they're just going to give you the basis for achieving some security posture and preventing these data breaches or just security threats, mitigating them. In some cases, they will also give you some certifications and clear path to enable the rest of the organization. But just to be clear, these frameworks are not a one-size-fits-all solution. Even at your company or perhaps at your individual context, still have to analyze if you need to mitigate some threats or some risks and identify which vulnerabilities and which risk tolerance can you afford. For example, the NIST, the National Institute of Standards and Technology, a US-based company, they have a well-established framework for you to start getting into on how to identify risks and problems, then decide what do you want to protect, your data, your applications, and then how you can detect that your security perimeter has been crossed or breached. And then how do you respond and recover from that situation? There are some other standards like the ISO 27000. I'm not going to, let's say, give you all the details. So I know that Google is your friend. Just Google that for you, and you're going to find a wealth of knowledge there. Now, here we have a controversial topic, and that is certifications. There are some detractors and some people in favor. So like you have advocates and also detractors. But let's just take a look at certifications from the learning perspective. There is no bad knowledge. Well, could be, but knowledge is going to give you skills that are going to impact positively your career. So these certifications are going to be the baseline skills, or so you can perform these, at least the core security functions or activities. And there is also a huge list, which I cannot fit in the 30 minutes talk or in a single slide. But one of the most common ones is the CompTIA Security Plus. This is a really cool one because you can get started from a very generic perspective, not getting too much into the jargon or the tough details on how to secure a network or how to secure using cryptography and so on. So with the CompTIA, you can start looking at threats or vulnerabilities and how they can be mitigated. Also, a security best practices from the architectural and design, operations, and how can you respond to an incident. And also governance and risk. You also need to choose what motivates you the most. If we move to another big provider, that is the CS or the ISC Square, the international, listen carefully, the International Information System Security Certification Consortium. Oh my goodness, I need to take some breath. This company is one of the most well-known ones, and you can get your career kickstart with an entry-level certification. So probably by the end of this month, you can be certified as an SSCP, just a security certified practitioner. And that will give you just the basics about architecting for governance, risk mitigation as well, infrastructure security, and application security, and so on. Now, I know that many of you that are participating here are also interested in cloud technologies. And for those, each of the big providers, the big players like Google, Amazon with AWS, Microsoft Azure, or Oracle with the OCI, they also provide their own certifications. I tried a couple of them. I got certified. So definitely, it's not enough with that certification because that's tailored for their providers, but at least that's the way for you to start. Now, I'm going to leave you with a challenge for this talk. And it was funny because I found that our previous talk also talked about this tool. So we have this tool or this website that have I been pwned, and that means if your data has been leaked or breached. And this is one of the easiest ways on how hackers they can get passwords and get information about their victims by just going to this website, and they can Google it with their email or phone number. By the way, I'm not giving you ideas here, by the way. So go and check and start mitigating the problems or the breaches that you have been part of. Ultimately, we cannot expect cybersecurity to be an easy fix or becoming a security architect just to be an easy path. Combining this software-based security with the people's education and just vigilance across businesses and individuals is just a cocktail of the essential tasks to minimize human risks. So to conclude, we all own security. Even though that there are security specialists out there, we must own security of our lives. You don't have to become an expert by no means. Just take a simple step. Read a book, follow some best practices, attend a conference. While human curiosity is still difficult to curb online, ignorance and trust can be easily treated with awareness and training. So with this, I would like to thank you all for participating here with us today. And for those that probably have questions or maybe comments, you can connect with me on LinkedIn or GitHub. And now you can trust me, that's the QR code that it will take you to my LinkedIn profile. And I will just go to this screen and see if we have some questions in the chat with Mike. And yeah, thank you everyone. And also thanks Giggle for having us here.
Andres, that was so super awesome. You know what? We got like 4 minutes, I think, before the next speaker. So I'm going to throw some. I'm just curious. All right, what led you down this path to choose to be a security architect as you as you are right now. What made you decide that?
Yeah, it's a good question, Mike. And it's actually connected to my, let's say, part of my childhood. When I was a child, I always had this mentality of, yeah, I want to, I don't know, it's kind of part of the human beings to be a protector, to be this guardian of your tribe, of your family, right? So yeah, it's like getting with the shared theme. And then I understand that probably I need to become a protector, or at least giving the tools to the community to protect themselves. And naively, back at that point, I was thinking of becoming a antivirus developer, but it just turned out to be that fun. But now getting into this field, it just gives you so much fun and also feel of action and interaction with the community. So just coming from the childhood, I always dreamed about becoming a security architect, and yeah, now here we are in this path, Mike.
That's so awesome, Andres. I got one more, and I think we'll end this. But we're coming back, right? I mean, we're gonna go back to the Q&A. We got a few more minutes. I got one more speaker, and then we're gonna get into a lot more here. But I've got another one. How do you recommend for companies to keep current with all these security hacks, right? Because I know one, for example, who really hit a database. I'm not gonna say who it was, but it hit them pretty hard, and then they had to go and mad rush to get a fix in and then implement that to all their customers. So how do we keep up with that? Because in patching is another one, security patching and all that for servers. Give us your rundown. What's the best approach we should take?
Yeah, that's a tough one. I mean, the answer is going to be like super long, just to give some insights, because what is happening here, as companies and as all of us, we are using software in our lives. We will need to patch or upgrade that software every time. So what companies can start, at least, is by reducing their attack surface. And that is by using or being conscious about the software that they are using. If they start bringing a bunch of different tools, libraries in their projects, it's going to make them more vulnerable. So just starting, let's reduce the attack surface by just having the right amount of software, libraries, and components. And then alongside that, we need to always set a plan. So that's why the security architect will come into play and say, yeah, let's define a plan, how we can keep track of everything that we are using right now, and just automate this kind of risk mitigation and incident response process.
That's super awesome. I think we're gonna end up here. We're ready for the next speaker, but just hang on, because I've got a lot more questions for you. We got a lot that are coming out. I mean, this is a really excellent topic. So I'll see you in a bit, Andres. Thank you so much. That was a really awesome talk. Appreciate it.
Yeah, thank you, Mike. Thanks, everyone. I'll see you in half an hour. Cheers.
Yeah, half an hour. Sounds good. Go get some coffee, man. Or something. All right, everybody. I think we got our next speaker here, and let me give you a little bit of a rundown here. It looks like it's going to be a talk from Tamar Awad, and it has to do with cloud, fog, and edge, all-in-one architecture. It sounds pretty interesting to me, so I'll tell you what, I'm going to let them take it away, and I'll see you guys in a bit.
This is Tamar Awad. Assalamu alaikum. And today we are going to talk on the all-in-one architecture that includes the cloud, fog, and mist. About me, I'm a certified solution architect at IBM Egypt. I'm working for IBM for around 7 years now, and I have 13 years of experience at IT industry. I have a baccalaureate degree in computer science, and I am a master degree student currently. So beginning in the last decade, the concept of cloud computing began taking the world by storm. As companies realized how much they could save by using the cloud, they started looking to reduce cost even further by applying cloud computing to other aspects of their businesses. And as cloud technology has improved, more and more types of services has been made available through the cloud. So cloud computing transforms IT infrastructure into a utility. It lets you plug into infrastructure via the internet and use computing resources without installing or maintaining them on premises. As more capabilities has moved into the cloud limitations and the drawbacks has been more evident. Users has finding out that Current architecture of cloud computing does not fit some types of projects and situations. In particular, they have discovered that Internet of Things, the IoT, which is experiencing a huge growth currently, does not always work that well with cloud computing. So the cloud computing has some limitations related to security, reliability, and in the IoT industry, especially the latency problem. So what does IoT have to do with cloud computing? Well, it does to do a lot actually, because many parts of IoT are powered by cloud computing. It might be a simple case of controlling your thermostat remotely on your phone by connecting to the cloud, or you might use cloud storage to store the footage recorded by a network of security cameras. All in all, IoT and cloud computing usually complement each other quite well. And we have this principle, this is a solid principle in cloud, that you need to keep your data close to its consumers. However, as the network grows and as more smart devices get connected, problems start to crop up. One such problem is often the massive amount of data that's generated by all of these connected devices. For example, in a network of security cameras, the system can upload a huge amount of videos data every second to the server. In such a system, the cameras themselves have no storage component, so all of these videos have to be stored in the main server. Another problem that cloud computing often does not handle well is time delay. This is the latency problem. Since data can be processed only in the cloud itself, there is always some delay between recording data and getting results from that data. This kind of delay can be problematic in a time-critical system. Imagine a self-driving car that's equipped with the sensors to check its surrounding. When the car is driving at 50 kilometers per hour, getting the analysis of its environment after 2 seconds is pointless, because the car will be at a different position by then. So the core issue of this problem lies in the centralized nature of cloud computing architecture. After all, only the central nodes of the network have the capability to store and process data. To combat this problem, network designers are proposing a new architecture where the computing power is distributed more evenly around the network. This architecture pulls the processing capability out of the edge of the network, closer to the source of the data. Such techniques are called fog computing and mist computing. The quick way to understand these two architectures and how they differ from each other is to understand the cloud, fog, and the mist phenomena. In everyday meteorological sense, in real life, a cloud is thick with heavy condensed water hanging high in the sky, far away from the ground. Fog, on the other hand, is less thick, condensed water located below the clouds, and the mist is the thin layer of floating water depolated located on the ground. You can see that analogically how cloud computing is similar to actual cloud, where great computing power is located far away from human activities. Fog computing takes place beneath the cloud in a layer whose infrastructure connects end devices with central server. And finally, mist computing takes place on the ground, where it is light computing power located at every edge of the network, at the level of the sensor and actuator devices. So, and we have another term that we listen very often is the edge computing. Unfortunately, this term seems to mean different things in different people. Some use edge computing as a synonym for mist computing, while others consider it equivalent to fog computing. For the purpose of this discussion, I will avoid using the term edge computing in most of the slides, but we will use it as a synonym after that. So let's be clear about one thing. Cloud, fog, and mist computing are complementary to each other. And what is fog and why fog now? So the metaphor fog comes from the mythology term from a cloud close to the ground, as we said before. So fog can improve efficiency and reduce the amount of data transferred to the cloud for processing, analysis, and storage. This is often done to improve efficiency through it may also be used for security and compliance reasons because you will not move all the sensitive data. You can transform the data, you can manipulate the data, you can change it, encrypt it, or avoid moving the data from the fog to the cloud itself. So you can improve efficiency and you can improve security very well. Popular fog computing applications include smart grid, smart city, smart buildings, vehicle networks, and software-defined networks because you can treat fog as on-premise cloud or some baby cloud that you can use instead of using the cloud itself, and it can work dependent or independent from the cloud. As you can see here, we can get some benefits from fog. So industries use fog. Some of these industries like energy, manufacturing, construction, oil, gas, transportation, finance, telecommunication, especially telecommunication, health, retail, smart cities, and agriculture. You can have some agriculture field in a very far desert or in a very far place, and you can have the fog cloud for it to run it, and you don't need to have this costly infrastructure to connect to the cloud daily or on real time. You can just save some logs, you can just have some real data that is needed to go to the cloud just to monitor the all behavior, and the fog itself can act as the cloud for that field. And also fog distributes core functionalities like computational, storage, communication control, and decision making. This can happen away from the cloud itself. Fog helps devices measure, monitor, process, analysis, and react. Yes, this is one of the decision-making features that you can have on a fog. You can use it with machine learning algorithms, for example, to determine what to do when the water level goes down in agriculture field. You can measure the humidity and you can act according to this, according to what the growing plants need. And also you can benefit from fog by ultra lowering the latency. You can have location awareness for your applications. You can have efficiency in networking load. You can have high bandwidth, security, real-time analytics, and agility. As I started earlier, fog computing is a paradigm of putting computational capability in the connecting between the device sensor and the cloud server. The capability is usually put into a device that acts as a gateway, connecting all of the sensors and managing connectivity with the cloud. The gateway device tends to have decent computing power and the data storage, so it can handle data received from multiple sensors, as you can see here. As you can see here in this mist and all-in-one architecture. You can also get benefit from fog computing as it's a great fit for projects that needs to process data from multiple sensors, as well as one where minimizing latency is critical. Based on these characteristics, you can see that autonomous vehicles are well suited for fog computing. An autonomous car relies on multiple sensors in order to get a complete reading of its surrounding. However, having all the data processed at the cloud is a no-go because the car needs the result of the data as quickly as possible. Having a gateway device that can process the data right away is critical to having the car working properly. In addition, the gateway device must be able to filter and find relevant data that needs to be sent to the cloud for further analysis, reducing the amount of bandwidth required. Of course, it's not all rainbows and sunshine with fog computing. The biggest problem with fog computing is that it relies solely on a gateway device for the whole system to function, which means that the gateway can be single point of failure. Having an issue like that in a system like an autonomous vehicle can be really dangerous. So it's important to put a backup or a redundancy mechanism onto place. Mist computing is all about putting computing power on the very edge of the network. On the actual sensor of the device, this computing power usually comes in the form of microchips or microcontrollers embedded in the device. For that reason, their processing capability is much more limited. You might wonder if having computational power on a sensor is even necessary. After all, the job of the sensor is solely to record the data from the environment. While these sensors usually also have another job, which is to transfer the information they have recorded to a data storage in the network. Data transfer uses much more battery power than an equivalent computing process. So by having computing power on the sensor, the data can be processed, preconditioned, and optimized first before being stored. The resulting data will be much smaller, consuming less power in the transfer. Although there isn't much of a downside to using mist computing, it is much more complex. Not only are the systems used for mist computing usually application scientific, but sensors are often heterogeneous, making implementing a solution more complicated. In addition, the processing power available in the mist computing architecture is often limited, which adds even more constraints to any possible solution. So we have here the pyramid of all-in-one architecture. This is the transaction scale. So we have edge or mist devices. They can catch data of billion records per minute, per hour, and you need to transfer this to the cloud. In our architecture, we can just minimize the data that is transferred from layer to the second layer. So the devices at the mist or edge layer can just optimize the data and select only the data that is required to be transferred to the fog. These data can be reduced from billions to millions of records. And on fog also, they can process what they can do. They can have a decision about some data, and they can act properly, and they can just send some of the logs or some of the major data to the cloud to be determined. One final aspect of the fog and the mist computing is security. Using fog or mist computing enhances data security on the system. In these computing architectures, data is processed locally first before being sent to the remote server. This means any sensitive data can be removed or encrypted first, reducing the amount of security threats the system has to deal with. Even of all benefits of other architectures, cloud computing offers the largest amount of computing capability. Earlier, I have explained how autonomous vehicles are a really good fit for fog computing, but don't forget that all of that data needs to be analyzed and used to improve the performance of the vehicle. Since analyzing the data requires a huge amount of computational power, and it isn't time sensitive operation, that better way to do it than using cloud computing. Here is a comparison of an infrastructure of fog computing and its relating computing paradigm from the network perspective. Here we have multiple fog computing. We have one cloud computing at the center. It has multiple data sensors and they are all connected. And we have some fog cloud at the right that contains some data to monitor human activity from their IoT device, maybe their mobile, from the training watch, or some smart clothing. These all data will be filtered and sent to the fog. After that, the fog can filter this data and send it to the cloud. Also, we have on the left autonomous vehicle cars, some also IoT devices like mobiles and computers. These are on the mist computing layer. They will take the data, optimize the data, and send it to the fog. And again, the fog can determine to take some decisions and provide the optimize the data for analysis to the cloud. Sorry. Okay, so now we have one use case. We have an old solution. Maybe it's one of the current solutions. So we have the client tier at the left. This client tier contains some thin clients and some thick clients. Some mobile clients. So we have mobile devices, we have browsers, and we have other applications. These applications can connect directly to the cloud. And we have on the cloud computing layer the analytics application. The analytics application contains the algorithms for the analytics, and we have the storages. So everything happens in the client layer, it will go again to the analytics. So the global analytics application will contain all the data. Excuse me to drink. So all the client data will go to the analytics data. And the analytics can register these data. It can generate vector data and it can generate graphs for data representation. So what we can do, we can optimize this a little bit by using a fog layer in between. So the clients, instead of sending the data to the cloud layer directly, it will send it to the fog layer. We have multiple nodes for fog, and they are really close to the client layer. So they are at the edge of the cloud. They can, the fog layer contains some low power computers, some low capacity storage, and they can get this data, analyze the data, optimize it, and store some of this data to be sent again to the cloud layer. So when this data could be optimized on the fog layer, it will be sent to the cloud for the analytics application. We can do more optimization to this solution by adding a mist computational layer. So the old fog computational layers that we have added before will be the computing will be the missed computing layer, and every client can send this to the missed layer, and many nodes can send to the master fog computational layer. The fog layer may be with much more computational power and storage, and it can handle more data. The mist layer, insertion of mist layer here is very beneficial because it can handle what the cloud is not good at, which is the data latency, and it also can deal with unreliable sources of data. Some of the applications of the cloud, of the all-in-one application architecture. So here we have the 5G multi-access edge computing with cloudlets and fog creating mist. So what we have here, we have a mist on the left in the endpoints column. We have a mist computing devices so the person at the top has a smart clothes, a smart wallet, a smart shoes, and the car is autonomous vehicle or some semi-autonomous vehicle that has some sensors. It can take some decision. And at the bottom, we have the mobile computational, which is the sum of the laptops, mobiles, and tablets. This data is a sensor data, and they are a very huge volume of data. It will be transferred through the access network layer, which may be some antenna or some router maybe, and this will be gone again to the edge network, which is maybe the fog network that we have here. This edge network can take some decision. It can analyze the data. It can do some optimization for the data before sending it to the core network, which is the cloud computing layer. We have another example here is the IoT industry application. So let's say that we have some factory, and this factory contains a lot of sensors on the machines that is working. We can have on the mist or edge layer at the bottom, these sensors on some of the machines. And these sensors may have a very low computational power. They can get some data. They can send the data in case of failures or something is not usual. And they can send this data to the fog layer, which could be each room in the factory. And the fog layer here can optimize the data, check if any flaws. It can take some decisions. It can send mails, maybe. It can do everything that is required. And after this, the fog layer will store some data to be sent after some while to the cloud layer for business analysis and some training, maybe for the machine learning algorithms. These are some of the references that I have made this presentation from. You can ask me at anything if you need something. I will be happy to reply your questions. Thank you very much.
Wow, that was really a good, awesome talk. I tell you what, I am learning so much. I'm looking for my guys, the guys for the Q&A. I do see Paulo. I wonder if he's ready. I'm gonna bring in Paulo. Hey man, how's it going?
I'm fine. How are you?
I think you're on mute. Again? Uh-oh.
Sometimes.
There you are.
Yeah, okay. Hi.
It's kind of low. A little higher, I can't really.
Can you hear me now?
Yeah, I can hear you. Yeah, and I'll wait for Andres to come in. I have. Oh yeah. Anyway. Oh, there's David. Hi, David. I see you. Sorry, I didn't
Hi.
see everybody. How's it going, guys? I'm waiting for also Andres. I don't see him. So I got a question for you. Let's drop this thing or get it going here, and I want to find out something from you guys. I just wanted to throw this in before we start. If you could name your architecture, what would you call it and why?
That's a good question. Maybe I can start. Well, so basically, what I demonstrated in the talk was the centralized CI, and I would just call it a central way of managing microservice testing, something like that.
That's awesome. Anybody else? I could see kind of you were thinking about that one there, Paulo.
I would say that if I would name my architecture, I would call it phishing free, trustworthy identity online.
Nice. I love it. I love it. That's super cool. Andres, what about you? What would you name your architecture? What would you call it and why?
All right. Hello, team. I just joined the
that's
panel.
okay. That's okay.
Yeah. So if I call it, that's a tough one. I will call it probably the defense architecture, and yeah, that is because we want to defend from the threats from the software world. So that's what I'll call it.
That's really super cool. I think I'd call mine Megalodon. I'm just letting you know because it would swallow everything. The big prehistoric shark. Anyway, let's move on here. Okay, I have a question right here for you. Can Git be used in centralized workflow?
Yeah, of course. You can. So basically, what I showed you in the talk is that you have your repos, and basically you have your backend listening for any PRs there. So you don't need really GitHub for that. The only thing is that you need a way to listen to PRs. So you could use Git, but you just need a way to be able to hook up some events.
Right.
If I'm clear here. So, but it can work with other platform like GitLab and any other platform that are built on top of Git. But basically, Git itself would lack events, so you wouldn't be able to use it just bare Git repos.
Okay, cool. That makes a lot of sense. Okay, here's another question. What skills does a security architect need? I think this is to you, right, Andres?
Yeah, I don't know if Paulo also was talking about the passwords.
Yeah, guys, anybody chime in too. This is for everybody.
Sneaky. Yeah, definitely. Well, not just to get started with the security architect. That's an excellent question, and that's how we need to get started. There is also a wide range of skills that we might have to acquire, and also the opinions are kind of divided. So let's get started. There are some opinions if a security architect should know about programming or coding skills.
Yeah,
that's not necessarily always the case, but what I can assure is the more you know coding, the stronger you are as a security architect. So then there are, at least just starting from knowing coding and then the programming language, I wouldn't get into that field. Some people will say Python, Java, .NET, but at least just get some hands on there. Apart from that, now that I just tap into this field, I would say you need to really get into the advanced details of the protocols and how computing really works under the hoods. Start looking at the OSI model, the 7 layers, really understand how the networking protocols work. And then apart just from those foundations, now we can get into a more high level soft skills, how to have this high level overview of the systems, just not particularly solve a specific problem or threat, but just have a overall and a holistic view of the system, and then on top of that start planning. So also planning, advanced networking skills as well, software development, and also team management and transmitting the knowledge that when you become an architect, just to finalize this question, just to finalize this note, when you become an architect, you also, one of the strongest skills that you need is the ability to transmit the knowledge, because you won't be able to just do everything yourself. So you need to.
That's a great point. Paulo, what do you think? What do you think about that?
Yeah, I totally agree, and I think on top of that, I would add that it is important to, like I said, I tried to make a funny remark that you need to be sneaky, and by this I mean that you need to try to read the rules and try to find holes in the rules. So it's like when you're playing a game, it's also part of the game, the part of cheating, and sometimes cheating is not that because it's not because you are not following the rules, is because you found a way to do something that was not specified.
Yeah, that's awesome, guys. Here's another crazy question for us here. And this is for everybody. You guys just chime in here. What if cloud is compromised, usually protected with password? In the end, it all again comes to password or other recovery methods that are not safe. I mean,
Yeah, I think this question is related to the WebAuthn topic. Yeah. So, like I said, Apple is pushing for this way of allowing credentials, private keys, to be moved from one device to another device. And to do this, the private keys, instead of being stored on a device, are stored on iCloud. And of course, this is always like a trade-off between security and usability, user experience. For the common average internet user, for every one of us, it's way easier if I can just log in on register on my laptop and then use the same service on my device, because behind the scenes, the operating system is fetching the private keys from iCloud. But of course, we need to trust Apple, we need to trust iCloud, and later on, we're gonna need to trust Azure and Microsoft, and we're gonna need to trust Google and Google Cloud. Well, if we trust them till today with all our accounts on Gmails and Azure accounts and Outlooks, well, I think for
Well,
the average people it will work. For
yeah,
the people with more a security related task, like I don't know, people working for the government agencies, maybe they will not trust and they will want to control their keys.
that's interesting. David, here's one for you. Thanks for your presentation. You got a kudos. There you go. You all, by the way, all you guys did super awesome. I loved your presentations. How this work when we want to run tests with dependencies like DBs and buses?
Yeah, so that's an excellent question. Basically, what I showed in the presentation is only the basic stuff. And basic stuff is just a linter. There was no dependencies. Usually you have dependencies in test. And so if you have some database, or some mocks, some service mocks, you have some common architecture. So the way we implemented that JIT internally is that we added some config file in each of the repos. So and in this config file, we're just defining the specificity of each repo. So if you have some dependency there, you're just implemented that. You add that into some very simple YAML file, and then in the central pipeline, then we're reading this file automatically, and then we know how to set up and spin up some instance of the database or some bus or anything that you need to use. And also, we're also using one great project. So if you don't know about this, you should really look into it. It's called Local Stack, and that's a great project. It's open source. Some of it's open source, and it allows you to basically have a local version of AWS. And so we're using that for test. and basically it's the same API than AWS uses. So we use that for all the testing, so you can have your whole pipeline work inside the CI using this this local stack project.
So it's like it isolates it. In other words, that's a really
Yeah,
good idea.
it's very isolated, especially for unit tests and for
Yes.
integration tests. That's a great way to test your infra without having to really spin up things and resources in AWS.
That's awesome. Paulo, and Andres, guys, chime in there. What do you guys use to test like with dependencies? Just give us some insight.
Well, I work mostly on Java, so in my case, we're using mostly test containers because that allows us to run any kind of Docker container during our CI, and that's pretty much it. And then the usual JVM based tools like JUnit.
Yes.
Mm.
That's awesome because it sounds like it's kind of the same concept of kind of isolation. What about you, Andres? I'm sure you got pointers out there too.
Yeah, no, so I will counter back that question and say, what kind of tests are you referring to? Like probably you want to do some kind of unit testing or performance tests or stress tests. But just there are some kind of tests that they require some dependencies. So they really have to be integrated with the kind of real environment. And some others that we really have to detach them or detach from the environment so we can really test that particular piece. So yeah, as David said, you can kind of enclose everything or isolate them in a specific environment. And then, well, there are plethora of technologies to kind of run these dependencies with containers mostly is what is the industry is gearing towards too.
I think that's really good advice. Okay, I got a part 1 of 2 question here. You guys help me out on this one. Hello, there we go. I tried with YubiKey and couldn't prevent pen that comes from Windows security. The idea was to use FIDO2, there you go, username list and password list. And then the second part, is it possible to prevent that pen prompt from Windows? Because if we had to have a pen prompt, it is like having a password. That's an awesome point about prompts and all that. So go ahead, just jump on it.
So the answer is yes and no.
Okay, good.
If you want to use the YubiKey as just universal second factor, which is like one of the features that YubiKey advertises, then you can use the personalization tool to disable the pin. And by disable the pin, well, you only have one factor. So the device, I have one right here. So the device becomes, because as you can see, this is just a touch. It's not a fingerprint sensor. It's just, so it just confirms that I touched it, and doesn't mean it was me. Can be anyone.
Yeah.
The prompt that you can from Windows Hello, and then it's supposed to be like a security confirmation of your persona. So for that, you either need to have a YubiKey with a real fingerprint sensor, and that uses a fingerprint, or use a pin. The sensor is now being kind of I wouldn't say obsoleted, but it's becoming optional, because with the adoption of Windows Hello on the enterprise, due to privacy issues, employees cannot hold biometrics from the employers cannot hold biometrics of the employees. So in the enterprise world, Windows Hello will always work with a pin. So the pin confirms that you are who you are, and then the YubiKey does the rest of the second factor that says I have the private key that you want to authenticate to.
That's awesome, guys. I'm going to throw this question out here. Is the military government interested in FIDO over PIV cards? Because the reason I know is because I've worked with PIV cards before. Just what's the most secure way? I'm just curious.
I don't work with the military, but I do know that I do know that there was a recent announcement from the President Biden administration requiring strong authentication mechanisms and multi-factor multi-factor authentication for all government agency software. And
Yes.
what they mean by strong security multi-factor authentication is in fact web authentication. They don't want to use SMSs. Those have been banned by the NIST. It's like no more SMSs because
Really?
it's really banned by the NIST. And tokens and applications are now being downgraded as not secure enough. So within certain levels of the certain administration, certain areas of the government, you cannot even use those anymore.
Wow.
That's the goal. That's the goal.
So sounds like security's always changing and evolving. David, Paulo. I mean, sorry, I was Paulo. Sorry, Andre. It's getting late. Come on, please forgive me. Let's try again. Okay, here I go again. David and Andres. So, what do you guys think about that? Because security just keeps on changing. I mean, just give us your insight.
I think that's one of the interesting trends I've been seeing lately is the whole passwordless trend, meaning
Yes.
that in a very near future, no one will use passwords, email and password anymore to connect to a SaaS service. Until now, you had these SSO methods using your Gmail account, for example,
Yes.
which is great because you only need one password, which is the one from your Gmail account. But now you have this passwordless trend. So basically, you're just entering your email. You're getting then your link, a very temporal link, just to log in. You don't need to remember passwords. That I think that's a great trend. I think that password is one of the most vulnerable attacks when you want to take over an account. So I think that's the trends are in the good direction.
That's awesome, Andres. Give us some of your insight too.
Yeah, well, as many architects says that everything is a trade-off. Of course, we can gain some benefits from. It's like if we just start analyzing security or these password or authentication methods, we kind of have to involve the human side of that equation. And then as we have this human factor, now dealing as the adversary, or let's say the other side of the equation is a human, every method that we follow is gonna have an implication or a way of circumvent or work around. So for example, let's go with this passwordless approach. Of course, we only need to remember one password, but then if you got that single password, now you got access to all the passwords. Compare with the multi-password approach where each system will have their own passwords. It's always a trade-off, and I don't know. This is an exciting field to get into or to kind of solve these problems. Let's say I have not invested. I'm not that invested or expert as my peers here, David and Paulo.
Oh, I'm telling you, these guys are awesome. I know.
Yeah,
This is awesome.
So yeah, but definitely it's gonna have some hackers or the way to break that authentication is gonna still going to happen. So that's my
Yeah,
thought.
you know what? I remember when you said that in your talk, and I was like, you're right. If there's a challenge, they're going to find a way and they're going to crack it. I mean, okay, so here's my next question, guys. This is for anybody or all of us. How can AI help in security? Give me some pointers.
That's a great question. Actually, this is something I wanted to add to Andrew's answer, because yes, of course, yeah, no, of course, hackers will still find a way at the end to attack. The question is not will they attack. The question is when they will attack, and they will pass any firewall you may have, any fortress you can build around your product security. They will manage to pass through. So the question is not how can I defend myself. It's one of the questions. You want to be able to maintain the distance and make it hard. But at the end, what you want to do is to be able to detect when they attack. And so I think that AI can help a lot here, because there's a way when you can detect animals' behavior in your system. So if someone is managing to take over your account, probably the activity in your account will be a little bit different than what you used to see. And so AI can definitely detect that. And whether it's on your own private email, you will start to see some suspicious activity. Whether it's in your company, and suddenly you see in your network traffic, you will see some weird patterns, and or in your AWS account, you will see suddenly some instances being spun up and trying to do Bitcoin mining. So I think that AI can really help here, trying to detect those patterns and alert you. And once you're alerted, then you can recover, change your passwords, do whatever
Right.
you need to do in order to remediate to the risks.
Right, guys. Any of your insight on that too? What do you think about that, Paula? What do you think about that? The AI can help. Do you have any ideas?
Well, software is never done.
That's cool.
So the software is never done. So there will be always someone finding a way
Yeah.
to break in.
Yeah, I agree with that. What do you think, Andres? That's true, right?
Yeah, definitely. Yeah, just picking up from David's point. Yeah, at the end of the day, from the system perspective, if the intrusion is from a hacker or from a regular user, it's just one and zeros at the end of the day. So it's just from the system perspective, the activity is going to be the same, or I mean, the one and zeros, the bytes are going to be the same. But as David mentioned, the behavior of that person is going to be slightly different. So definitely that additional artificial intelligence can spot those differences. Is going to definitely help us out. Probably also with, as also happens in other fields, and can give some recommendations or assistance throughout the use of the software. So it can also give pointers, or well, we are already applying those techniques, but definitely is how AI is helping us, at least being our coach or partner or assistant on that.
Yes.
On that.
Yeah, that's awesome. Paulo, here's one for you. Is it possible to extend authentication from one device to another? For example, on a desktop, I don't have FIDO capable device and I can use my mobile to extend it. Example via QR code. Just what do you think?
Well, you can build it yourself. It's not a feature that is given out of the box by the specification. This is kind of one of the solutions you can do to do multi-device authentication. So you can authenticate with your mobile phone because you already have their fingerprint sensor, so you can use your biometrics to unlock the chip, get the private key to all the handshake login ceremony, and then you just generate like a magic link, which is kind of very popular if people using Slack, where you just get like this temporary link that you get on email and you have a few minutes to use it, otherwise it's gone, and you log in on your desktop. This is one possible way to address the problem. But now it's just about we're just talking about being creative here. It's
right, of course.
It's not a part of the spec. The spec is not really concerned with this kind of use cases. The spec is only concerned, okay, I want to authenticate the user authenticated, done. From now on, it's all about us as architects, as developers, to think out how can we solve the problem.
That sounds really awesome. It's kind of straightforward, and that's really what it comes down to, right? Is for people to be secure. Guys, do you have any advice on that too?
I think it reminds me. We talked before about how at the end you need security to be user friendly, because otherwise people will try not to use it or try things to circumvent security. I think that one of the great, and we were talking about the pin for Windows before, it just remind me how they actually think better, and not, I'm not only an Apple fanboy, but here they actually had a great idea. If you have a Mac and if you have an Apple Watch, you can use your Apple Watch to unlock your Mac without having to put your password. And I think that should be the idea, right? So that you authenticate once when you put the watch on your wrist, and then it can detect that you're using your device, your laptop, because it's the same account, and so you can really is security because it already knows it's you, and so you don't need to add any additional authentication on your Mac, and it unlocks it. I think that should be also the future, being able to e-security so that you don't need to think about it, but it's running behind the scene transparently. Same thing with the Face ID. There are a lot of innovation in that field, and I think that doing multi-device authentication is really a great thing if you can only authenticate in one device and then unlock everything else once we know that everything belongs to you.
That's I think that's the trend too, isn't it? It's kind of like, what I have in my possession, what I have and what I own, and then that can unlock other devices that I have.
Yeah.
As long as someone doesn't steal it from me. I'm sorry but that's true, right? I mean, sometimes there's other factors involved here that, wow, that's a good idea, but here we go. Somebody stole my
but
Apple.
someone needs to physically steal it here. So that's actually harder, right?
Thank you for telework. I don't have to worry about that one very much. Okay, here's another crazy question. Okay, this is actually for all you guys. Any book recommendations? Because this is incredible. This is an amazing topic, and I think it's really important for us all. So, there you go. There's the floor. And what kind of books should people be reading?
Yeah, definitely a must-have question, and well, it would depends on what excites you. But at least it's kind of funny. I have a couple of books here on my desk, so probably for the authors, you can also pay me for the free marketing. Yeah, so here we have
say whatever you want, man. Oh, here we go again.
Yeah, from the O'Reilly, the building is building secure and reliable systems. I'm gonna just put that on the. I'm gonna be publishing that, and I have also from one of my friends, Tanya Janka, a really good entry book called Bob and Alice Learn Cybersecurity, just to get started, kind of. Now, if you are in a more advanced way, let me just grab it from here.
Yeah, go ahead. 1, 2.
Yeah,
okay.
Yeah, so now if you are in a more advanced, then you can get into like hands-on hacking, probably from Wiley, from these. So probably it just depends on kind of your mood, and well, if you are more a generalist or you want to get into hacking, penetration testing, or these kind of things, offensive security, purple, blue team, red team. Well, that's so probably at least those ones. So hands-on hacking. Building secure and reliable systems. This is a really good one, by the way. Yeah, so just my
another advertising. That's cool. Guys, you got some books to show? You got some stuff?
I have also one for you. So let's see if I can show it with the background.
Well, it disappeared. It's a hack.
Yeah, it disappeared. It's Startup Secure.
Startup Secure.
And actually, it's a book that tries to teach you if you're building a startup, and so you don't have time to invest in security. What are the minimal things that you need to do from the day you start the company to the day you sell the company, right? So I think it's a great book because you never have really time to invest in security, and so the book actually gives you the minimum. It's actually also the kind of the same thing that we're doing at JIT, right? Trying to give you the tools for the engineers how to add your own security to your product. So in the kind of the same spirit to do the minimal thing, you can read this book. It's a great one.
That's super awesome. I've got a personal one for you, Paulo. Here, this is another one for you. When do you think will web authentication become mainstream? So when will the major cloud service companies, but also other industries, banking, social, support it for their cloud services? Do you think that it would, the web authentication for cloud services?
Yeah, I do believe it's coming soon, because I see Microsoft doing a big investment on Azure. They just announced that they just support WebAuthn on their Azure accounts, enterprise accounts, and I think after this, the other major cloud providers will follow. And as you can see, Apple is investing a lot on the operating system. Both iOS and macOS are just trying to get a better user experience by using this technology. They are developing the passkeys with iCloud. I do see some banks, especially also already in the alliance, like the Bank of America. It's there. They are
Interesting.
interested in working on this, and I do see some banks here in the Netherlands that are also doing some investment and development in the area, like the ING, which is like I think, yeah, it's an international bank. And I think it's going to be even bigger because the WebAuthn working group is now also there is another group on the W3C which is related with payments, and once secure authentication meets easy payments, I think that's like the funneling where this is going mainstream, because then you just use your fingerprint to authenticate in your shop, and you can use your biometrics and your private keys again to confirm a buy that will be sent to your bank, and the bank will issue a payment. So once all these things start to work better and better together, so like all the cogs in the machine start rotating,
Yep.
we are in that direction.
I got okay, cool. We got one more question, and then I've got one last thing to ask all of you. Okay, I'm trying to find it. Here it is, right here. I heard some satellites were hacked recently. How can we add security to those? Do you have any ideas? Do you have any advice? Just curious.
Turn them off.
No Wi-Fi. Just kidding.
Yeah. Once you are exposed on the internet, that it's just a matter of time.
Yeah.
Yeah. Exactly what Andres was saying, right? Somebody's going to hack it, right?
Yeah.
That's
I
crazy.
don't think we can do a lot, right, about it.
Yeah, absolutely.
Any system can be hacked at the end. I don't think there's a system that doesn't have any 0-day vulnerability. At some point, we could see what happened with the log4j vulnerability from one day to the other. The whole world suddenly was vulnerable, right? So you can never predict what will happen.
You know, it's funny because all of a sudden, all my managers knew what log4j was. Because of the alert. I mean, I'm like, wow, everybody's an expert now on log4j. How come you didn't understand it when you were in design review? But whatever. Okay, so here's the last part. Okay, you guys got the floor. 1 minute, all of you. Just give us some advice out there. Just throw it out to us. I mean, what's the best advice you can give us all? Okay, somebody just go.
Don't reuse your password.
That's a great one. I would say, and this is something that we're trying to tell everyone. We're trying with this concept of MVS, minimal viable security, like MVP. Usually, minimal and security don't go together. What we're trying to say is that don't try to boil the ocean. Try with the minimal stuff. Trying to do the most critical stuff. Adding MFA everywhere. Trying to check your codes with some very basic SaaS tool. Check for misconfiguration in your cloud environment. Do the minimal stuff, and try to configure all your tools to only show the critical stuff first, so that it won't be overwhelming.
That's awesome advice. Andres, finish it off for us. What do you got?
Just to close, 2 points. Trust people in the real world. Don't trust them on the internet. And use your curiosity. So now that whenever you see a piece of software or anything, be curious about it. Try to understand how it works and how you can break it. So I'll leave you with that.
That's cool. I think you call it a chaos engineer, right? And I think I'd be really good at it. Just break everything. Guys, this has been so awesome. I mean, we got to go. Thank you so much. And I hope to see you back. And by the way, I know we all agree with this. Geekle, thank you so much for doing this. I mean, seriously, you did such an amazing job. It was awesome.
Thank you, Mike. You were great.
You guys were awesome. I really appreciate it.
Cheers, Mike. Cheers,
Bye, guys. Yep. Have a good
everyone.
Bye. Bye. And I think I'm finished. What's up, Rob? I'm going to go ahead and end it, and I think I'm off. So, all right, everybody, I'm going to end up. I think we have a break coming up. And thank you to everybody. And one more time, I want to iterate this. Gigo, thank you so much for doing this. I know there's a lot going on, and we all love you very much. And we think you're the best. And this was so super, super amazing. Thank you for the hard work you did. This is Mike. I'm out. And everybody have a good one. I'll see you next time.
Hello, everyone. Welcome to the day 3 of WSAS 2022. That is the Worldwide Software Architecture Summit 2022. Hope you guys might have enjoyed all the 3 events that happened over the 3 days, and we are into our final event. I would like to thank the Geekle team and the team in Ukraine for their efforts with whatever is going on right now. So, we are in our day 3 final event. So welcome everyone. I'm Rohan Brasne. I work at ServiceNow as an architect and lead a couple of products. I am based out of San Francisco and I'm working from my garage right now. Today we have, in this last session, we have 4 amazing speakers lined up. The first one being Rob Richardson. Let me add him to the stage. Welcome, Rob. Would just like to introduce Rob. Rob is a dev advocate at Savile. He is going to speak about, he's the Microsoft MVP, and he's going to speak about all about data storage. So Rob, stage is all yours. Welcome
Oh,
to
great.
the event. Where are you
I'm
based
so
out
glad
of,
I
Rob?
can be here with you. Are you able to hear me okay?
I am. So that's perfect. Rob, where are you based out
Great.
of?
I'm in Phoenix.
Awesome. Oh, wow. Nice.
Yeah, a little bit quieter in the world than you are, I hope.
Yes, I'm in the US, San Francisco Bay Area. It's cold out here in the garage, but yeah, we can get started.
Sounds great. Today we're going to talk about the history of data storage. We're going to take a look at data warehouses, data lakes, and data mesh. So this will be a lot of fun. Come join us. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been chasing similar speakers and it's never worked out well, which is why you can go to robrich.org. Let's head there right now. Head out to robrich.org. Let's click on presentations at the top. And here's data warehouse, data lake, data mesh. Oh my. The slides that we're going to look at are online right now. While we're here on robrich.org, thanks for the introduction. Let's go to the About Me page. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. I'm also a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp closer to you, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I do a lot with databases and data storage. SQL Source Control Basics, that was a lot of fun, minus Chapter 8. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into the data storage. We talked about this guy. Is data mesh a fad? Should I just skip this one and wait for the next one? Let's talk through each of the storage mechanisms, how each one came to be, the things that it was trying to optimize for, and the things that it might struggle with. Then finally, we'll dig into data mesh quite a bit and compare it to other services like DevOps and microservices, and take a look at how it compares. Database. So ages ago, the task came in, let's store some data. We built a monolithic database, not that unlike our monolithic application. So a user would hit a data entry app and store their data in a traditional transactional database. Well, a few years later, we had this idea that, well, we might want to use more of a structured approach. So we created structured query language. Actually, Donald Chamberlain and Raymond Boyce created this from IBM in the early 1970s. And SQL became that mechanism for accessing relational databases. So SQL. In SQL, we have consistent rows and columns. You could think of an Excel spreadsheet where every column identifies the type of data it has, and every row is a unique piece of data in that table. Then we have multiple tables, and we can combine them with joins. Now, we created this consistent data rows and columns with normalized data so that we could store this data in really compact ways, avoiding redundancy and optimizing for writes. Now, the beauty here in the 1970s was data storage was really at a keys, at a premium. So being able to store things small was important. You know, back when we spent thousands or hundreds of thousands of dollars for just a few megabytes of storage. And we got ACID compliance. Let's double click into ACID compliance. Now we have atomic, consistent, isolated, and durable. And as you grab these slides from robarch.org, click through to this blue link to learn more about ACID compliance. Basically, either the entire transaction succeeds or fails. We're not going to get part of the query's data in place and part of it not. So we know that it either completely succeeded or completely failed. In comparison, we could take a look at eventual consistency. Here's a link that talks more about eventual consistency. With eventual consistency, we queue it up to happen, but we're not going to wait for the results. If I stand in line in Starbucks and I place my order, I'm not going to continue standing in line until they deliver it. Instead, I'll go sit down. I may take a token. They may take a token, my name. And when it's ready, then they'll call my name and I'll go retrieve my results. So if I do a quick write and then read, I may get the old data. So we have ACID compliance and we have database normalization, and we mirror that monolithic app. This is really optimized for searching for a row and then adding or updating those few rows. It has a slowly evolving schema, and our security mechanism in databases is, well, that it was on premise. And so if you didn't have physical access to the network, you didn't have access to the database. On the upside, security was really easy. Changes were rare, so we had this small storage space and a strong schema to keep up with that. And then, a few years later after that, hey, let's create some reports. Now, we end up with a system kind of like this. Now, obviously, Tableau didn't exist at the time, but we can think of that as a great example for analytic systems that need to harvest trends on a database. So we have our analytics systems, and they're here to do bulk reads and identify trends in data. Now, that's very different than our traditional application that did a search and then just updated or added a few rows. Analytics. Analytics does that bulk read, and it really doesn't write. So we have a very different characteristic to these types of query shapes. So because it's querying in unusual ways, looking for unexpected patterns, then the data store may not understand these patterns and may not be optimized for them. Because of that, it probably locks the table on the off chance this query might update something, and that yields really bad performance in our transactional app. So now our databases don't look quite so elegant. We've got all of the benefits of having easy security and rare changes, strong schema, but now because analytics work so differently, we end up with poor performance in our transactional app because our analytical queries are taking such a long time. So a database. The TLDR, analytical queries work so differently that we end up with poor performance in our transactional application because of it. So how do we make the analytics fast? And that's where we get to OLAP, or online analytical processing, compared to our traditional database, which is OLTP, online transactional processing. So let's take a look at an OLAP database. With an OLAP database, we start to separate the transactional needs from the analytical needs. The data entry is one database, and the analytics is a different database. Now, the beauty here is that they have very different use cases, very different query shapes, very different expectations. In a transactional system, we will seek and then read and write a few rows. In an analytical system, we won't write, but we'll read a lot in bulk. So we end up splitting these processes like this. Our transactional application works with our OLTP database, and our analytical program works with our OLAP database. Excellent. Except for now we have this process in the middle that has to get data from here to there. So let's dig into that. That is an ETL process, extract, transform, load. We also have ELT, extract, load, transform, where we just pull the data out of one system, push it into another, and then massage it in place in that other system. But for this purpose, let's kind of group them together in that ETL process. It's the process of getting data from the transactional system into the analytical system. Now, we've kind of generalized this term ETL now, And so maybe we might want to say it's the process of getting data from one data store to another. It doesn't necessarily have to be from a transactional to an analytical, but that's kind of how we discovered this ETL process. Okay, so periodically, we're going to look through our transactional system. Maybe we're grabbing all data, or maybe we're only grabbing change data, and we're bulk reading that, and we're writing it to our analytical store. And yeah, in the same way that the analytics queries were locking our transactional store, our ETL process will lock our transactional store too. So it's not ideal. So we end up with this compromise. Now, if we run our ETL process more frequently, our analytics have more up-to-date needs. That's great. But if we run our ETL process more frequently, we have more frequent interruptions to our transactional system. So maybe we should run our ETL process less frequently to have less disruptions, but now our dashboards are out of date. This becomes the dilemma. Maybe we'll only run our ETL process at night so that it doesn't interrupt day-to-day application use. That means that our dashboards, by default, are a day old. That becomes quite the dilemma. So with our OLAP databases, we nicely separate the transactional experience from the analytical experience, so those databases can avoid that impact. But we do have an impact from the ETL process that needs to be able to do, well, basically that bulk work for us. With OLAP databases, the TLDR, it's good to get those transactional and analytical needs separate, but we now have this dilemma about how quickly or infrequently we do an ETL process to meet the needs of both transactional and analytical apps. So a few years later, we come up with some interesting things. Let's tune the analytical database for queries. And we get to our data warehouse. Now, the cool part of the data warehouse is we start to experiment with how can we make the analytical system faster, better, more tuned for those queries. So let's modify the schema to facilitate faster and easier reads. We end up with pretty much the same architectural diagram as when we had the OLAP database, but now we have more of a formalization of that separation between an OLTP database and an OLAP database. So our first experiment, let's remove foreign keys. Now, foreign keys are great for being able to validate that the related data exists when we're writing it, but in the data warehouse, we're not writing it, so we don't need those foreign keys. Now, maybe our application still assumes that relation. Maybe we still have a relation in our data catalog, but we don't need to enforce it on writes because, well, we're not changing this data. Next up, let's tweak our indexes. Maybe we can tune our indexes more specifically for our analytical needs. If we're, for example, doing bulk analysis on location, then maybe we put an index on country or city. And maybe that wasn't necessary in our transactional system because we were only referencing customers by ID. Next up, let's denormalize data. Now, hopefully I don't lose people, but denormalizing data does create duplicates. Now, we do this to avoid joins. So let's double click into that. Database normalization. As we looked at SQL, we created this normalization mechanism so that we could store data more succinctly, more compactly, and so that we could, well, avoid data duplication. We optimized for writes. The data existed only in one place so that it could be written and rewritten easily. Now, that's interesting, but in an analytical system, that's not the problem that we have. In today's world, we could grab gigabytes, terabytes, petabytes of storage really easily. Today's problems are not about compact storage. Today's problems are about latency. So in our analytical database, let's denormalize the data. In our transactional system, we'll have a customer table that looks like this and an order table that looks like this. In our analytical system, we will denormalize the data to optimize for reads. We have the order ID, the customer ID, but we also have critical details from the customer table in the order table. Now, if I want to query orders and get lots of information about it, I don't need to join the customer table anymore. My query is simpler, it'll probably run faster, We do have duplicate data, but data storage is not what we're optimizing for. We're optimizing for reads. So we've denormalized our data. Next up, let's experiment with storage types. Now, we had relational databases, and they work great for our transactional systems, but maybe we could play with a column store, or maybe with a NoSQL environment. As we compare relational on the left with column stores on the right, with a column store, we could think of this maybe like an index. Now, if we're optimizing for, say, states or countries, then we only have maybe a couple of hundred to optimize for. Now, that's really easy. I can go grab everything for a particular country really easily. It facilitates bulk reads. So if I have a column store, maybe I'm able to store that data more compactly and query it a bit faster. Similarly, as we experiment with SQL and NoSQL, here's SQL on the left and NoSQL on the right. You can see in the NoSQL example, we can nest data in the same record. So now maybe I can denormalize the data by nesting it as nesting children inside of it. Now I can bulk read that one piece of data, and I get all the dependent data without the need to join. That's an interesting experiment. The next experiment we can do inside analytical systems is horizontal scaling. Now, as we do horizontal scaling, we'll end up with more machines doing similar work. Let's take a look at the CAP theorem. The CAP theorem suggests that you can have consistency, availability, and partition tolerance, and you can pick at most two, or maybe one really hard. Zooming in on that, we have consistency, availability, and partition tolerance. And you can see that there, in this Venn diagram, there is no spot in the middle where I can have all three. I can pick one or I can pick two, but I can't pick all three. Now let's take a look at our analytical needs. In our analytical needs, we're not really doing writes outside of that ETL process, so we don't really have a need for partition tolerance or consistency because, well, the data is pretty much static. So availability is key. We want this operational and fast. So let's really focus in on availability, and so we can have lots of horizontal nodes that allow us to do analytics fast. That's excellent. So here's some of those experiments that we did as we kind of formalized this analytical process into the data warehouse, removing foreign keys, different indexes, denormalizing data, different storage engines, and horizontal scaling. So on the upside, a data warehouse, we can now evolve our schema differently to match the needs of these read-only bulk systems. Well, our data warehouse worked out pretty well. We now have a separate read-optimized data store, except, well, how do I query across teams? Now, as we get more and varied different types of systems, we might end up with multiple applications, and therefore we have multiple analytics stores, multiple data warehouses. How do I query across them? And that's where we kind of get stuck. It's difficult to discover the data warehouses in various silos baked in various teams, and it's even harder to query across them if I want to get corporate-wide learning out of the systems. What if I want to correlate new orders with collections? Well, they're probably very different teams, and so how do I discover their silos, and how do I join them together to be able to get insights on orders and collections? Yeah, data houses struggle with that. On the upside, we were able to grow our schemas differently. On the downside, it's hard to combine this to holistic organizational learning. So we evolve our data warehouse, and maybe we can do ETL between our data warehouses, or let's take a look at data lakes. Now, data lake is the answer to how we start to evolve our schema to organizationally learn things. In a data lake, we're going to consolidate all of those data warehouses across all of the teams into one spot, one data lake. Now, this data lake might have lots of different types of data, and so we might have different database stores from different vendors, and those all come together in this data lake. Here in this data lake, we also have a data catalog, so BI tools might be able to look through the catalog and understand where various data is. Each of our applications now does an ETL process to get data into the lake. Now we have a great spot where we can start to optimize for organizational learning. And we can really put experts here in our data lake team to be able to onboard new data sources and make this really top-notch available for our organization. Now that's amazing. We have different data types welcome, unique schemas, different storage engines, duplicate data is welcome. Now we can query across the enterprise to be able to learn lots of things. And we end up with a data mart. This is really cool. So our data is presented as products. We now have SLAs for performance and availability on our data products, and we can kind of now present this in our data catalog so that consumers have some consistency and dependability on their data sources. The data lake. We have the specialized team to be able to ensure uptime, availability, and the ETL jobs run successfully. Now that's great, except for how do I get my team's data into the data lake? We end up with competition between various parts of our organization to be able to get their data into the data lake. No, I think mine's more important. And now our experts keeping the data lake up to date don't really understand the domain knowledge of the data that they're caring for. What we end up with is our data lake becomes a data swamp. It is highly available, but the data in it doesn't make sense. Maybe we don't have all the data in the data lake, or maybe we imported it, but we don't know what it means. When any consumers have questions about it, all we can do is point fingers to the ETL process, which gets us back to the domain experts, but the domain experts didn't put the data in the lake, so yeah, we end up with the data swamp. Here with the data lake, we do have experts caring for the data and ensuring that it's highly available. But it's difficult for us to get content into the lake, and so we end up competing with other teams to try and get our data into the lake, get time with our experts, and so we may end up with a data swamp. The TLDR for a data lake, it's available and discoverable, but it may not make a lot of sense. A few years later, let's take a look at how we can avoid the swamp, and we end up with, well, we consolidated all of our data warehouses into one data lake to try and get availability, but we sacrificed domain knowledge. So let's do a data mesh. In the data mesh, we distribute all of this knowledge into the spots where the domain experts lie. So each team will manage both their transactional and their analytical systems, and then we can have a central data catalog that allows us to discover all of those pieces. So we end up with a view like this. Now, each team is going to have their own transactional and analytical systems. They'll manage their ETL to get data into it, but this becomes our data mesh. Lots of little services. We can kind of see how this might look a lot like microservices. Now we end up with a data catalog, which is excellent, so consumers can look through the data catalog to understand where their data might be. And we might create unique data products that are combinations of data warehouses. That's excellent. And our data lake becomes one of the nodes here in our data mesh. That is wonderful. A data mesh is a methodology, and the principles include distributed storage, a central data catalog, and presented as products with SLAs around availability, consistency, and quality. With a data mesh, we have our domain experts that maintain the transactional piece, also maintaining the analytics piece. So if we have any questions about the data quality or data definitions, we can go to those domain experts that understand it very well. Domain data mesh. The analogy I like here is like a grocery store. When I'm in the bread aisle, I can see lots of different types of bread. Now, the grocery store didn't make the bread, but the grocery store is able to aggregate all of those brands. I can flip through them, I can compare labels, and when I'm ready, I can purchase the type of bread that I want. Now, this analogy breaks down a little bit because in the grocery store, I'm purchasing the bread from the grocery store. In a data mesh, I'm purchasing the data from the APIs that created it, from the actual vendor. So taking this grocery store analogy apart, I would then drive to each baker now that I had discovered the type of bread that I wanted. So on the upside, our data mesh now allows us to be able to continue with that SLA concept that we wanted. We have highly available and high quality data. And we have, now it's faster for us to enroll new data as well. On the downside, we might have some duplication of effort to be able to get data listed in the data catalog and maybe creating the stable infrastructure to get us going. Also, it might be possible in our organization for us to lose track of data because it didn't get integrated into our data mesh. The TLDR on a data mesh, it is a methodology, not a technology. So let's compare this to other things that we have in our system. We have microservices. Comparing data mesh to microservices, both of them have lots of little specialized things. Each thing does that thing well, and we can combine them in really interesting ways to learn more. Ultimately, the whole is greater than the sum of the parts. Similarly, we can compare this to a DevOps methodology, where we have a cross-functional team accomplishing really amazing things. We can deliver faster and higher quality products, and the team responsible for building it is also the team responsible for maintaining it. We can. So what about the data lake? Should I abandon that and start over? Well, the data lake is a node on our data mesh. We have lots of data warehouses, and the data lake can become a node there too. Do I have to dump my tech stack and start over? You don't. Don't retool the technology stack. Instead, distribute the data experts to the teams to help them get their node enrolled in the data mesh as well. So, should I skip this one and start over? I don't agree. I think data mesh is a concept that will continue with us. Here's other tech methodologies that we thought were once fads. The internet, agile, DevOps. Now, what made them unique was they were methodologies, not technologies. So, is data mesh a fad? I don't think so. Data mesh is great for being able to discover data across the organization, easily publish data products for consumption by others within the organization, and domain experts can focus on delivering high quality data. I had a lot of fun giving this talk. This is built on an article. If you want to dig in farther, you can grab this link to the data mesh article on cyril.com. You can grab these slides right now on robrich.org and hit me up on Twitter at rob_rich if you want to continue this discussion. For those of us here live in the event, what are your thoughts?
Oh, that's a great refresher, Rob. I loved watching it. What a great story narration on that. So it's been amazing hearing all the things and in 30 minutes. So yeah, that's super awesome.
Yeah. It was quite the journey to try and get from the 1970s to today in 20 minutes and 30 minutes. But yes,
That's
it was
true.
a fun journey.
Yep,
And I understand we have a Q&A in a few hours. I'd love to join and be able to talk more about data mesh.
Absolutely. We do have Q&A, and our next speaker has still 4 more minutes. So yeah, we can get back then as well. And I just had a couple of questions. Maybe we can take them in the Q&A sessions. Maybe I'll ask you something else. So
that sounds
are
great.
you working at Cyril right now?
I am.
Is Cyril in data mesh technology? Is it a product company? Or
Cyril does really great for securing databases and data lakes in your data mesh. So, the great example is traditionally we'll draw the security boundary around our network. Anybody on the VPN has access to the data. But in today's cloud native world, maybe the BI tools live in the cloud, the databases live in the cloud, the users are maybe disconnected from our VPN. How do we control our data access if none of the data flows through our VPN? Cyril is an excellent product that allows you to secure those data stores through SSO authentication and log that data into your SIEM of choice so you can alert on data access entry violations in real time. It's a lot of fun.
Interesting. That's good. Awesome. Thanks a lot, Rob, and see you back in the Q&A session. So thank you. Thank you so much.
Sounds great. See you in a few minutes.
Next up, we do have Murat Parlaksek. Let me add him to the stream.
Hello.
Hi, Murat. Hey. Murat is a software developer, senior software developer at Amazon. He's going to speak more about the mobile data modeling, right from his journey from using his first mobile phones to the 5G.
Yes.
Murat is based out of USA. Where are you based out of in US?
In California right now.
In
Bay
California.
Area.
That's cool. Bay Area. Oh, I'm from the Bay too. So nice to see another Bay Area meet there. Awesome. So Murat, stage is all yours. So yeah, feel free to share the screen and I can add that to the stream.
Perfect. Just a minute.
By the way, what was the first mobile phone that you use when you started programming?
Oh, it was the Motorola, and I start with the Motorola devices. So,
Oh, nice. That's cool. Awesome.
so
So
yeah, I want to give some the. It's not much more the deep dive. It's much more the, I can say, 10,000 mile away. What is the model change in the from the first generation to the fifth generation mobiles, and what this one is affected the developers. I want to give what my the history, and I have been working nearly 20-25 years in the mostly in telecommunication area. So in telecommunication evolution, everything started in 1980s. So if you look at that, every 10 years takes to change to the old generation. As a developer, it takes too much time, so because we are changing our codes in every week or every day. So it is it is the difference is too much for us. But that time is 1990s. It is not much. And also another thing is in telecom networks, there are multiple vendors and multiple equipments working together. So and the 3GPP specifications has to be clear that which the equipment work, how they are communicated each other. And I will start with so right now the 5G is deployed in US and probably in the other countries too. And then now the lots of discussions starting for the 6G. And I will not explain these ones, but for the 6G, people are start to, especially professors are talking about how can we communicate under the water. So, but this is the another journey. So let's start from the first G. So this is the first one, probably nobody's seen before. And in the 1980s, the first idea for the telecommunication is to call the only voice. So the telecommunication only focusing on the voice. So this one is only using the analog switching. They are using the frequency modulation. There is only voice, nothing else. So you cannot handle anything. And for what is the where can you use this one is the only fixed location because it is too heavy and there is only using the cars. But what is the developer opportunities for what the developers are doing these ones? In our days, we can only implement these protocol, FTMA protocols and the switching, but not much more people working on that. But our journey is starting in the 2Gs in 1990s. In the 2Gs it's changing to the digital switching. So which means that the packets there were no packets, but these are the switching are turned to the digitalized. So in these ones, so we can use the voice and there is a SMS that's nobody is using or not much more using anymore in SMS. And you can use this emails for the data. And the data rate at that time, if you can see that these are not the megabytes or gigabytes, these are this 14 to the 64 kilobytes. So very limited data. And so where can you use? You can use everywhere. There's no location for that. Wherever 2G coverage, you can use all the mobile device, but there are not much more devices. As we discussed, there are Motorola's or Nokia's or these kind of devices where there are not much more devices. But what are the developer opportunities for us? And these days, because there is the only SMS applications that can be written. So for the developers, that we just implement SMS protocols, and we create some SMS services for that. So I will go through that. What are the SMS services at that time? Because while you are starting in 2G, 2G was not enough. As you can see, 64 kilobytes. So they increased this one in couple of years. So they are changing this one to the GPRS. Probably you are seeing this one. If you are far, far away from your location, you will see this edge in your phones. And this one is covering the very low bandwidth still in terms of the today's world, but it is going up to the 400 kilobytes, and we can see these ones. So this is also bring us as a developer to reach and get the data from the device. And for the developer opportunities for us, because still in the 2.5G, we don't have fully connected to the internet. We are only the telecom operators are so closed, and there is only you can implement the applications inside the telco operators. At that time, what kind of components do we have? How can we write the applications? For the devices, we have the WAP, and this WAP is equal to the HTML 1.0. So there is no the picture, nothing inside. Very similar, just the text-based information. It's not going. That's the only thing you can implement. So how can you use that? You can gather some weather services. You can gather some information for daily basis. That's all. And there is a Symbian, is the C-based application. It's initialized, so there are some mobile devices are supporting the Symbian. It is hard to implement for the C code inside, but this is not the bad. So this is the only thing. This is just the start to start in the device applications. So at that time, because these are the closed the systems and the telco operators are able to write their applications value-added services, which means that so instead of to the voice, they can gather more money with the value-added services. So you can gather your logo, you can get your melody, or you can get the weather information based on the location-based services. Or yeah, we were implementing the SMS group chat so people can chatting by SMS together by sending the the phone number so it can communicate each other. And by using the Symbian the applications inside the devices, you can write the turn-based games. But these are not the fully the multiplayer used applications. These are much more using the single player applications. So how the architecture is implemented, how can you bring up these devices? How can you bring your application in the architecture? Generally, these all applications in the server-side applications, because the devices are so limited, so you cannot hold to the cookies in the device, and you can gather this information in the server side. And these servers are always located inside telco operators, because the telco operators are putting some cookies based on the devices, so you can capture this information and handle inside your application. But these are the sending by the telco operators web servers. And the only thing you can implement the client-side game, so there's not much more thing for the 2.5G. Even if you go far away, you cannot reach the internet, or what. Let me say that you can reach the internet, but you cannot gather much more the information as you expect today. Then everything is a little bit changed with the 3G. And because 3G is now turned to everything to the video calling, location tracking, and the web browsing, no more web. We are currently using the Web 2.0. Everything is supporting, and there is a multimedia message support. You can send the photo from the SMS, and it's supporting in the system, and the data rate is increased. And for the developer opportunities, now we can write the application inside the telco operators as we did in the 2.5G, but we are able to implement applications for the device, because that day, there are lots of the components come to us for the 3G. Symbian, iPhone, Android, BlackBerry. And these are the devices and the applications that the different frameworks that we can write inside the device. This gives us, as a developer, lots of opportunity in the system while in the 3G networks. As you can see, the value-added service is going down a little bit. And there is still bulk SMS marketing, term-based games, SMS group chats is still going on. But for the operators, but for the applications are much more moving to the devices. So at that point, we are, as a developer, we are moving from the operator system to the much more the cloud base in the system. So our applications turn to the client server applications because right now the data rate that is reached to our expectations. There's a high latency, but at least you can get some information. And because of the device capabilities, clients are much more intelligent, and you can gather the location-based information from the device. In the previous systems, location, you cannot gather the location from the device, so you have to ask the operator to get the location from this phone number, and the operator give you the location. And this is not right because of the triangle algorithms. They are giving to approximately 50 meters or 60 meters, so you cannot know the correct place. It's not much more easy in the previous systems. And still in the 3G, because the servers are mostly located in the operator infrastructure, but this is not the mandatory. This is because the people, especially the developers, doesn't know how to get the money, how to earn the money within the 3G. And we, especially developers, are doing the revenue sharing with the operators these times. That's why most of the servers, most of the applications going to the servers. And there are still lots of the multiplayer games, and TV streaming is just started. And TV streaming is still going inside the operators network, and it's still in all the applications still located in the operator systems. And this is the big point where everything is perfect for the developers and for the 4G. I am going a little bit quickly because I just want to give the history of what's happening just before that. So as you can see, we move from the operator network, or so we move applications to the devices. And now we have 1 gigabits connected data transfer capability max. You may not see everywhere, but in the idea, theoretically, you can gather these information. And this is the mobile development era for everything. So we can write from all the health informations, we can track all the banking informations. And as you can see, all the developer components, iPhone, Android, and BlackBerry is still there at that time. And we are using the Web 2.0 for the developer components. And there are lots of the different devices in the system. So for the value-added services, in terms of the operator, not much more using, because all the things like, for example, weather or some of the informations, or everything in the internet, and all the informations are getting from the systems. So operator is much more working as an internet service provider, and all the applications move from the operator's internal servers, move to the cloud. So you can deploy your application anywhere in the world, so you don't have to be bind for the operator. So this is scalable all over the world. Whenever you implement any iPhone or Android application, you can deploy to the cloud, and you can deploy to the Android iPhones, and everything going through that. So all the communication going from the device to cloud. You don't have to need any operator. You don't worry about which operator they are using. But what are the problems for the 4G? There are too many variation of the devices. So, for example, the size of the Android devices and the capability of the hardware, whether they have the right cameras, whether they have the right CPUs, and whether of the size of the screen, everything change. So as a developer, you have to test everything for each device, and you have to validate your application. If you, especially for the gaming applications, you have to take care of all the size of the screens, and it takes too much time. It's take too much responsibility in the systems, and there's a it is the bottleneck for the developers. And application changing for the especially iPhone, Android, there's a lots of verification process. You have to change everything, even the logos and everything has to go through that, and it's really difficult to change anything, especially inside the devices. Because of that, lots of the developers try to think about why we are using the iPhone and Android applications if we don't touch the device capabilities, or let me say that variables, for example, for a hardware. If you don't need to reach to the hardware, you may not need that. That's why lots of the applications move from iPhone, Android application to the Web 2.0 applications. So you can manage everything in the website and everything. So browsers are much more powerful in the devices now. They don't need any embedded application inside the device. So lots of the applications that we saw in the last 5-6 years, lots of the applications move that path. So they don't have to manage everything in the embedded devices. And the worst thing is for the 4G. It's not about the applications, but it is good for any gaming applications. But because of the latency is too high, this is always the problem for the latency. It's not good for the AR and VR, augmented reality and virtual reality. Even the robot management, it doesn't work well. Let me say it again. So what does it mean? What is the AR, VR robot management didn't work well? Because if you are implementing augmented reality and virtual reality and all the application inside the device, if everything is embedded in the iPhone and Android, it works fine. But it is not capturing all the real-time data. And if you have to improve the augmented reality parameters, if you want to change the world, you have to deploy your image, or you have to deploy everything to the iPhone and Android again. And it takes time. It is not scalable for the systems. And the robot management also doesn't work well because of the latency. It's not about the application, because, for example, you are looking to the line, and in the line you are checking the apple, which one is good or not. And you have to respond very quickly while the apple is going down in the line. So you have to understand which one is good. And this is not easily to handle in these devices. And because of this, we moved to the 5G. At that point, as I mentioned in the previous timeline, before the 4G, everyone is waiting for the documents and protocol designs, but the 5G takes too much time, and all the developers and all the vendor equipment builders say that we want to build our own. We want to decide what kind of protocol, and these 3GPP also agree. They just created some template, and based on this, they are filling these templates based on the results from the real world. So they are engaged with the mechanism. So they are not writing and finalizing in 10 years. They are waiting from all the vendors, all the industry to gather information and give these feedbacks and improve the architecture. If you look at the latest specs, it is not as much detail defined as previous. This is much more giving to the template for all the developers. So what is in 5G? Why it's important? And in the 5G, it is 10 times up to the bandwidth is increased 10 gigabits. And the most important one is the low latency, which means that it's less than 10 milliseconds. But when I say the 10 milliseconds, it's from the device to the wireless server. So it's not to the cloud. It is between these devices, less than 10 milliseconds low latency. And there's a lots of small cells. So to cover for example, in one street, you have to deploy maybe 5 or 6 different cells in each places to cover up these low latency and get the high bandwidth. And developer opportunities, everything will be mobilized. Everything is for the developer opportunities, everything's turned to the 5G. All the applications move to the mobile. And what are the developer components? So we don't have a Symbian anymore. Unfortunately, we don't have a BlackBerry, but iPhone Android is here, and we are still using Web 2.0, and probably we will use the Web 3.0 in the future. What are the applications we are using? What is changed for the previous ones? Nothing changed in what we are using in the 4G. If you are streaming, watching the videos, if you have a game and playing, everything works as is. Nothing changed. But there are the enhancements because we couldn't design our architecture in the 4G. For example, AR, VR. Because we have a high latency and we cannot gather information from the cloud and we cannot handle the robots. Even because of the low latency, your operating system for the devices may be located in the cloud because you can, with the low latency, you can build everything in memory, so you don't need anything in the device anymore. And another applications that they are doing, and lots of the demos are going, for example, people are doing the live remote surgery while using the 5G networks. So how the architecture is evolving? What can we do to handle the 5G? What is our applications should be aware of? So first of all, cloud has to be approached to the operator's network again because of the low latency. So if we are so far away and if there is a lots of routers, so this one increasing the latency. So now the clouds are not only some places, so they are the places so the cloud operators are deploying the systems much more close to the operators to catch up to less than the 10 milliseconds response. And the location that we are getting from the device, is it enough? It is not enough anymore. So as we discussed previously, because the IP address or the location address is not showing us which the wireless is close to our application. So we need some APIs from the telco operators to get these informations. And this is still on progress. Probably lots of the operators are working that, but this is need for the developers because if you write an application for the self-driving cars, you need to get the low latency information from the closest to the cloud. And another thing, because currently what we are doing, we are creating the applications in the cloud, and for scalability, if there is a more request coming, so we are scale this one easily. But for the low latency and our devices moving, so we have to share current information because the cloud is spreading all over the places. It's not in the single point. So there is lots of the locations that it's close to the operators. So if your location is changing from San Francisco, let's say from San Francisco, if you are moving to the Los Angeles, while you are driving, so you have to gather the information and you have to understand which one is the closest. And based on that, you have to move your current data to the closest cloud port so you can communicate with the low latency response. And client applications, because of this low latency, do we need more detailed or more core application in the device? You don't have to write a gaming application in the device anymore. If you are stream all the videos and if you gather all the gaming, the date information and send back to these servers, so you can play your game in the cloud and you can watch with this live stream and low latency, you can play in any device. So devices will be simplified and all the applications levels can be go to the cloud and handle much more easily. And this is the next generation, and we are still working on progress. There is lots of things going on for the 5G. It is not fully deployed yet, but it is going on. If you are planning to write the application 5G, which needs the low latency, so you have to think about these architecture parts. And that's all from me. Is there any question?
Hi, Murat. That was a great journey of all the G's. So I loved it. Love to hear what happened in early 1980s and what's happening now. And looking at low latency, we see it's super critical to have those low latency devices. We do have our question answers session that's going to happen after all our slides or our speakers speak. But yeah, we'll get back to that. I see a lot of questions already. Well, from the perspective,
we can
yeah,
talk
go
in
ahead.
the QA part. That's okay too.
Sure. From the perspective of this reminds me, like when I was a mobile developer, my first mobile app was written on J2ME phones, the Java-based phones, and it was super hard.
Yeah.
Like even writing mobile applications on Palm
Oh,
OS, we
even
had
I
to
missed
add.
that. Yeah. Yes, that's
Yes.
true.
So, like, if I go back and want to program it, I would definitely not. I'll stay away from them. You had fragmentation issues. You had to be core
Correct.
C++ developer. But now it's getting more and more helpful for the developers. So, yeah, we have a bright future on mobile development. And it was a great presentation on the architecture and what other development opportunities you have on each of them. So that was amazing.
Thank you.
Thanks. Next up, we have Suleiman Sadiq, who is from Canada, and let me get him onto the stage. So I know we are starting 5 minutes early, but yeah, why not? Let me add Suleiman to the stage. Hi, Suleiman, how are you?
I'm fine, thank you. Hi.
Hi. So Suleiman is a solutions architect at Red Hat, and his focus areas are on public and healthcare domain. So, what part of Canada do you work from?
So I'm in Toronto, Ontario.
Oh, nice. That's cool.
Yes.
Is it in the Eastern time zone?
Yeah, so it's the Eastern time zone. That's right.
Okay. Awesome. So let me add your screen to the stream, and the stage is all yours.
Okay. Thank you very much. It's really great to be here today. So today, really, I'm going to be talking about hybrid cloud application integration with open source. So I'm going to talk a little bit about Kubernetes, Kafka, Copper, and GitOps. So what I'm going to try to do today really is to talk about open source. Talk a little bit about Kubernetes, Kafka, Copper, GitOps, and then I'm going to try to really come up with a very simple architecture of a solution that utilizes all of this in a hybrid cloud fashion. So without wasting much time, let's dive into it. So first of all, who am I, and why am I even here talking to you today? So I'm Suleiman Sadiq. I'm a senior application platform solutions architect at Red Hat here in Canada, and I help public sector and healthcare clients within Canada to modernize their existing applications, build new applications faster, modernize their current application platforms and development process using open source, hybrid cloud, and automation. I've got around 2 years of experience working across different domains, including consulting, healthcare, banking, and technology. And outside of these, I'm an enthusiast for open source, multi-cloud, and of course hybrid cloud. Again, I would really love to I would really love to talk to people, meet new people. So please do reach out. If you have any questions after this, please you can reach out to me via LinkedIn. My email address is there. I'll be very happy to talk to anyone who is interested to talk. Now, I'm going to quickly start with talking about what open source is. Again, I know we pretty much all know what open source is, but just because this is about hybrid cloud integration using open source, I'll do a quick overview of what open source is. Again, compared to proprietary software, open source really is a way of developing software in a more collaborative manner, where software is publicly available, and really anyone, myself, you, can contribute to that code. It is publicly accessible, and anyone can see, modify, and pretty much distribute the code. In a nutshell, that is really what open source is all about. So meaning anyone can go on, contribute to the code, make the code better. And open source software are really always robust, because again, collaboration is always better than developing in a closed manner. Now, jumping into our real topic for today, it's to talk about hybrid cloud integration. It makes sense to talk about containers and the evolution of virtualization on containers. And in the past, like we know, back in the day, we had applications deployed on a single physical server, where there's a host operating system, and you have the application deployed on top of that. Now, that wasn't the most efficient way to deploy applications for a number of reasons. One, sometimes the resources on these physical servers are just too excessive for the amount of for the code for the application we have on that server. And if we want to deploy multiple applications on a single server, what that would mean is there will be no isolation, right? Because they're sharing the same underlying infrastructure in terms of network, storage. There was pretty much no way to isolate the different applications that we deploy on a typical physical server. And then virtualization came about as a solution to this problem. Which virtualization, we would typically have a hypervisor installed on an operating system in a physical server, or you could also have the hypervisor installed directly on the server. In that case, the hypervisor will do all of the kernel stuff and everything. So yeah, so let's say we have a hypervisor, which would basically pretty much divide the resources into different logical units, where each operating system would have its own set of resources. So it would basically reserve resources for the OS. And in this particular case, we had all of this OS basically acting like they were on different infrastructures, because they would have pre-reserved storage, pre-reserved CPU, and they have their own IP addresses, individual IP addresses, individual resources for the different operating system that are deployed on this hypervisor. But again, that was really good for microservices. Of course, it was good, but still not good enough. And we needed, a much more efficient way to get things done. We needed our applications to be packaged into very small units, and containers came along. I'm not going to talk about containers right now, as I have it covered in my next slide. So, what are containers really? Again, I know a lot of us already really understand what containers are, but for the sake of this particular presentation, I'm quickly going to talk about this. Now, again, back in the day before containers, we used to have this issue of bugs and errors, when code is moved from one environment to another. So a typical example is a developer who has developed an application, push this particular application to, let's say, QA environment, and they just had too many issues, right? So, for example, in a situation where the configurations on the two different platforms are different, sometimes we have issues with the codes. We can have scenarios where different versions of libraries are used, from between the developer and the QA platform. Again, this could also lead to issues. So too much time was spent debugging codes, leading to long development cycles, just taking too long to get these codes actually into production. And let's not even talk about the high cost of running VMs. Then containers came along as a solution to this problem. With containers, what actually happens is the application code, together with the configuration files, libraries, and every single dependency needed to run this application is packaged as a single container unit, which is really small. And so everything really that's required to run the container, the application is packaged, into a small unit. So containers are really lightweight, start up really faster, and of course it consumes less resources. Now, getting more towards our topic for today, hybrid cloud. Hybrid cloud essentially refers to a mixed computing environment where you have services and applications and and infrastructure spread across different platforms. So that could be public cloud, private cloud, and an on-prem server. So a typical example could be an application or an application in AWS that consumes a service in Microsoft Azure, and they all write to a database and read from a database that is on-prem. And there's so many reasons why this could happen. Really, I know I work with a lot of healthcare and public sector customers where we've seen all sort of requirements, all sort of data residency requirements where they might really not want to put their data in the cloud. They might want to have their data, reside on-prem due to, different reasons. So that is one of the typical use case of, hybrid cloud. And Kubernetes. Again, containers was just was just part of the solution. We still needed a way to orchestrate these containers, to have them deployed, to manage these containers. So Kubernetes came along again as an open source system for automating the deployments, scaling our containers up and down based on requests, and really the management of containerized applications. In a nutshell, Kubernetes is portable, meaning that once we have our container, we can easily move them from platform to platform. So we can move it from AWS to GCP, back to on-prem. So it's really portable. But it's, again, extensibility. It is highly extensible. With Kubernetes, talking about Kubernetes, we can, since it's open source, we can really add to the functionalities of our Kubernetes. We could, do things such as monitoring, DevOps. It's really extensible, right? And again, as we know, it is self-healing. So that means when you run your application on a pod, once you deploy your application on a pod, if for some reason that pod cannot be reached, based on the liveness check that is constantly done in Kubernetes, if for some reason that pod cannot be reached or your application cannot be reached, what Kubernetes would do is it would try to restart that pod automatically. And if that can be done, it's automatically going to reprovision a new pod to replace the dead pod. So it is really, self-healing. Okay, now how Kubernetes work? Typical workflow. Now this is assuming we have, some sort of CI/CD DevOps pipeline in the picture. So you have a developer who's writing code. You have on an IDE, pushes the code to GitHub. Through webhook, Jenkins start up a pipeline to automatically compile that, into a container image, pushes that container image into a container registry. And from there, really, that just gets to our Kubernetes environment, whether on-prem, cloud, wherever that is. Now, this is a typical flow. But in the real world, it's not as easy as this. We've got to think about, to get Kubernetes working, we have to think about many different things. One, we have to start thinking about, provisioning the physical servers, VMs, all of that configuration. We have to start thinking about the OS, container registry, creating a CI/CD pipeline if we want to do DevOps. We have to start thinking about monitoring, alerting, and a whole bunch of different things, really. And again, upgrading and patching of our Kubernetes, right? We need to manage all of that ourselves if we want to do the the DIY, basically DIY Kubernetes. So let's jump into our use case to see how complicated or how easy this can actually be. Assuming we have a patient management portal, what we want to do is we want to deploy this portal on a Kubernetes cluster on Microsoft Azure. But then, due to some sort of data residency requirements, we need to have our database on-prem in a physical location, probably here in Canada, for example. And we want to do PostgreSQL. Now we have a different Kubernetes cluster for that, cluster 2. And at the same time, we want to be able to get patient monitoring data. So that means we want whatever some of the monitoring data some of the data that we have gotten on from this patient management portal, we want to send some of that data to a patient, let's say we want to send it to some sort of repository for analytics. And at the same time, we've got patients in the hospital in intensive care. They could be in different hospitals, the same hospital, doesn't really matter. And what we want to do is we want to get real-time data from the devices that are attached to that particular patient. We want to get real-time data into a repository as well for analytics. So we want to know if we want to analyze that data in real time, to know if the patient is probably having a more critical condition or if there's something that just needs to be looked at. So for the sake of this particular presentation, we're not going to cover the analytics part. We're going to talk about it, but that is not the focus for today. We're going to talk about all of the integration that we need to do to get this working. So in that use case, there are a couple of basic requirements. One, Kubernetes platform. We need to think about what Kubernetes platform we want to use. And there's also the database, which is going to be on-prem. We have events and data streaming because we need to get real-time data from the devices that are connected to that particular patient to analyze them. We also need some form of insight connect because we want to be able to, talk cross-cluster, cross-platform, cross-environment. We want to have that communication. In the same way, we also want to think about multi-cluster management because if we have multiple Kubernetes clusters, then we want to think about how we can manage all of those clusters easily, and there's also security. Okay, now moving. Again, in the real world, it's not always so easy. We have a diverse mix of environment, like I've mentioned, different clusters. We've talked about bare metals, VMs, and cloud. Now, again, to allow all of this communication to happen, we have all sort of firewalls that we have to go through. The different environments could have different, they could use different, one could be using IPv4, another could be using IPv6. There's also VPNs and VPCs, CIDR conflicts. We need to start thinking about IP addresses to ensure that the IP addresses are not within the same range just to avoid any kind of conflicts. And then there's also multiple administration domains to manage all of the different Kubernetes clusters. Now, so how do we then deploy application services across multiple Kubernetes platforms? Now, again, there are many ways to do this. There's always not one way to get it done. But I want to do this the open source way. So I'm going to talk about how I would do this the open source way, just to give us, an idea of a use case. So here comes OpenShift. Now, again, we've talked about all of the enterprise features that we need to kind of implement to be able to use Kubernetes on an enterprise scale. But then there's OpenShift, which is also an enterprise ready Kubernetes container platform. So it comes with all of the enterprise security, CI/CD, easy to spin up CI/CD, monitoring and alerting, and all of the stuff that we really need to get Kubernetes going in a matter of minutes. And again, it provides a consistent platform regardless of where we deploy it, cloud, on-prem, wherever. The platform is still pretty much the same. And we can choose to get started in a matter of minutes. If you want to go for a self-managed option like on cloud, pretty much can get started in probably 15 to 30 minutes. If you want to do a managed OpenShift, still a matter of minutes in most cases. So for the platform, I chose to go with OpenShift for this particular use case. I want to use OpenShift for my Kubernetes platform simply because I can get started in a matter of minutes and just get going. And then Scopper for the interconnect. Some of us may have heard of Scopper before. So Scopper pretty much is a layer 7 interconnect, so it operates on layer 7. And what it does really, it provides a secure communication between two Kubernetes clusters, and provides that connectivity across data centers. There are no VPNs or firewall rules. You can connect anywhere, on cloud, on-prem, and our applications can span multiple environments. So we don't need to start thinking about IP address conflicts, VPNs, firewalls, and all of that stuff that we'd normally think about. And all we really need to do is to create that Scopper connection between the two different Kubernetes clusters. We have to sort of install, deploy the Scopper router, get all of the tokens that we need, have the tokens on the different clusters, do the rest of the configuration, and we can have Scopper running in a matter of minutes. Just to visualize how this works, we've talked about our OpenShift Cluster 1 on Microsoft Azure, where we have our front end, the patient management portal. And then we have a local physical server which is a local server on-prem, an on-premise server. And what we want to do is to deploy Scopper on OpenShift Cluster 1, do the same thing for OpenShift Cluster 2, and create that connection with Scopper, and we can really start consuming information between the two different clusters. And I need to mention that again, Scopper is open source. Again, we're talking about open source today. And then we need to also think about event streaming, message streaming, since we want to be able to get data, real-time data, from the monitoring devices attached to this particular patient in intensive care. So we probably want to think about Kafka. Kafka, again, Apache Kafka, highly distributed, fault-tolerant, scalable message streaming platform. Allows us to create streaming applications, and Kafka would Kafka would scale to meet the demand of our application. So it is fully open source as well, and this is what we have chosen for this particular architecture. So we're going to be using Kafka. And then one thing we also need to think about is consistency, right? Because in a typical application like this, we're going to have multiple Kubernetes clusters. In each of those applications, we want to have multiple environments, from testing to development to staging to production. But what we really want is for all of these Kubernetes clusters to have the same configuration, right? Because we want our production environment to be almost exactly the same as our testing environment. So how do we do this when we have multiple Kubernetes clusters? GitOps. Now, for a lot of us, we might have heard of GitOps. We might have even used GitOps in the past. And the challenges here really are, again, multiple environments. We want similar state for configuration, monitoring, and storage. We want similar states for everything, really. We want a scenario where if we encounter some issues with our configurations in our cluster, we can easily recover to a previously known state. And with GitOps, there are really 4 basic principles. One, we want our system definitions to be described as code. So we're going to codify our system definition. The configurations, the desired state of our systems will be defined as code, which would be versioned in Git. The changes to the configuration can then be automatically applied using pull requests to individual clusters or all of our clusters at the same time. And we have a controller, of course, which would always ensure that no configuration drifts are present. So if for any reason a particular cluster, for some reason, doesn't have the expected configuration, so we have a controller that would periodically check and try to automatically get those clusters in conformance with our desired states. So again, In this case, we're going to be using OpenShift GitOps, which ships with OpenShift. And it just ensures that we have that consistency when we deploy our applications across the different clusters. Okay, so we're going to dive a little bit again into our use case architecture, into our use case. And if you take a look at this here, what we have tried to do today is we've tried to create what our architecture might look like. Firstly, we have our patient portal in an Azure OpenShift cluster. And then we have a Scopper router deployed on that cluster in that particular namespace or application. And then over here in 2, we have our local machine, which is bare metal. We have another OpenShift cluster where we've got our Postgres database. We've got a Scopper router in there. And what we've done really is we've tried to create that Scopper connection by really exposing those services to each other using the tokens that have been provided. And we've really created that connection. But another thing we also want to do is we want to be able to send certain data to Kafka. So again, we're going to be using Kafka. Like I mentioned earlier, I want to be able to send certain data to a central Kafka cluster, which is over here below, for analytics. And then over here at the top here, we've got our patients. We're monitoring vitals. We want to get information. We want to be able to stream the real data, the real-time data, and use that for analytics. So what we're going to do is, again, we're going to use Rozak, which is Red Hat OpenShift streams for Apache Kafka. So we're going to be using that as a managed Kafka instance. What we're going to do is we have the data streaming from the patient bed all the way down to our cluster here, to our managed Kafka cluster here, and we're getting that real-time data. But another thing we also want to do is, this is a local Kafka cluster here, right? We want to be able to push all of that data to a central Kafka cluster that's going to be used for analytics. So we're going to use Mirror Maker in this particular case. We're going to be using that in this particular case, and we just mirror our data. So in real time, we're going to have our data being replicated to the central Kafka cluster. So assuming we have multiple different hospitals or multiple different departments where we want to stream data from, we can have individual local Kafka clusters and then stream all of that to a central Kafka cluster that will be used for analytics. So this is again just one of the one of the architectures that could be used. We can use several different kind of architectures. And in this particular case, what would happen here is, again, just to reiterate what I have said earlier, we've got two clusters for OpenShift, one on Azure, one on-prem, communicating with each other using Scopper. We've also got a patient. We're streaming real-time data from the devices hooked up to that patient into a Kafka cluster, a local Kafka cluster. And at the same time, we're trying to replicate that data into a central Kafka cluster using Mirror Maker. And what we're really trying to do here is to use the data from the central server for probably some analytics or whatever we want to use that data for. And if you're taking a look at this here, I have a Debezium Postgres SQL adapter here, which is pretty much helping us to push data as well from our Postgres database into our central Kafka cluster for real-time analytics as well. Now you would think, well, this is we've got an architecture that we can use right here, and but what more can we do to this architecture? What more can we do? Can we make it better? Of course, there are always ways to make it better as far as architecture is concerned. There are always ways to make things better. So how about multi-cluster management? how do we manage the individual clusters? Now we've got 2 different clusters of OpenShift at a bare minimum. It could be more than that, depending on what other environments we need to have, from staging to production to all of that. So we could easily have upward of 4 to 5 Kubernetes clusters, or even more, depending on our use case. Okay, so back to our architecture. We don't know that with Kubernetes OpenShift, for example, we can visualize what's happening within our cluster, from a dashboard. We can pretty much see everything that's happening within our cluster. Manage security, manage things from our cluster, within our cluster. But how can we have a more holistic view, rather than switching between different administrative panels? How can we manage things from a single plane? So we've got advanced cluster management, which we can then use to manage all of our different clusters. So regardless of how many OpenShift clusters that we have, we can actually manage all of these clusters from a single plane. So all we need to do really is to connect all of those clusters to our advanced cluster management, just to be able to ease the task of managing these clusters. And then again, we've got the advanced cluster security. For security, we want to be able to ensure that we can see everything happening in our clusters regarding security. So if there are any threats to our clusters, we can see that from a single plane. If there are any deviations, that needs to be fixed, we can see all of that as well from the advanced cluster security, which is really, a more reasonable approach. And in this particular case, I think this is all I have regarding this. Again, I know this is very high level, but we've only got 30 minutes. And I've tried as much as possible to go through a typical use case. I can see, some things that I probably can talk about. So a few questions that I can talk about. Let me see this quickly. Again, when it comes to implementations, of course, just so many things we need to worry about. So again, yes, HIPAA is one of those things in terms of healthcare. But again, there are also other things, right? We need to be able to process HL7, FHIR messages when it comes to healthcare domains. And this is why we want to be able to use platforms that can actually be compliant. And in terms of HIPAA compliance, for example, I do know that, yes, there's so many solutions out there that does support HIPAA, that's compliant with HIPAA. I don't want to be quoted here, but I believe OpenShift on Microsoft Azure, if I'm not mistaken, is also HIPAA compliant, and I think same as well on AWS. We've got some compliant ones as well when it comes to HIPAA. Again, let me see. I'm just taking a look at the questions I have here. Okay, yeah. So this is pretty much all I have today for this. I hope I've been able to share a little bit of knowledge on how we could go about doing a multi-cloud integration the open source way. Thanks again, everyone, and I'll be looking forward to your questions.
That was an amazing presentation, Suleiman. Love to see Kafka in action, and then your hospital use case was pretty informative. So that gave an end-to-end picture of how things move and how can a developer who's looking to set up a hybrid environment can start for that. We do have a couple of more minutes until our next speaker joins. There we go. He's getting there. So we do have a question and answer session. So that's going to happen after the next session. So stay for that, and then we'll be back and talk more about it. Thanks a lot, Suleiman.
Thank you.
Yep. All right, so we are getting into our last session of this conference, and that is something more about streaming and messaging. And we do have our next speaker who's there. His name is Kasun, and welcome, Kasun, to the stage. I hope you can hear me and see me. So I can start with a introduction of Kasun. So Kasun is a
Okay.
senior product manager at Microsoft, and he's authored lots of books. One being GRC up and running, design patterns for cloud native applications, and many more. Personally, I think I've met Kasun at a meetup in Mountain View. So good to see you back.
Yeah.
And yeah, the stage is all yours. Whenever you're ready to share the screen, you can start.
Sure. Thanks, Rohan. Let me share my screen. Okay, can you confirm whether you can see my screen?
Yes, I can.
Okay, I can get started, Rohan, right?
Sure. Yep.
Okay, great. Thanks, everyone, and thanks for the Kikal community for organizing this conference. My name is Kasun Indusiri. I'm a senior product manager at Azure Messaging team. So at Microsoft, we are building a suite of messaging products. I'm leading one of the event streaming product that we have called Azure Event Hub. So you probably have used it as well. So in this talk, I'm planning to give you an overview of cloud native event streaming architecture. So first we look at what is cloud native and what is event streaming, and then discuss some of the challenges and attributes of cloud native event streaming. All right. So before we jump into the details, like the technical details, let me quickly give you an overview of the business use case for event streaming. So as we build cloud native applications or any type of software application, we usually need to either consume or produce large volumes of data or events. So we produce them continuously, and we have wide array of input and target sources of creating this data. So for example, when you are building applications that process web click streams and anomaly and fraud detection in the case of financial domain, as well as processing application logs, right? And as well as processing data coming from IoT sensors and any other sensor data. And at the same time, things such as real-time ETL, chain data, capture data. So you are processing a huge volume of data, and the main challenge that we have is we need to process this huge volume of data, and we need to respond faster to those events, right? So basically, for instance, if you are analyzing a web click stream, you need to incorporate that feedback directly into your application and improve the overall end-to-end experience. So if you are building a financial application, you need to instantaneously process data elements and take necessary actions if you detect a fraud. So therefore, event streaming and data ingestion is becoming more and more important in the modern software applications. So the main focus of this talk will be to look at how you can build a scalable cloud native event streaming architecture. All right. So before we go further, let's try to sort of define events and event stream. So as you know, event is something that says it's a fact, right? It's a fact that something has happened at a specific point in time. So, for example, if there is an error log from an application, that is an event. So in the case of a retail use case, creating an order can also be an event. So likewise, event is a fact. And event stream is a sequence of related events that are made available over a certain period. And these events are not necessarily discrete, they may be related. And by analyzing all these different events, you may be able to derive different patterns and identify different
various results, derive various results out of it. And usually this, if you take one event stream, that is usually stem from either one producer or multiple producer context. So if you look at, for example, price updates event stream, that is usually coming from the producers that update the price update in the context of a retail domain microservice. And usually these events repeats and evolves with the time. That's why processing these events and doing event processing gives us some business value, because they are evolving and repeating. And then we can look at the notion of an event streaming platform. Right? So what we talk about is using event triggers, right? Using event triggers as the input source. So it can be data coming from your sensors, it can be data coming from your application. So that is the source of your events. And also as part of the trigger, you are ingesting data or events into a event ingestion engine, which is usually it's we call it an event streaming engine. So this is the place that you can elastically publish all your events, and internally it will store the events in a sort of a event storage. So you can store it to a certain period, store it for a certain period of time, or you can also decide to persist for a long-term storage or a persistent storage. So I'm actually covering different phases of event streaming platform, and I'm also providing an example of from Azure. So here we have all the different event triggers, triggering data, and then we have the event ingestion layer. In Azure's case, it's event hubs, and we have Kafka API available for event hubs as well. So that is the event ingestion and storage. Usually events are stored in a continuous event stream backed by underlying storage. But if you want to store it for a prolonged period of time, then you can also capture or record events into a separate storage service, such as Azure Blob Storage. And once you ingest data into the event ingestion engine, then on top of that, you can create event streaming or event analyzing logics, right? So usually it can be, basically it comprises of consuming all the incoming events from the event ingestion layer, and then reacting to those events. So basically the term stream processing is heavily used in this context. So that's where you have the ability to react to events in real time. And analyzing doesn't need to be real time all the time, right? So once you ingest data and once you process or cleanse data, then you store data in a separate data lake or something, and then you can run different batch processing and other big data processing on top of it. And once you have analyzed and processed data, obviously you can serve them via any other external models and serving tools, such as Power BI in the case of Azure. So this actually defines the end-to-end workflow of event stream processing. In today's talk, I'll be mostly focusing on event ingestion layer, and look at how you can adapt cloud native patterns and technologies to build a better event streaming engine. So before we dive into the details, let me quickly cover some of the terminology related to event streaming engine. So I'm sure most of you are familiar with Kafka and other similar brokers. So I'm using the Event Hubs terminology, but this will be very similar across other brokers as well. So if you take any any event streaming engine, what you can see is you have producers, you have consumers, and then you have sort of entities or topics, right? So the topic is sort of a uh, mapping between the business context and the internal representation of that context within the event ingestion engine. And inside a topic, you can further scale it down to partitions. So partitions is a mechanism. It is similar to a lane in a freeway. So you can add more lanes to support more throughput. Similarly, if you want to scale the topic further, you add more and more partitions. And starting off with the producer side, you have producer applications sending data to the event hub or event streaming engine. And usually we support multiple protocols, right? You can ingest data using Kafka, AMQP, HTTPS. Likewise, you can use any ingestion protocol to publish data. And when you're publishing data, you can either select to use a partition key. So it's like using the partition key, we determine how the data is being distributed across all these partitions, right? So if you don't use partition key, it will use the round robin scheduling mechanism. It will distribute data across all these partitions. And if you use specific partition key, that means you can send data, you can basically organize data using that partition key within one partition. So if you're using partition key, then all the events that use the same partition key are stored in ordered way in a given partition. So at the consumer side, consumer is we represent multiple consumers under one consumer group. So consumer group has the view of the entire topic, and they are sort of load balancing, they are sharing all these topic among the receivers of that consumer group. So consumer group will receive data from the entire topic, and one receiver usually consume data from a given partition only. So we don't really share data between two receivers of the same consumer group for a given partition. So this terminology will be helpful in identifying certain characteristics of cloud native event streaming architecture. So that's why I want to dive into that. Now, then the main term that we have to define is cloud native. So this is sort of a overloaded term these days, but in the context of event streaming and other applications, we can define cloud native as a mechanism of buildings of the application as a collection of independent, loosely coupled business capability oriented services. So if you're familiar with microservices, I'm sure you will find most of the terms familiar because it is all about building an independent service which is loosely coupled and you don't have any direct dependencies with other services. And also cloud native application should be able to be automated. You should be able to automate the application life cycles, as well as it should be scalable, resilient, and they should be observable as well. So if we try to understand the notion of a cloud native event streaming architecture by looking at that definition, I think the first thing we need to look at is some of the drawbacks of the conventional non-cloud native event streaming technologies. So if you have ever used Kafka production cluster on-prem, you will understand most of the limitation that I'm saying, right? So usually event streaming platforms are extremely hard to scale. They are really complex to set up, as well as really expensive to maintain. And also the things such as making it high available, make sure that it has disaster recovery. So all these things are really hard when you are dealing with a conventional on-prem event streaming platform. So what is meant from a cloud native event streaming platform is it should be a fully managed event streaming service that is composable, scalable, performant, resilient, and highly available and observable. So we should have all these characteristics in a such a cloud native event streaming service. So in the next part of the presentation, I'll be diving into the details of different characteristics and maybe give you some examples on how these things are achieved in Azure. All right, so let's look at some of the key characteristics of cloud native event streaming services. So as we discussed earlier, elastic scaling is one of the main driving force behind building a cloud native event streaming platform. So the main reason is the volume and the rate that you are ingesting to an event streaming engine is not, it's really hard to predict, right? So you may get data bursts at times, and you may get a huge amount of data or large number of data depending on the use case. So your event streaming engine should be able to dynamically or elastically scale. So elastic scaling can be implemented in multiple phases. Obviously, you can allow manual scaling, because if you think about an on-prem Kafka cluster, for example, even manual scaling is hard, right? Adding a new broker to the cluster, it will be a daunting process. But in the case of cloud native event streaming engines, you can allow users to manually scale the deployment via control plane. So if you need a certain number of scaling units, if you're using certain number of scaling units and you need to add more, then you can allow users to add more via the control planes. And then the next step would be to make it fully dynamic, like allowing scaling up and down based on the workload. And most important thing is your client application should feel, or at least the service should appear to be infinitely scalable. Although infinitely scalable is not possible practically, but internally the provisioning of resources behind this should happen behind the scenes. And when it comes to scaling, we only talk about like large scale, like more granular level scaling by looking at allowing users to add more scale units and so on. But if you look at one topic or one entity, you can always scale them up by adding more partitions or shards. So in this case, when you add more partitions to a given topic, you can easily scale your producers and consumers. And as a cloud service, we should be able to allow users to add partitions or change the partition count dynamically. The other attribute that we have in cloud native event streaming platforms is multi-protocol, right? These engines are they should be able to ingest and consume data using different protocols. So usually there are two aspects of multi-protocol. So supporting native protocols for event ingestion, things such as AMQP, Kafka, and even Pulsar. So that is one aspect of being multi-protocol, because you have the event streaming engine, and you can bring in your existing Kafka, AMQP, or Pulsar application without doing any code. That will be really useful for all your client applications, right? You don't really have to spend time on modifying them to be able to send data to a event streaming engine. And at the same time, you can also further expand the capabilities by easily connecting your event streaming engine with other systems. For example, if you're familiar with Kafka Connect, you can find pretty much API connectors to different APIs, right? You can JDBC, MongoDB, Cassandra, and so on. There are various set of source and sink connectors that you can leverage, and you can ingest and consume data from Kafka via those connectors. So therefore, having native protocol support is also important, because usually these connectors, they work in a certain way that because these protocols are actually optimized for event streaming. Rather, these are more or less acting as just a connector and just to push data. So having native protocol support versus connector support is also equally important. Then performance of an event streaming engine is also critical. So usually when you think about performance, especially on-prem versus cloud, you usually think that you will get far better performance with on-prem compared to cloud services. But at least when it comes to event streaming, that may be not the case, because most of the event ingestion services out there are fully optimized for better performance as well. So if you look at the performance aspect of a event streaming engine, we have several areas to consider. So first one is ingestion throughput. So this is the peak stable producer throughput that you can achieve from a given event ingestion engine. So usually this is measured in megabyte per second or gigabyte per second. If your cloud service is dynamically scaling and it is not using reserved capacity model, usually you don't really have to worry about it, right? You can send 10 megabyte per second, and next time you can send 20 megabyte per second, then it will automatically scale. But if you are using some sort of a provision capacity model, this is an important metric. Then the other aspect is latency. So there are two latency measurements that you can keep an eye on. Obviously, the publisher latency. Publisher latency is the latency between publishing data from your producer application to the event streaming engine, and if the engine successfully replicate and acknowledge the producer, that is the end-to-end, that is the latency that you will measure as part of the publisher latency. But the other important metric is end-to-end latency, where you measure the latency from producing the data and consuming at the consumer side. This is complete end-to-end latency, which involves latency incurred from the network, the processing latency of the publisher event stream engine, and the consumer side latency as well. So usually end-to-end latency is measured when comparing event stream engine performance. And when it comes to performance tuning, most of the cloud native systems, you don't really have to worry about performance tuning at the service side, because everything is configured and tuned behind the scenes. You usually have to only worry about the client side optimizations. For example, if you are using Kafka API, things such as configuring proper batch sizes, link milliseconds, and acknowledgement would be the performance tuning parameters that you have to worry about. But if you're using an on-prem or a conventional event streaming platform, you have to worry about so many things, right? Infrastructure, cluster management, load balancers, and all the other performance tuning parameters. And when it comes to performance tuning of event stream engines, we usually there aren't many standard tools out there, but possibly one of the most popular one is open messaging benchmarking, which is a open source Linux Foundation open source project that is designed for measuring the performance for these event stream engines. This includes other messaging services as well, things such as RabbitMQ as well. But this is a great tool to measure the performance of your event streaming engine. Quick overview of, in fact, quick stats on some how Event Hub's performance numbers. So there are some numbers that we have recently collected related to event hubs. So this is where we recently introduced a new products queue targeting achieving better performance numbers. So if you think like you can get 10 millisecond latencies only with on-prem deployment, you will really find this interesting, right? This is from our latest queue that we recently introduced. You can see we continuously get less than 10 millisecond of latency for both Kafka and AQP workloads, and this is also predictable across the board. And we alter the ingestion throughput from 1 megabyte to 10 megabyte, and we were able to achieve the same numbers, same millisecond level latency. So this is just an example. So you can use tools such as Open Messaging Benchmark to benchmark all the available cloud native event stream engines. All right. So the next point is on multi-tenanted PaaS environments and how we do workload isolation. So usually when you are using a cloud native event streaming engine, you are usually using a multi-tenanted PaaS environment. There are certain options that certain cloud providers provide, including Azure, that you can have your own tenant, which is not shared between other tenants. We usually call it a dedicated cluster. So you can go for that option, but for the most parts, most economical one would be to use a shared multi-tenanted environment. So one of the main possible drawback of using this kind of a multi-tenant environment is cross-tenant interference, right? You need your workload to be isolated, so you need to have minimum cross-tenant interference, and you need to make sure that your workload is fully secured and you get predictable latency, predictable low latency, preferably for the most part of the operations. So that's why workload isolation in a multi-tenanted PaaS environment for event streaming engine is really critical, because as I said earlier, you are ingesting a large volume of data, and if you are ingesting that kind of burst, how that will impact other tenants in the same cluster. So in the case of event hubs, we, again, as part of Premium, we introduce a new approach where you can have your reserved compute and memory capacity, but still you operate inside a multi-tenanted environment. And with this approach, we were able to minimize the cross-tenant interference and improve the predictability. And by default, we secure data by encrypting during data at rest is always encrypted. So we ensure that security is guaranteed within this multi-tenanted PaaS environment. So this is something that you need to keep an eye when you are selecting an event streaming platform: the cross-tenant interference, security, predictability. So you can certainly do several tests to measure various cloud services and see their performance. And then this point is about high availability. So you want event streaming engines to be highly available, right? And there are two aspects of high availability. First one is replicas. So basically within one cluster, how do you achieve high availability? For example, if you take one partition in an event streaming engine, such as Kafka or even event hubs, the data reside in one partition is being replicated across several other broker nodes. So one such broker or one such partition is assigned as the primary, whereas all the other ones are secondaries. And if something goes wrong with the primary, then it will automatically elect a new primary, so that your client application seamlessly switch over to the new primary without noticing any changes, and because the data and state is preserved across all these different secondaries. So that is usually with most of the event streaming engine, this feature will be available. But again, in the case of Kafka, you need to make sure that you have to have the required replication factor configured if you are deploying it on-prem. But if you're using the cloud services, you don't really have to worry about it. And so the related configurations are in-sync replicas and X count in the producer side, right? So you will only get the acknowledgement if you configure X to be all. Producers will only get the acknowledgement once that is replicated across all the replicas. And another way of achieving availability, especially with all the cloud vendors, is using availability zones. An availability zone is it's reside within one region, but those are 3 physically separated data centers, right? Those are, for example, you can have West US as the region, but you will have 3 physically separated data centers within West US. And data is seamlessly replicated across all these 3 data centers, and actually your client application can completely stay agnostic of the existence of availability zone. So it's not that you really have to use any zone specific endpoint that is completely transparent from your client application. You just need to enable availability zones for your cloud service, and client application can seamlessly switch over between these different data centers without even noticing it. A related extension to the high availability is disaster recovery. So with high availability, we talk about one region, right? One region having 3 physically separated data centers. But how about if the entire region goes down? This will be probably an rare situation, but if the entire region of West US goes down, how do you achieve disaster recovery? So this is about having another region as the backup region. So we have one main region as the primary, and then you have another region as the secondary. And even ingestion service needs to take care of several things here. So you obviously need to replicate metadata from your primary region to the secondary region, as well as you need to replicate any event data, any access control list, or any user management data with the secondary region, as well as if you're using consumer state, right? Things such as offset and offset committing features, then that particular offset needs to be replicated in the secondary as well. So in the case of a disaster recovery, when your client applications are switching over to the secondary region, the state of the client application, the offset should also be translated as it is. So at the moment, there are few cloud services that are supporting this feature, including Azure Event Hubs. We currently support metadata replication across 2 geographically separated regions, and the data replication also can be done as an external feature for the time being. And so again, this is not disaster recovery is not something you should rely on if you have to enable high availability. This is purely to overcome any catastrophic events of an entire region failure. But if you just need high availability, just stick to using AZs and other replica related HA features. And then moving on to stream governance, when you are running a cloud native event streaming system, you need to have some insights into the data that you are producing and consuming. So in order to ensure that data that you are publishing to a event streaming engine comply with certain schemas, certain structured types that you use in your application, you can use a schema registry. The main purpose of a schema registry is it's an integrated product to your event ingestion engine. so that you can your client applications can use the schemas residing in the schema registry and use them to deserialize data to event ingestion engine. So along with the data that you publish to the event streaming engine, you can also append some schema information. So when the consumers are reading that data, they want to deserialize it, but they want to verify, they want to retrieve the schema associated with that data payload from the schema registry and then use that to deserialize the message. So with this approach, you can make sure that producers and consumers are using a standard schema defined in a central repository, and schema registry can allow different types of schema evaluation techniques such as forward or backward evolution and forward and backward compatibility. So depending on the compatibility type, producers and consumers can evolve at different rates. A related feature is schema lineage. This is where you get a bird's eye view of how your event streams are consumed and used across the different pipelines of your event streaming platform. So stream lineage is also an important aspect. So I hope that gives you some good context into technical details of event streaming engines and selecting event streaming platforms for the cloud native architecture. But one other thing that we have to keep an eye on is cost efficiency. So usually most of the event streaming engines support one or more cost models. Either they are pay as you go or you have to rely on reserved capacity. So pay as you go means you are basically not provisioning any resources by yourself. You just pay for the usage. So this can be ideal if you have fluctuating workloads. So you cannot really predict the workload rate or workload capacity. This might be the best option, but this is not necessarily the cost efficient one, right? So reserved capacity is ideal when you have better understanding about the workload that you expect. For example, if you are pretty sure that you will not go beyond certain capacity limits such as 10 megabyte per second, then you can use the reserved capacity model. And this can be also cost efficient when you have very high workloads, right? If you, for example, if you have to do 10 gigabyte per second ingress, and going with pay as you go might not be the best option. Maybe it's the most expensive option, right? So if you have like a predetermined capacity already in place, then select the reserved capacity model and allocate the required number of units you need. So again, the bottom line is you have to be cautious when it comes to selecting the cloud service and look at the cost comparison across the cloud services and see what is the most suitable one, what is the most economical one compared to the features offered from the cloud service. Here are some resources for Event Hubs. So most of the concepts that I explained here are common for most of the cloud services, including Azure Event Hubs, and even Kafka has a lot of good materials on explaining this concept. So if you have any questions, feel free to reach out to me via Twitter or LinkedIn. And finally, thanks again for the Geekle organizing committee to organizing this conference. I appreciate your efforts.
Thank you, Kasun. That was a super informative session, very detailed on ingestion and the other technologies or the things that a customer should look at while buying the solution or building one. So thanks a lot. So let's get in the other speakers to start our question and answers. So I'm going to add Rob, and then there is Suleiman. We are still waiting on the the fourth speaker to join, but we can get started. So, Rob and Kasun, what do you feel about this event? Like, did you guys get a chance to watch the other slides in the WSAS that was
I
happening?
didn't get to watch very many talks, but I love the diversity of topics. I think this is a great chance to bring all of us together to talk about really interesting things. Thanks for collecting us.
Sure. Yep. Absolutely. Yeah. It's all about Geekle and the support that they are doing, and then they are still running the show, so that is very commendable.
Yeah.
So great job.
Yes.
Yes.
Yeah.
Let me kick off. Yeah. Go ahead, Kasun.
Yeah, I was about to say they are running this under extreme circumstances. So again, we should be really grateful for that.
Yep. What about you, Suleiman? Did you get a chance to look at the presentations that happened over the last couple of days?
Yes, I've been able to have a look at a few, and it's been really interesting. The diversity of topics, the wealth of knowledge, it's just phenomenal.
Yep, absolutely. So let me kick off with a common question to all. So in terms of data, what are the challenges that the tech industry faces when they're building solutions like the Event Hub or hybrid cloud solutions? So what do you guys feel about it? Anyone can go first on this one. So
I'll go.
Go for it.
A lot of what we've done historically is just gather all the data we possibly can and then look through it later. And we've learned that regulation and privacy don't really fit with that model. So what are the concerns that we hit now? Regulation, data sovereignty, data storage, size of capacity of storage in times, but probably more so making sense of it. How can I learn from the data that I have and use that to improve my products?
So the telemetry side of things as well, probably.
Exactly.
Absolutely, I agree on that. Kasun, you were.
Yeah. Yeah, so I think similar to what Rob said, I think we used to process data, like store data and process it after a relatively long time, right? Maybe a few weeks or days. But now I think it's becoming more and more important to process data as and when it happens, like real-time processing. We are seeing so many use cases that we need real-time processing and taking actions against that. So I think that's why it's becoming like end-to-end event processing, as well as still the batch processing and other technologies are still there, but real-time processing is becoming more important.
That's true. That's very true.
Right. Let me just quickly add to this. Really, I think one of the things I've seen when it comes to data, one of the things I've seen for the clients I work with, particularly, again, I work with clients within bank financial services, healthcare, and public sector. And when it comes to data, we can all agree that these clients, they don't play around. There's always one policy or one standard to abide by. And there's always concern, with data residency requirements, how this data should be processed. And so that's typically one of the first things that we do really to really understand how we can use that data and where we can actually have those data reside. So yeah, so that's one of the challenges, which is not always very easy to solve.
Sure. Yep. Completely get it. Yep. On the similar lines, there is another question. So, what do you guys feel about it? Data and streaming, do they correlate to each other? And yeah, what's your take on it?
Yeah, probably I can take that one. So usually what we are seeing like a database and an event stream are sort of related things, right? So basically database records the state of the certain things, whereas stream is all about state changes. So if you are familiar with the concept of change data capture, so I would say database is the end product, whereas stream is what has happened in the past. So by looking at the stream, you can actually recreate the database state by processing a stream. So Those are very much going hand in hand. But I would say, depending on the use case, you can definitely have use cases that you will require database, whereas out of that database, you can also generate a stream using CDC.
Yeah, that's an interesting use case. I've heard about KSQL and the use of
Mhm.
it, so pretty
Yep.
useful. Yep.
Yep.
Yeah, what do you think, Rob, about that?
What I think is really interesting about an event stream is it's kind of a database turned on its head. It's the transaction log without the storage.
Yes.
And that's kind of brilliant in some circumstances. When I want the latest events more so than the current version, then an event stream can be perfect. Event streams are also really great ways to connect systems together asynchronously when I just want to publish the events as they happen and consume them whenever I get to it. So
Sure.
I think event streams are a really excellent solution for some data problems. Now, they're definitely not the golden hammer. I'm not going to replace all my databases with event streams, but event streams are really intriguing, and I'm glad that they're gaining popularity and traction within the enterprise and within business.
Sure. Yep. Completely get it. Yep. I think the next one is I'd like to ask this to Suleiman. So, what actually is a Red Hat Advanced Cluster Security and Management? So, could you
Yeah,
throw some light on that?
yeah, that's a very interesting question. So, again, really, when we have multiple clusters of OpenShift Kubernetes, it can get really complicated to manage them. So we want to be able to have a way to really manage our clusters from a single interface. So a typical example is if we want to scale our clusters, we want to delete clusters, we even want to create new clusters. We can really do all of that from Red Hat Advanced Cluster Management. So it's just a way really for us to manage our clusters from a single interface rather than having multiple interfaces to manage those clusters. And again, we can see what's happening within our pods. We can see what's happening within our nodes. We can pretty much just have visibility into our cluster the same way we would have if we're working with a single cluster. Now, with advanced security, with Red Hat Advanced Cluster Security, ACS as we call it, really again is a way for us to, from a holistic approach, to really see. Again, we did talk about HIPAA. I know you mentioned HIPAA. You talked about policies. We talked about security policies as well. So now with ACS, Advanced Cluster Security, what that really helps us to do really is to see how our clusters are performing from a security perspective, shows us vulnerabilities, and from there we can really quickly remediate, automate remediation of those issues still from ACS. So again, we can apply policies, security policies, cluster-wide, all across our different clusters from ACS. And so rather than doing it, individually on individual clusters, we can see really what's happening across our different clusters just from within ACS. So when you have a multi-cluster deployment, we have multiple clusters. To ease management of that, you probably want to think about, a way to manage everything holistically, such as advanced cluster management and advanced cluster security.
Got it. Yep. Completely makes sense. Next one is I'd like to ask Rob about the data fabric. So would you want to elaborate more on that? And then what challenges over the time can the industry face on that?
Good question. I haven't dug a whole lot into data fabric, and so I imagine that our definitions may differ. But from what I understand, it's that mechanism of trying to connect multiple data stores together. And I think that's kind of where data mesh has become more the formalization of that concept, where the data stores stay where they are, but we have a central data catalog that we can use to discover them. And I think that's really helpful. Part of what I hope to convey in the talk is that data mesh is a methodology of storing our data, not so much a technology. Where previously, where we were looking at data warehouses or data lakes, where, how do I move my data between things? Data mesh suggests that you leave the data where it is, but you centrally index it so that you can do queries across them. And so it sounds like data fabric is a similar vein in that path.
Got it. Sure. Next question is for probably Kasun. So can the telemetry data be used for scaling up and scaling down? You spoke about the elastic scaling up and scaling down. Can that be used as a factor? And what are the factors are like our inputs to drive that scaling?
Yeah, certainly telemetry data can be used for scaling. So based on our experience, usually the CPU consumption and memory consumptions of a given cluster are most of the most important metrics that we keep an eye on when it comes to scaling. Because the number of events and the size of the events, there are so many parameters involved, and the partition count and various other things when it comes to scaling of event stream engine. So we usually look at like primitive metrics such as CPU and memory when it comes to scaling, because there are so many moving parts in the other part
That's
of
true.
the event stream.
Yep. Yep. It could be driven by events happening. For example, Uber use case where, hey,
Yeah.
there's a game happening in Levi Stadium, and then we need to scale up for that, and completely makes sense. So yeah, that's a great answer. Next one
It
is
really
about
depends a lot on whether you have a compute-bound workload or a network-bound workload or even a storage-bound workload.
Yes.
If you have a compute-bound workload, looking at CPU and RAM is really important. If you have an I/O-bound workload, looking at the request queue length might be a good place to discuss auto-scaling. It really depends on the workload that you have.
Yep. Have you guys seen any tools which are kind of guiding factors, or do companies use their own tool set and then use probably Grafana, Prometheus for generating the data from the, like, basically get the diagrammatic view, and then probably those are the factors. Like, have you guys seen any tools specifically in that are being used to drive this?
Tools to visualize your cluster or tools to facilitate auto scaling?
Both, probably.
Yeah, Grafana is pretty much the standard. Grab Prometheus metrics and stick them in Grafana. But then depending on the type of telemetry that you're looking at, maybe you have a Jaeger dashboard, or maybe you've built your own thing. Maybe you're pushing these events into your SIM, and so now you have a visualization in Elk or Splunk or something like that. Where is the spot where you're already taking action? That's probably the spot that you want to build up your visualizations for your cluster. If you have to log into a different dashboard to see the alarms going off, you probably won't see them until it's too late.
Sure. Yep. That makes sense.
Yeah. Another point is if you are using event-driven application, something that you should look at is CADA, Kubernetes event-driven auto-scaling. So this is mainly designed for application auto-scaling in the event-driven world, where you can use different parameters to scale up. This is only applicable if you are running your application in Kubernetes. Only, but yeah, you don't really have to worry about if you're running it in a cloud service.
Okay, got it. Is that called CADA?
CADA, yeah.
Okay, cool. Yeah, that's informative. I had a question for Suleiman. So you spoke about the hospital use case. So how challenging it is for a customer, like a hospital, let's say, to have a hybrid infrastructure? Like, they have to make those decisions. Okay, this data doesn't go out on cloud. This data does stay on cloud. How can a person, let's say a developer or an implementer, be it a company or a vendor, help them make those decisions easier? Like, is there kind of a metric that is being used, or any other tools that help in that criteria?
Right. Okay. So I guess all of this all comes down to really understanding why a customer would want such architectures, really. And on a typical use case, I mean, a customer would come to you, tell you their problems, and you think about the best possible solution for them. Now, a typical example is a customer comes to me, hey, I want to do OpenShift. And I'm going to start thinking, okay, what are you interested in? Are you concerned about HIPAA? And if a customer also wants to do, let's say, Apache Kafka, for example, I'm also going to want to know if they're also interested in things like HIPAA as well. And what I would say is making these decisions all comes down to again, the customer's requirements. Now, if I know for a fact that a customer is really concerned about HIPAA, I'm probably going to want to start thinking about ARO, which is Azure Red Hat OpenShift, which I know is HIPAA compliance. I'm also going to want to start thinking about OpenShift dedicated on AWS, which I also know is HIPAA compliance. And in terms of Apache Kafka, if they want something that's already HIPAA compliant out of the box, I'm probably going to start thinking about Red Hat ROSAC, is Red Hat OpenShift strings for Apache Kafka. So again, it all comes down to this requirement on what the customer is looking for. And there are also data residency requirements, of course, where a customer would come and tell you they can't have their data leave a particular jurisdiction. In that particular case, an on-prem database might probably even be a better solution if we can't have it within that particular jurisdiction on cloud. So it all comes down to a lot of things, really.
Got it. Sure. Makes sense. Next one is for Rob. So what's your take on, like, you did provide a very good insight on a row store, column store database. Are there any common solutions that a customer can use to solve both the problems?
Good question. For those that may not have seen it, row store is a traditional database where database data is stored in rows. Now, I have different columns of things, but the data isn't sorted that way. It isn't stored that way on disk. By comparison, with a column store, the data is stored by column. Now, my example was if we have a column that includes countries in the world or states in the United States, then that might be a great place where a column store might be helpful. If we have, for example, phone numbers, then that isn't a really good use case for a column store. We could think of maybe column store as like the index inside of a relational database. It's perfect when I want to do bulk reads and do mass analytics on it because the column store will store that data much more succinctly. Are there common solutions between row store, column store, or even other things like NoSQL, blob storage, table value storage, or text search? There are a lot of hybrid databases that start to be SQL plus, or I can do this NoSQL thing, but I also have time series things. I have a different talk called Databases in the Microservices World that digs into this topic quite a bit. And hybrid databases are really intriguing. Or you don't necessarily need the same database in all of the pieces. If you're moving towards a microservice architecture where each microservice owns its own data store, you can have multiple data stores to be able to store the details for this microservice. So maybe you have a column store for some things and a row store for other things, and blob storage for the very large files, and NoSQL data where that makes sense. You know, ultimately, you can start to mix and match these things. In time, we might want to consolidate to a particular set of vendors or a particular set of technologies, and that's where hybrid databases are really beautiful and kind of bringing together the features in lots of places. We're making compromises here, but then store them all in one engine.
Makes sense. Yep, sure. As a follow-up, there is another question for you. Does data mesh store historical data, and what is cloud native streaming? Probably that is a question for all of you guys, if you don't know.
Yeah, I'll take the data mesh one first. Does data mesh store historical data? Yes, that's its purpose, is to facilitate analytical queries across the history within your organization. Cloud native streaming, we could talk about event streaming, and I think we've done a great job highlighting that so far today, where event streaming is kind of the changes of your data over time. So maybe you might want to enroll your event stream in your data mesh as well as one of the data stores. But event streams are typically used to communicate between systems more so than do analysis. And so that may not be the best fit for your data mesh. But the beauty of a data mesh is it is that collection of data in whatever spot, in whatever storage mechanism, in whatever engine makes sense. So store the data where it makes sense, and then analyze it across all of those stores with tools that allow you to gain insights.
Sure. Yep. That is very informational too. I'm just looking if there are any more questions or anything that that we have. Do you guys have? I don't see any more questions coming up. So, do you guys have any closing comments as such? Probably we'll start from Kasun if you don't mind.
Yeah. So, just to give an high level overview, I think we got really good questions on data and data streaming, data governance. So, I think we all agree that data would play a critical role in our software application delivery, right? So I think data mesh and especially data lakes and data warehouses merging as a data lake house, there are a lot of things happening these days. So as just with respect to event streaming and data streaming, I would say that is just a one input to a data lake or a data lake house, but there are other forms of data that are coming in. So it's all about like how to process these different types of data. It can be streaming data. You need to have a separate set of technologies such as Flink and even Azure Stream Analytics and so on to process this streaming data, whereas you have other technologies to process data at rest. So I think there's no like a golden hammer, as Rob said. So you have to pick the right technology for the right job.
Sure. Yep. Completely get that. What about you, Suleiman? Any closing thoughts?
Oh yes. So again, we've interestingly talked about Kubernetes and all of that interesting stuff. And I guess what I would just have to put really say really is, as we start thinking about microservices, Kubernetes, event streaming, and all of that stuff, it really makes sense to not reinvent the wheel. Again, we don't, if there are things out there that we can actually leverage to save us some time, to help us to shorten our development cycles. Really, if it fits our requirements, we really should start looking at those things rather than reinventing the wheel and doing things that have already been done before. Again, so I guess this is really what I have to say about that. And I mean, I know lot of open source projects, open source products that do have, that would really help us to get the task done without necessarily reinventing the wheel. Again, as you know, Kubernetes, Apache Kafka, these are very specialized tasks, requires a lot of time, a lot of effort, a lot of manpower. Again, if we have tools that can really help us to shorten this, we can take advantage of those and we can really focus on writing codes.
Yep. Thank you so much. Yep. What about you, Rob? Any thoughts?
What I think is amazing about data is it is such a valuable and wonderful resource. If we think about 800 years ago, it's likely that I didn't know more than maybe 10 miles around me. 400 years ago, I might have known about data across countries, but it was probably months old. If we think about 50 years ago, I might have known about stuff across the world, but it was still through the lens of whoever was telling the story. If we look at data today, we are connected across the globe live right now. That is amazing, the amount of data that we can consume and create and enjoy. So here's my task then. Are we being responsible with that data? Now, it's amazing for us to have a voice that can transmit across the globe, but are we respecting people's privacy and empowering them, uplifting them? If we're choosing to use these data sources for malicious purposes, to deceive or to oppress, then let's definitely not do that. Instead, let's empower, let's embrace, let's use this data to be able to create wonderful things. Please be responsible for your data. And thank you for joining us here.
Rob, that was an amazing wrap up. Yes. So, four amazing speakers, three amazing panelists to speak with. What an exciting day, I would say. Data, integrations, streaming, messaging. It's been so amazing to be host on this show. So it was great and wonderful to speak with all of you and hear all your thoughts. Thanks a lot for spending some time preparing your slides and sharing it with the entire world. So Really appreciate your efforts and thank you so much. Dhanyavad. So that's what we say in Hindi. And thanks to the Geekle team. And that's about it. So thank you, everyone. Bye-bye.
Thanks for joining us, everyone.
Thank you.
Bye.
Thank you.
Bye.